Maven Architecture. Here you can see the architectural diagram of Maven. Maven is a built automation tool used primarily for Java projects. Maven can also be used to build and manage projects written in C#, Ruby, Scala, and other languages. The Maven project is hosted by Apache Software Foundation, where it was formerly part of Jakarta project. Here in this diagram you can see the these are the various components of Maven architecture. This is a local repository of the local machine that you work on. This this is the central repository, and this the remote repository or the remote web server. So whenever you specify any dependency on pom.xml file of Maven, Maven will look for the file in the central repository. If the dependency is present in the central repository, Maven will copy that dependency into your local machine. But if it is not present here, Maven will fetch it from the remote repository using the internet. So the internet is very much mandatory for using Maven. This is how Maven architecture works. Maven build follows a specific lifecycle to deploy and distribute the target project. There are 3 build lifecycles: default, the main lifecycle as it responsible for project deployment; clean, to clean the project and remove all files generated by the previous build; and site, to create project site documentation. Here you can see the pom.xml and Maven are in build system. Build system interacts with local repository and advisory, and build system interacts with remote repository via HTTP, and build system is connected to site. Here you can see Maven 1x architecture. Here with here basically it is possible to establish parallel Maven builds, one using with old M1 settings and second one with M2 new one. The Maven 2 configuration file names and users have been modified, so the 2 builds should not conflict. With Maven 1.x, X build is configured with following files: project.xml, project object model pom definition, maven.xml custom build scripts, and project.properties general build settings, build.properties local build settings. In Maven 2 build is configured with the different file set pom.xml, pom for definition, and settings.xml local configuration. With regarding migration, the project object model POM has moved from project.xml file to pom.xml. XML schema has also changed from version 3 to version 4. New POM is normally superset of the old, so the first step in creating pom.xml is to copy over the project.xml. Then start tweaking. There are several new elements that can be added to the POM, but all are optional. So should not cause a problem with initial build. If you want to some help converting your project.xml to a pom.xml, you can use Maven-1 plugin. If you run the following command, it will convert your project.xml into pom.xml. The command is men space 1 :convert build.properties and build.properties and project.properties. These files have been replaced with settings.xml. Like with the POM, you can establish a parallel build environment. So the M1 build never breaks while the M2 build is being debugged. Additional local build customizing options can also be created using profiles. So how do I write custom script without maven.xml file? Everything in M2 is a plugin, so for doing any sort of custom work like that, you will need to make plugin. Greatly reduces the complexity with M2 because we only deal with proper plugins. The maven.xml file in M1 was a pseudo plugin essentially and greatly complicated the initial and 2. It promotes sharing of your work right from the get-go. To start with, you will probably write a plugin that is only applicable to your specific requirement or your team's work, but you will see people asking for some functionality and you will go, hey, I have something like that. And hopefully people who have concrete solutions will generalize their solutions so they can be shared with others. That's what we are trying to encourage here. And we establish that there's a lot of work built upon in projects maven.xml that is not being shared, and we would like to try to change that. We plan to make a dead simple share plugin, so hopefully people can use their other projects plugins as a start for a plugin that they need themselves. That's the whole idea of maven.xml to be removed. With directory structure, the POM allows customization of a directory structure in both Maven 1 and Maven 2 using the build tag. For simplicity, it would be ideal to move source from the Maven 2 default structure, but it is not required. You can begin by customizing the directories in Maven 2, and when satisfied that both build paths are working, move to the Maven 2 structure and customize the settings in Maven 1. With plugins, migrating plugins, the main conceptual change in plugins and their use has to do with the concept of a build lifecycle in Maven 2. Instead of using pre-goal and post-goal tags in Maven.xml to tie plugins goals into build process, the goals of the plugins are associated with the predefined stages of the build cycle. And with migrating repositories, every 4 hours, the Maven 1 X repositories is converted over to a Maven 2.x repository, and they were planning to release a plugin based on conversion tool, but currently. And here you can see the build system. The top part consists project.xml and maven.xml. the bottom you can see the Maven, and build system is build system interacts with local repository and remote repository. HTTP is connected back and forth during the interaction between build system and remote repository. Build system is connected to site here. Here you can see Maven plugin architecture. Maven can be considered as a plugin execution framework in which each and every task is conducted through plugins. Maven plugins are used to perform following type of task: jar file creation, war file creation, compilation of code files, unit testing, project documentation creation, project report creation. A plugin in Maven generally delivers a set of goals that can be performed by using this syntax. It is a MVN space and plugin name colon goal name. As an example, we can compile a Maven project with the Maven compiler plugin just by initializing a compile goal after execution. This command MVN space compile colon compile. Here you can see Maven 3.0.5 here, and inside it you can see the basic shell. Inside it you can see command line input parser, class path parser, class path manager, pom parser, Maven plugin downloader, and Maven 3.5 is connected to Maven central Maven repo in this diagram. And here Maven 3.0.5 is connected to local M2 repo. Here these two reports are connected to. Here you can see Maven wagon. Maven wagon is a transport abstraction that is used to Maven's artifact and repository handling code. Wagon defined unified API, and it currently has following providers: file, HTTP, HTTP lightweight, FTP, SSH, and SAP, web dev, SCM in progress. The Maven wagon API, the wagon API component define a simple API for transferring resources, artifacts to and from repositories. Apache Maven wagon providers the Maven wagon file. This component is an implementation of wagon provider for file system access. Maven Wagon HTTP Lightweight. This component is an implementation of Wagon provider for HTTP access. It uses standard JDK classes as lower level layer. Maven Wagon HTTP. This component is an implementation of Wagon provider for HTTP access. It uses Apache HTTP Components Client 4.5.x as lower level layer. Maven Wagon WebDev. This component is an implementation of Wagon provider for WebDev server access. You will need to use at least Java 1.6 if you want to use this Wagon provider. Maven Wagon FTP. This component is an implementation of Wagon provider for FTP access. It uses commands net as lower level layer. Maven Wagon SSH external. This component is an implementation of Wagon provider for SSH server access. Maven Wagon SSH. This component is an implementation of Wagon provider for SCP and FTP access. Maven Wagon SCM. This component is an implementation of Wagon provider for SCM, source control management systems, using Maven SCM. HTTP shared library for Wagon providers supporting HTTP. SSH command library, tools to manage artifact and deployment. Here you can see providers are connected to provider API, and here the provider test and TCK HTTP are connected to provider API. Here the file HTTP lightweight, HTTP WebDev, FTP, SSH external, SSH and SCM and SSH common and HTTP shared are in providers. Here the HTTP lightweight and HTTP are connected to HTTP shared. Here the HTTP is connected to HTTP components. Here WebDev is connected to Jackrabbit. Here the FTP is connected to Commonsnet. Here SSH external and SSH are connected to SSH common, and here SSH is connected to JSCH. Here SCM is connected to Maven SCM API. Here you can see Apache Maven 2.2.x. Maven is a project development management and comprehension tool based on the concept of project object model, build, dependency management, documentation creation, site publication, and distributed publications are all controlled from the declarative file. Maven can be extended by plugins to utilize a number of other development tools for reporting or build process. The distribution. The Maven is a project deployment and deployment management and comprehension tool based on the concept of a project object model, builds, deployment, dependency management, documentation creation, site publication, and distribution publications are all controlled from the declarative file. Maven can be extended by plugins to utilize a number of other development tools for reporting or build process. Compact about the Maven compatibility layer. Maven is a project this is a Maven compatibility layer. Maven toolchains. This is strictly the model for Maven toolchain, so really just plain objects. This is the Maven core. Maven reporting API. Maven error diagnostics provides manage components which will process a given throwable instance through a set of diagnostic subcomponents and return a string message with user-friendly information about the error and possibly how to fix it. Maven mirror. Maven plugin parameter document API. Maven project builder. This library is used to not only read Maven project object model files, but to assemble inheritance and to create remote models as required. Maven plugin descriptor model. Maven artifact. Maven plugin API. Maven artifact manager. Maven repository metadata model. This is strictly the model for Maven repository metadata, so really just plain objects. Maven vegan API. The vegan API component defines a simple API for transferring resources, artifact to and from repositories. Maven profile model. Maven model. This is strictly the model for Maven, so really just a plain objects. Here the Apache Commons CLI. Apache Commons CLI library provides an API for passing command line options passed to programs. It is able to print help messages dealing with the options available for command line tool. Here the distribution is connected to toolchain. and compact. Here the tool compact is connected to the core. Here toolchain is connected to the core and artifact. Here the core is connected to reporting API, and here you can see error diagnosis, monitor, plugin parameter, documenter. Here the core is connected to common CLI. Here the core is connected to plugin descriptor, project, sec dispatcher, and class worlds. Here plugin descriptor is connected to artifact and plugin API. Here the project is connected to artifact manager, profile or settings, and plugin registry. Here the artifact manager is connected to artifact, repository metadata, vegan provide API. Here the profile or settings are connected to model and interpolation. Here the class words, sec dispatcher, cipher, interpolation, utils, and container inside plexus. Here the sec dispatcher is connected to zipper. Here you can see Apache Maven 3.x. Maven is a project development management tool and project development management and comprehension tool based on the concept of project object model. Builds dependency management, documentation creation, site publication, and distributed publications are located from the pom.xml declarative file. Maven can be extended by plugins to utilize a number of other development tools for reporting or build process. Here distribution is connected to SL4J provider and embedder. Here SL4J provider is connected to SL4J API, and embed is connected to SL4J API, compact, and common CLI. Compact is connected to vegan provider API and core is connected to shared utils and plugin API and resolver provider and settings builder. Shared utils are connected to Gency, and Gency is connected to native. Here the plugin type. Here the resolver provide is connected to resolvers here, and IMPL, SPI, API, and util in resolver. There are IMPL is connected to SPI, and SPI is connected to API, and API, and here the IMPL is connected to util, and util is connected to API. Here the resolver provide is connected to repository metadata and model build also, and model build is connected to builder support. And model builder is connected to builder support, interpolation, artifact, and model. Here the settings build is connected to settings and builder support, and interpolation and sec dispatcher. Here the plugins API is connected to model and artifact and plexus. Here the plexus and inject are inside SISU, and plexus is connected to component annotations, class words, and inject. Here the inject is connected to juice, and juice is connected to java x.inject. Here the component annotation, class words, sec dispatcher, cipher, interpolation, and utils are in plexus. Here the sec dispatcher is connected to cipher. Here you can see Maven Apache 4.x. Maven is a project development management and comprehension tool based on the concept of project object model. Builds dependency management, documentation creation, site publication, and distributed publication are all controlled the pom.xml declarative file. Maven can be extended by plugins to utilize a number of other development tools for reporting or build process. Here you can see the Maven Apache 4.x. Here the distribution is connected to SLFJ provider, and SLFJ provider is connected to SLFJ wrap, and wrap is connected to SLFJ API. Here the embedder is connected to SL4J wrap and common CLI. Here you can see BOM. And embed here the embedder also connected to compact, and compact is connected to core. Core is connected to shared utils and plugin API and resolver provider, settings builder, toolchain builder. Shared utils are connected to Jansi. Here the resolver build is connected to IMPL. Here the IMPL is connected to SPI, and SPI is connected to API. Here IMPL is connected to util, and util is connected to API. SPI, API, util, and implementations are in resolver. Here the resolver provider is connected to resolvers here, and repository metadata and model build. Here the model build is connected to model transform, model, and artifact and interpolation and build support. Here the settings build is connected to settings, and here toolchain is connected. Toolchain builder is connected to toolchain model, and it is connected to builder support. And here settings build is connected to settings and builder support and sec dispatcher and interpolation. Here's toolchain build also connected to interpolation here, and model build also connected to interpolation here. Here plugin API is connected to model and artifact. Here the plexus. Here plexus and inject are inside Sisu, and here plexus is connected to crossword and inject. Here inject is connected to use. And here crossword, interpolation, sec dispatcher, and zipper and utils are inside plexus. Here sec dispatch is connected to Cypher. Here you can see default artifact handlers reference. Artifact handlers defined for each dependency type. Information on the artifact classifier, extension, language, and how to manage it as dependency, add to class path, include dependencies. Some artifact handlers are configured by default in org.apache.maven.artifact.handler.providers package. Here you can see a type, classifier, extension, package, language, added class path, include dependency. Here type pom is equal type and none, and here jar equal type and Java and language Java, and class add to class path true. Test jar, test, classifier test, and extension jar, and Java and true. Here Maven plugin jar and equal to type, the packaging, and here Java and true, and here EGB extension is jar and equal packaging equal type and Java and true, and EGP client jar, EGB Java true. Here var and equal to type here packaging and language Java, and include dependencies true. Here EAR extension equal to type and packaging equal to type and language Java. Here ra and RAR and equal to type and here language Java. Here Java source and classifier sources and extension jar and equal to type and language Java, and here Java doc, classifier Java doc, extension jar and packaging equal to type and language is Java, and added to class path equal true. Here you can see Maven sources overview. Each component has its own Jira project or component for issue tracking. Here Maven site. This is the Git repository for content of https ://maven.apache.org. Apache Maven sources manifest to fetch every Apache Maven Git repositories using Google repo, default.xml file, configure the directory structure where the different Git repositories will be put. Here the Maven core IT is the Maven core integration test provide tooling to test every aspect of Maven functionality with any Maven version. Apache Maven Artifact Resolver. Since version 1.7.0, Maven Resolver requires Java 8 to run. For Maven 3.8.x compatible version, read the documentation. Apache Maven Artifact Resolver is a library for working with artifact repositories and dependency resolution. Maven Artifact Resolver and tasks. The Maven Artifact Resolver and task enable build script for Apache Ant 1.7 plus to use Maven Artifact Resolver combined to Apache Maven Artifact Resolver provider to resolve dependencies and install and deploy locally built artifacts. Maven plugins, available plugins. Maven is at its heart a plugin execution framework. All work is done by plugins. Looking for a specific goal to execute, there are build and reporting plugins. Build plugins will be executed during the build, and they should be configured in the build element from the pom, and reporting plugins will be executed during the site generation, and they should be configured in the reporting element from the pom. Because the result of a reporting plugin is part of the generator site, reporting plugin should be both internationalized and localized. You can read more about localization of about the documentation about localization. Core plugin, the plugins corresponding to the default core bases, that is clean, compile. They may have multiple goals as well. Clean up after the build. Compiler compiles Java sources. Deploy the build artifact to the remote repository. Install the build artifact into the local repository. And fail-safe, run the JUnit integration test in an isolated class loader. Here the install the build artifact into the local repository. Resources, copy the resources to the output directory for including in the jar. Site, generate a site for the current project. Surefire, run the JUnit test in an isolated class loader. Verifier, useful for integration tests, verifies the extensions of certain conditions. Packaging types or tools. These plugins relate to the packaging respective artifact types. EAR, generate an EAR from the current project. EJB, build an EJB, an optional client from the current project. jar, build an jar from the current project. RAR, build an RAR from the current project. WAR, build an WAR from the current project. App client or ACR, build an Java EE application client from the current project. Shed, build an Uber jar from the current project including dependencies. Source, build a source jar from the current project. JLink, build Java runtime image. Jmod, built Java JMod files. Reporting plugins which generate reports are configured as reports in the POM and under the site generation lifecycle. Changelog, generate a list of recent changes from your SCM. Changes, generate a report from an issue tracker or change document. Check style, generate a check style report. DOP, generate a description of project DOAP file from POM. docck, documentation checker plugin. Javadoc, generate Javadoc for project. JDEPs, run JDK JDEP tool on the project. JXR, generate a source cross reference. Link check, generate a link check report of your project documentation. PMD, generate a PMD report. Project info reports, generate standard project report. And Surefire report, generate a report based on the result of a unit test. And tools, these are miscellaneous tools available through Maven by default. Here you can see ant, and here the ant run. Run a set of ant tasks from the pace of the build. And artifact, manage artifact task like build info, artifact type, archetype, generate a skeleton project structure from the archetype. Assembly, build an assembly distribution of sources and or binaries. Dependency manipulation, copy, unpack, and analysis. Enforcer, environmental constraint checking, Maven version, JDK, etc. User custom rule execution. GPG, create signature for artifact and POMs. Help, get information about working environment from the project. Invoker, run a set of Maven project and verify the output. JSigner, signs and verify the project artifacts. JDEP, DEPR scan, run JDK JDEPR scan tool on the project. Patch, use GNU patch tool to apply patch files to source code. PDF, generate a PDF version of your project documentation. Plugin, create a plugin descriptor for any modules found in the source tree to include in the jar. Plugin report, create a plugin documentation for any modules found in the source tree. Release the current project, updating the POM and tagging in the SCM. Remote sources, copy remote sources to the output directory for the inclusion in the artifact. SCM, you can see repository, and here the SCM, execute SCM command for current project. SCM publish your Maven website to SCM location. Scripting, Maven scripting plugin wraps the scripting API according to JSR 223. Stage, assist with the release stage and promotion. Toolchains, allows to share configuration across plugins. And wrapper, download and unpack the Maven wrapper. There are some retired plugins. Here the ant, generate an ant build for the project, and Eclipse, generate an Eclipse project file for the current project. And idea, create an update idea workspace for the current project. Individual modules are created as idea modules. The one and a plugin interact in legacy Maven 1.x repositories and build. Reactor, build and subset of independent project in a Reactor Maven 2 only, and repository plugin to help the repository based tasks. Here you can see site and sources. Here the core Maven, core ITs, resolver and task. In plugins you can see core packaging, reporting and tools. With core you can see clean, compiler, deploy, install, resources, site, surefire and verifier. With packaging ER, EJB, jar, var, ICR, shade, source, JLink, JMod. Reporting changelog, changes, check style, DOP, docck and javadoc, jdeps, jxr, link check, pmd, project info reports. With tools you can see ant run, archetype, assembly dependency, enforcer, gpg help, invoker, jar signer, jdpr, scan, patch, pdf, plugin, release, remote resources, repository, cm publish, scripting stage and tool jars. With doxia you can see doxia site tools. With site and site, here the tools converter, link check. Here miscellaneous archetypes, poms, skins, studies, indexer, vegan, plugin, testing, disk tools. With Jenkins, env and lib. Here the shared, you can see achiever, artifact resolver, artifact transfer, artifact filter, dependency analyzer, dependency tree, downloader, file manager, filtering, invoker, JASigner, mapping, OSGI, projects, utils, reporting, API, reporting, EXE, reporting, IMPA, repository, builder, runtime, script interpreter, incremental, IO, char, resources, util, verifier. With Plexus you can see utils, components, class, words and Modello. Now we are considering dependency mediation in transitive dependencies. The dependency mediation, this determines what version of an artifact will be chosen when multiple versions are encountered as dependencies. Maven picks the nearest definition, that is, it uses the version of a closest dependency to your project. Maven picks the nearest definition it uses version of the closest dependency to your project in the tree of dependencies. You can always generate a version by declaring it explicitly your project poms. Note that if two dependency versions are at the same path in the dependency tree, the first declaration wins. The nearest definition means that the version used will be closest one to your project in the tree of dependencies. Consider this tree of dependencies. In text, dependencies for A, B, C and C are defined as A to B and B to C and D 2.0 and A to E and E to D 1.0. Then the D 1.0 will be used when building, because a path from A to D through E is shorter. You would explicitly add a dependency to you could explicitly add a dependency 2.0 in A to force the use of D 2.0 as shown here. Now we are considering the dependency scope. Each of the scopes except import affect transitive dependencies. Dependency scope is used to limit the transitivity of a dependency and to determine when a dependency is included in a class path. There are 6 scopes. Compile, that this is the default scope used if none is specified. Compile dependencies are available in all class paths of a project. Furthermore, those dependencies are propagated to dependent projects. Provided, this is much like compile but indicates you expect the JDK or a container to provide the dependency at runtime. For example, when building a web application for Java Enterprise Edition, you would set dependency on the servlet API and relate related Java EE APIs to scope provided, because the web container provides those classes. A dependency with the scope. This scope is added to the class path used for compilation and test, but not for runtime class path. It is not transitive. Runtime, this scope indicates that the dependency is not required for the compilation, but for the execution. Maven includes a dependency with the scope at runtime and test class paths, but not the compile class path. Test, the scope indicate the dependency is not required for normal use of compile application, and is only available for test compilation and execution phases. The scope is not transitive. Typically, this scope is used for test libraries such as JUnit, Mockito. It is also used for non-test libraries such as Apache Commons AI, IO, if those libraries are used in unit test, src/test/java, but not in the model code for src/main/java. System, the scope is similar to provided, except that you have to provide the jar which contain it explicitly. Artifact is always available and is not looked up in the repository. Import, the scope is only supported on the dependency type pom on the dependency management section. It indicates the dependencies to be replaced with the effective list of dependencies in the specified pom dependency management section. Since it is replaced, dependencies with the scope is import do not actually participate in limiting transitivity of a dependency. Each of the scopes, except for import, affect transitive dependencies in different ways. It is demonstrated in the table here. If a dependency is set to the scope in the left column, the transitive dependency of that dependency is with the scope across the top row results in the dependency with the main project with the scope listed at intersection. If no scope is listed, it means the dependency is omitted. Here you can see compile is compile and runtime, and he provided and provided with runtime is provided and runtime is runtime here, and the test is with compile test, and with compile test runtime is test. Here you can see how do optional dependencies work. The diagram here says the project A depends on project B. When A declares B as an optional dependency in its pom, this relationship remains unchanged. It's just like a normal build where project B will be added in project A's class path. When another project X declares project A as a dependency in its pom, the optional nature of the dependency takes effect. Project B is not included in the class path of project X. You need to declare it directly in the pom of the project X for B to be included in X's class path. Now we are considering how dependency exclusion works and when to use it as a last resort. This diagram shows that the project A depends on both project B and C. Project B depends on project D, and project D depends on both E and F. By default, project A's class path will include B, C, and D, E, and F. Suppose you don't want Suppose you don't want project D and its dependencies to be added to project A's class path because some of the D's dependencies are missing from the repository, and you don't need the functionality of B that depends on project D's anyway. Project B's developers could mark the dependency on project D optional true. And if you deploy project A to a repository and project X declares a normal dependency on the project A, will project D still excluded from the class path? The answer is yes. The project A has declared that it doesn't need project D to run, so it won't be both in as a transitive dependency in project A if you declare if you remove it from the class path. Now consider the project X depends on project Y as in the diagram here. Project Y also has a dependency on project B, and it does need a feature supported by project D. Therefore, it will not place an exclusion on project D in its transitive list. It may also supply an additional repository from which it can resolve the project E. In this case, it is important that project D is not excluded globally, since it's a legitimate dependency of project Y. Another scenario, suppose dependency you don't want is project E instead of project D. How do you exclude it? See the diagram here. Exclusion work entire dependency graph below the point where they are declared. If you want to exclude project E instead of project D, simply change the exclusion to the point at project E, but you don't move the exclusion down to project D. You cannot change project D's POM. If you could, you would use optional dependencies instead of exclusion. So split project D up to multiple subprojects, each with nothing but normal dependencies. Here you can see the built extension class loaders for every plugin which is marked with extensions true, and every built extension listed in the according to the section of the POM, there is a dedicated class loader. Those are isolated, that is, one built extension does not have access to other built extensions. It imports everything from API class loader. All JSR 330 or Plexus components declared in the underlying jars are registered in the global Plexus container while creating the class loader. In addition, all component references in the plugin descriptor are properly wired from the underlying Plexus container. Built extensions have limited effect as they are loaded late. Here you can see the platform aggregates Bootstrap and Bootstrap aggregate built extension. Here the core extension aggregates API aggregates built extension. Here you can see a Maven home /boot here, boost for the Bootstrap, and here API just composition of all core extensions. Here per gav of plugins loaded with extension true or built extension. Here you can see a plugin class loaders. Each plugin which is marked as build extension, has its own class loader that imports the project class loader. Plugins marked with extension true leverage the build extension class loader instead of plugin class loader. Users can add dependencies to this class loader by adding dependencies to a plugin in the plugin section of their plugin.work of their project pom.xml. Here you can see a core extension aggregates API, just composition of all core extensions and API aggregate project, and here the build extension per gav of plugin ordered with current extensions true or build extensions aggregates project, one per Maven pom project aggregates plugin and plugin aggregates project, and here the platform aggregates bootstrap aggregates plugin. Here the per gav plugin. Here you can see differences between Maven 3 and 4. The table here illustrate multiple scenarios which have changed between Maven 3 and 4. They assume the project structure as depicted here. Here you can see the here dependencies and blue color, and this color you can see the parent child. This is parent and these are child relationships. Here this scenario, the build an aggregator and its children, and the outcome in order is module C, module 1 and module 2. The command is here, the Maven compile here. Module Maven compile -pl module C, module C1 and module C2. In Maven 4, Maven compile -pl module C with built an aggregator and ignore its children. Outcome in order is the module C, module C1 and module C2. The command is here with Maven 3 Maven compile -pl module C, with Maven 4 Maven compile -pl module C-n. Also make dependencies outside of the current scope. Here the outcome is in order is parent, module A, module B, module C and module C2. Maven 3 is not available, and Maven 4 CD module C module C /module C2 ampersand and Maven compile -am. Also make dependencies outside of the also make dependent outside of the current scope. Here the outcome is module A, module B and module C2. Maven 3 is not available, and Maven 4 it's CD module A ampersand and Maven compile and dash AMD. Resuming from a module and built all dependencies, parent module A, module B, module C, and module C2 not available. In Maven 3 and Maven 4, Maven compile dash RF colon module C2 dash AM or Maven compile dash R dash AM. The run specific goal on one submodule with dependencies from project, module C2. Maven install ampersand Maven jetty colon run dash F module dash C and / module dash C2. Maven compile ampersand Maven jetty colon run dash F and module / module C / module C2. Here you can see the Maven repositories. Apache Maven uses repositories to store artifacts. Your dependencies are being downloaded from repositories. And artifact you built are being installed, uploaded into repositories as well. This is one of the fundamental concepts of Maven since its inception. Maven command line tool and Maven repositories are molded together and developed since the beginning of Maven project itself. As you may know, Maven addresses artifact using artifact coordinates. The artifact coordinates uniquely describe the artifact you are referring to, but all does not tell anything about its source or origin. This is where Maven repositories come into picture that holds the artifact laid out, published according to Maven repository layout. And this is where the circle closes. Artifact being laid out in defined layout, consumed and published by Maven. Here you can see the users here in the central, the default, and here the Maven is connected to central minus and a local repository manager and local repository and independent public repositories. Here the Maven is connected to the central default, and here the Maven is connected to mirrors, and here the Maven is connected to repository manager via settings.xml mirror off tag. Here the repository manager is connected to mirrors and central and independent public repositories via cache. Here the repository manager is connected to private data, and here the Maven is connected to local repository, and here Maven is connected to independent public repositories via pom.xml repository and plugin repository. Here you can see JBoss is in independent public repositories. Here the Maven repository manager, private data and local repository are in users. Here you can see Maven central repository. Here we are considering this is for those who that need to use or contribute to Maven central repository. This includes those that need dependencies for their own build or project that wish to have their releases added to the Maven central repository, even if they don't use Maven as their build tool. Here you can see a central repository, central CDN and mirrors and central data, central archetype catalog, central index are in central repository. Center repository interact with center repository is connected to project dedicated staging repositories via rsync deprecated x and y. You can see x and y here. The public features multi-project staging repositories are connected to center repository via push. You can see Apache and OSSR H and others are in and etc. are in public features multi-project staging repositories. Here the aggregation these are connected project dedicated staging repositories and public features multi-project staging repositories are connected to central data via aggregation. See, central data interacts with center archetype catalog and central index, and here the central data is connected to central CDN and mirrors via publication. iBiblio and Google are inside mirrors here. Here you can see Maven, Apache Maven Artifact Resolver. Since version 1.7.0, Maven Resolver requires Java 8 to run. Apache Maven Artifact Resolver is a library for working with artifact repositories and dependency resolution. Maven Artifact Resolver deals with the specification of local repository, remote repository, developer workspace, artifact transport, and artifact resolution. It is expected to be extended by a concrete repository implementation such as Maven Artifact Resolver provider for Maven repositories or any other provider for other repository formats. Here you can see demos and Apache. The demos and Antask are connected to transport and resolver provider. Here the Maven plugin and snippets are in demos, and Maven plugin is connected to plugin API. Here the Antask are connected to Ant. Here the plugin API, resolver provider, module builder, model, and repository metadata are inside Maven core. Here the resolver provider is connected to IMPL and model builder and repository metadata. Here the model builder is connected to model. Here the IMPL is connected to SPI, and transport is connected to IMPL is connected to SPI and util here, and transport is connected to SPI and util SPI, and here connect SPI and util, and here the connector basic is connected to util. Here the SPI and util are connected to API. Here you can see test util, and in file, class path, HTTP, and Wagon are inside transport, and Wagon is connected to Wagon here. HTTP is connected to HTTP client. Here you can see Maven plugin tools. Maven plugin tools contains the necessary tools to generate repetitive content such as descriptor, help, and documentation. Here you can see Maven module Maven plugin. Create Maven plugin descriptor for any modules found in the source tree, generate reports, and create help goals. Maven plugin report plugin. The plugin report plugin is used to create reports about the plugin being built. Maven plugin tools generators. Generators, XML descriptor, help documentation used by Maven plugin to generate content from descriptor extracted from sources. Maven plugin tools API, extract API used by Maven plugin to extract Mojo information. Maven plugin tools Java. Extractor for plugin written in Java annotated with Mojo Java doc tags. Maven plugin tools Java doc. Provides doclets to support Mojo Java doc tags in the Java doc tool. Maven plugin tools annotations. Extractor for plugin written in Java with Java annotations. Maven plugin annotations. Provides Java annotation to use in Mojos. Maven Maven scripts. Maven script Mojo support lets Java developer write Maven plugin goals with scripting language instead of compiled Java. Maven plugin tools Bean Shell, extractor for plugin written in Bean Shell. Maven script Bean Shell. Maven Bean Shell Mojo support, that is write Maven plugins with Bean Shell script. Maven plugins tools and extractor for plugins written in Ant. Maven script and Maven Ant Mojo support, that is write Maven plugins with Ant script. Maven plugins tools model, plugin metadata model for script based plugins. Maven plugin is connected to plugins tools API and plugins tools generators. Plugins tools Java and plugins tools annotations and plugins tools Bean Shell and plugins tools Ant are connected to plugins tools API. Here the plugins tools annotations are connected to plugins tools plugin annotations. Here the plugins tools Ant is connected to plugins tools model. Here the plugins tools Bean Shell, plugins tools Ant, plugins tools model, Maven script Bean Shell, Maven script and Maven script Ant are in Maven script. Here the Maven script Bean Shell and Maven script Ant are connected to Maven plugin API. Here the Maven script Bean Shell is connected to Bean Shell and Maven script Ant is connected to Ant. QDocs and ASM and Doxia. Here you can see QDocs, ASM and Doxia. Here you can see plugin descriptors. Plugin descriptor is the first being generated in memory, finally contains some values in HTML format before persisted into 3 different formats. Formats differ in whether they contain extended attributes, not part of plugin descriptor specification, or whether descriptive values contain HTML or plain text. Java docs tags are in general being resolved and replaced by XHTML value before they end up in accordance plugin descriptor attributes, description and replicated. Also Java doc code links via link and C are replaced by links to the according Java doc pages is configured accordingly. Here you can see Maven plugin execution, Maven plugin help Mojo and goal plugin report are in consumers. Here Maven plugin execution is connected to plugin.xml via users plain text. Here the here Maven plugin help Mojo is connected to plugin help .xml plain text via users. Here the plugin.xml plain text and plugin XML plugin help.xml and plugin enhance XML, the HTML are in plugin description serializations. Here the goal plugin report is connected to plugin xdoc generator here via calls. And here the Mojo scanner and Mojo description descriptor extractors are in plugin goal plugin descriptor. Here Mojo scan is connected to Mojo descriptor extractors via calls, and here the Mojo descriptor extractors are connected to plugin descriptor via populates. Here the plugin descriptor plugin xdoc generator is connected to itself via resolves links to javadoc, and here the plugin descriptor files generator is connected to itself via transform javadoc to HTML. Here plugin descriptor file generator is connected to a plugin descriptor via consumes. Here plugin xdoc generate is connected to xdoc via generates. Here the plugin xdoc generator is connected to plugin enhance .xml via users. Here the plugin descriptor files generator is connected to plugin descriptor serialization via writes, and here plugin descriptor file generator, plugin xdoc generator, xdoc and plugin descriptor are in Maven plugin tool generators. Here you can see a high level Maven architecture here. Here Maven creates a local repository with all required dependency files, Java files, Java files when we built a project for first time. This local repository is located in your machine. Center repository is provided by Maven community. This contains the large number of common libraries. If the necessary Java files or dependency files aren't included in the local repository, when Maven downloaded it from the central repository and then copy that to your local repository as well. That's the usage of this kind of build automation tool. As an example, our local repository doesn't have JUnit for 4.10 version, but we add the JUnit version in our pom file as 4.10. Then we build the project. Maven checks the 4.10 version in our local repository. Since it doesn't have it, Maven download it from the central repository and copy to your local repository and build the project successfully. If you don't have Maven, we have to download those files manually. Remote repository is a place where we copy our final packages in a distribution format, so other developers can use that file or for their project requirements. Other than that, the site plugin is used to generate a site for the project, which includes the reports and documentation. When you work with Maven practically, you will understand this architecture well. Here you can see pom.xml and Maven are in build system. Build system interacts with Maven repo, center repo, and remote repo, and build system is connected to site here. Here you can see Maven architecture in a different view. The Maven architecture includes plugin jar, code file, etc. Here you can see project to build and Maven are in local machine. Maven core are in local machine. Here project to build is connected to Maven core, and here the Maven core is connected to plugin, for example jar, and plugin for example Surefire, and plugin for example release. Plugin for example jar, plugin for example Surefire, and plugin example release are in remote repository or local install. Here you can see a Maven architecture in a different view. Here the source code and test script and libraries are connected to build process. Here the build file and Maven is connected to build process, and build process is connected to build reports. And here the build process is connected to build report and deploy artifact.ear.war and project documentation java.uml. Here you can see Maven architecture in a different view. Here here you can see the pom.xml, and it's connected to project object model, and the project object model interacts with dependency management model. Dependency management model interacts with the repositories, local and remote. Here you can see the project lifecycle and phases, and there are plugins. Here the plugins. Here we can see source files, and here the plugins interact with generated files or resources and binaries here, and here the package libraries are there. Here you can see Maven repository types and locations. Maven repositories are directories of packages, package jar files, and with extra metadata. The metadata are pom files describing the project which each package jar file belongs to, including what external dependencies each package jar has. It is this metadata that enables Maven to download dependencies of your dependency recursively. until the whole tree of dependencies is downloaded and put into your local repository. Maven has three types of repository: local repository, central repository, and remote repository. Maven searches these repositories for dependency in the Maven sequence. First in the local repository, then the central repository, and the third in the remote repositories if specified in the POM. Here's a diagram illustrating three repository types and their location. Local repository is a directory on the developer's computer. This repository will contain all dependencies Maven downloads. The same Maven repository is typically used for several different projects. Thus, Maven only needs to download the dependencies once, even if multiple projects depends on them. For example, JUnit. Your own projects can be built and installed in your local repository using Maven install command. That way, your other projects can use the packaged jar files of your own projects as external dependencies by specifying them as external dependencies inside the Maven POM files. By default, Maven puts your local repository inside your home directory in your local computer. However, you can change the location of Maven local repository by setting the directory inside your Maven settings file. Your Maven settings file is also located in your users-home/.m2 directory, and it is called settings.xml. Central repository. Central Maven repository is a repository provided by Maven community. By default, Maven looks in this central repository for any dependencies needed but not found in your local repository. Maven then download these dependencies into your local repository. You need no special configuration to access the central repository. Remote repository is a repository on a web server from which Maven can download dependencies, just like the central repository. Remote repository can be located anywhere on the internet or inside the local network. A remote repository is often used for hosting projects internal to your organization, which are shared by multiple projects. For instance, common security project might be used across multiple internal projects. The security project could not be accessible to the outside world, and should thus not be hosted in public. The central Maven public is the central Maven repository. Instead, it can be hosted in an internal repository, remote repository. Dependencies found in the remote repository are also downloaded and put into a local repository by Maven. Here you can see local repositories and remote repository are in organization internal network. Here you can see the internet and central repository is connected to interacts with central repository interacts with internet. Here you can see which scopes exist. Here you can see distinct class path related to Maven lifecycle phases: project compilation, test compilation, test execution, and project runtime. Here you can see scope decide when a dependency gets included in a class path. Here this lifecycle basis interacts with the compile scope, and here the compile scope. Here the interacts with the runtime scope. Runtime scope includes test compilation, test execution, and project runtime production. Here the provided scope includes project compilation, test compilation, and test execution. Here the system scope deprecated it is include project compilation, test compilation, and test execution. Test scope include the test compilation and test execution. Here you can see a memory structure. Here you can see a standalone public artifact repositories, project dedicated artifact repositories here, and here the Forges multi-project artifact repositories, Apache Codehouse, OSS, HRS, etc. And here you can see Java.NET and JBoss here. Here you can see standalone public artifact repositories are aggregated. He's connected to center data via aggregation. Here you can see central repository. It has central data, index, repo, mirror, and mirrors. Here central data is connected to repo and mirrors via publication. UK and iBiblio and etc. are in mirrors, and here the Maven is connected to repo via central default, and here Maven is connected to mirrors and repository managers via settings.xml or mirror off. Here the repository managers are connected to central repository, and here the standalone public artifact repositories. And here the Maven is connected to standalone forges and multi-project artifact standalone public artifact repositories via pom.xml and repository. Here Maven is connected to local repository, and repository manager and Maven and local repository are in users. Here you can see Maven structure in the top here, the repository manager, then below Maven settings.xml, and below project.pom.xml. Here you can see how Maven works. Here you can see the first Maven is connected to pom.xml via read. Then it's 2 is going through a build, and 3 the Maven is connected to title /m2 / repository, the local repository, via check if artifacts is in local repo. Then the Maven is connected to 4 central repository via get artifact, and central repository connected to Maven via get artifact here again. 5 the Maven is connected to local repository via put download artifact in local repo, and 6 Maven is connected to target via generate files, create jar. Here the pom.xml and target are in project. Here you can see default Maven default lifecycle flow. The default lifecycle flow here, the validate is connected to compile is connected to test is connected to package, and package is connected to integration test is test is connected to verify is connected to install, then install is connected to deploy. Here the validate, for example, the default lifecycle comprises of the following phases here. The validate the project is correct and all necessary information is available. Compile the source code of the project. Test the compiled source code using a suitable unit test framework. These tests should not require the code be packaged or deployed. Package, take the compiled code and package it in its distributable format such as jar. This is integration test, and verify, run any checks on results of integration test to ensure quality criteria are met, and install the package into the local repository for use as a dependency in other projects locally, and deploy done in built environment, copies the final package to the remote repository for sharing with other developers and project. This lifecycle phases plus the other lifecycle phases not shown here are executed sequentially to compile the default lifecycle. Given the lifecycle phases here, this means that when the default lifecycle is used, the Maven will first validate the project, then try to compile the sources, run those against tests, package the binaries, for example jar, run integration test against that package, verify the integration test, install the verified package to the local repository, then deploy the installed package to remote repository. Here you can see Maven, and here you can see repository manager is connected to IDs, Eclipse, IntelliJ or NetBeans, and it is connected to Git conversion, Git or Subversion or Clear Cache, for example. Source control. His source control is connected to continuous integration, Hudson, Jenkins, or Team City, and continuous integration is connected to build tools. Maven Ant or Gradle, and build tools are connected to repository manager. It interacts with recent repository, and repository manager interacts with provisioning tool, Puppet, Chef, or Capistrano, and provisioning tool is connected to servers here. It's kind of organization. Here you can see a Maven dependency management. Enterprise level projects typically depends on a variety of open source libraries. Consider the scenario where you want to use the log4j for your application logging. To accomplish this, you would go to the log4j download page, download jar file, and put it into a project lib folder or add it to the project's class path. There are a couple of problems with this approach. One, this jar file you download might depend on a few other libraries. You would now have to hunt down all those dependencies and other dependencies and add them to your project. When the time comes to upgrade the jar files, you need to start the process all over again. 3, you need to add jar files to source control along with your source code so that your projects can be built on a computer other than your own. This increases project size and checkout and build time for the shared jar files because teams within your organization become difficult. To address these problems, Maven provides the declarative dependency management. With this approach, you declare project's dependencies in an external file called pom.xml. Maven will automatically download those dependencies and hand them over to your project for the purpose of building, testing, or packaging. This figure shows the high-level view of Maven dependency management. When you run your Maven artifact and related metadata from the remote repositories, the default remote repository is called Maven Central, and it is located at repo.maven.apache.org and uk.maven.org. Maven places a copy of this download artifact in its local repository. In subsequent runs, Maven will look for an artifact in its local repository. Upon not finding the artifact, Maven will attempt to download it from the remote repository. Here you can see Maven Central Maven Central interacts is connected to Maven via internet and jars. You can see here the local repository, the Maven and local repository are in local, and here Maven interacts with local repository. Here you can see enterprise Maven repository architecture. With the Maven dependency management works in a majority of cases. It poses few problems with an enterprise environment. The first problem is that the sharing comparative artifact between items is not possible because of the security and intellectual property concerns. You wouldn't want to publish your enterprise artifact on Maven Central. Another problem concerns legal and licensing issues. Your company might want the teams only to use official approved open source software, and this architecture, that previous architecture, the Maven dependency management architecture would not fit for that model. The final issue is concerned the bandwidth and download speeds. In times of heavy load on Maven Central, the download speed of Maven artifact are reduced, and this might have a negative impact on your builds. Hence, the most enterprise employ the architecture shown here. Internal repository manager act as a proxy to remote repositories. This allows you to cache artifact from remote repositories, resulting in faster artifact downloads and build performance improvement. Because you have full control over internal repository, you can regulate types of artifact allowed in your company. Additionally, you can also push your organization's artifact onto the repository manager, thereby enabling collaboration. There are several open source repository managers. For example, the Nexus repository OSS, Apache Archiva, Artifactory open source. Using new repositories. In order to use a new repository, you need to modify your settings .xml file. Here you can see Spring repository and Maven Central and JBoss repository are connected to repository manager via internet and jar. Here the repository manager is connected to Maven, and Maven interacts with local repository, and Maven and local repository are in local, and local and repository manager are in the corporate network. Now we are considering transitive dependencies. Dependencies declared in the project's pom.xml file have their own dependencies. Such dependencies are called transitive dependencies. Take the example of Hibernate core. For it to function properly, it requires JBoss logging, DOM4J, Java assist, and so forth. Hibernate core declared in your pom.xml file is considered a direct dependency, and dependencies such as DOM4J and Java assist are considered your project's transitive dependencies. The key benefit of Maven is that it automatically deals with transitive dependencies and include them in your project. This figure provides an example of transitive dependencies. Notice that transitive dependencies can have their own dependencies. As you might imagine, this can quickly get complex, especially when multiple direct dependencies pull different versions of the same jar file. Maven uses a technique called dependency mediation to resolve version conflicts. Simply stated, dependency mediation allows Maven to pull the dependency that is closest to the projects in the dependency tree. This figure shows there are two versions of dependency B 0.0.8 and B 1.0.0. In this scenario, version 0.0.8 of dependency B is included in the project because it's a direct dependency and closest to the tree. Now look at the three versions of dependency F 0.1.3 and 1.0.0 and 2.0. All three dependencies are at the same depth. In this scenario, Maven will use the first found dependency, which would be 0.1.3 and not the latest 2.0 version. If you want Maven to use the latest 2.0 version of Artifact F, you need to explicitly add that version dependency to a pom.xml file. Although highly useful, transitive dependencies can cause problems and unpredictable side effect, as you might end up including unwanted jar files or older versions of jar files. Maven provide a handy dependency plugin that allows to visualize your project dependency tree. There are times where you don't want to include certain transitive dependency jars in final archive. For example, when deploying an Artif application inside a container such as Tomcat or WebLogic, you might want to exclude certain jar files that, such as Servlet API or Java EE API, as they would conflict with versions loaded by containers. Maven provides an exclude tag to exclude transitive dependency. Here you can see the project. Here the project version 1.0.0. Here the direct dependencies A, B, C, D, and E. Here the A is connected to the project is connected to the direct dependencies A, B, C, D, and E. Here the A is connected to F and G. Here the C is connected to F and H, and here E is connected to H, and H is connected to B and J, and here E is connected to I and F. Here you can see the standard directory structure. Having a common directory layout allows us users familiar with the when Maven project to immediately feel at home in other Maven projects. Advantages are analogous to adopting a site-wide look and feel. This section here the directory layout expected by Maven and directory layout created by Maven. Try to conform to this structure as much as possible. However, if you can't, these settings can be overwritten via a project descriptor. At the top level, files descriptive of the project pom.xml. In addition, there are textual documents meant for the user to be able to read immediately on receiving the source, readme.txt and license.txt, etc. There are just two subdirectories in this structure, src and target. The only other directories that would be expected here are metadata like CVS and CVS.git or .svn and any other subprojects in the multi-project build, each of which would be laid out as here. The target directory is used to house all output of the build. The src directory contains all of the source material for building the project, its site, and so on. It contains subdirectory for each type: main for the main build artifact, test for the unit test code and resources, site, so on. Within artifact producing source directories, that is main and test, there is one directory for the language Java, under which the normal package hierarchy exists, and one for resources. The structure is copied to the target class path given the default resource definition. If there are other contributing sources to the artifact build, they would be under other subdirectories. For example, src, the main ANTLR would contain LR gamma definition files. Here you can see the src main Java, the application or library resources. Here the src main resources, application library resources, src main filters, resource filter files, source main web app, web application sources, src test Java test sources, src test resources, src test filters, test resource filter files, src it integration test primary for plugins, src assembly or descriptors, src site license.txt projects license, notice.txt notices and attributes required by libraries that projects depends on, readme.txt projects readme. Here you can see the Maven Java project structure. The best way to understand Maven project structure is look at this one also. Let's look at each of the components in the project. Here the GSWN is the root folder for the project. Typically the name of the root folder matches the name of the generated artifact. The src folder contains the project related artifacts such as source code or property files, which you typically would like to manage in a source control management SCM system such as SVN or JIT. Source main Java folder contains the Java source code. Source test Java folder contains the Java unit test code. Target folder holds the generated artifacts such as .class files. Generated artifacts are typically not stored in SCM, so you don't commit the target folder and its content into SCM. License.txt file contains license information related to project. Readme.txt file contains information or instructions about the project. Notice.txt file contains notices required by third-party libraries used by this project. Every Maven project has pom.xml file at the root of the project. It holds the project and configuration information such as dependencies and plugins. In addition to source main and source test directories, Maven recommends several other directories to hold additional files and resources. Here the resource. Now we are focusing on build system. Maven builds a project using its project object model POM and a set of plugins. Here you can see an overview of Maven build elements. Here the gray colored rectangles are provided by you, and green colored rectangles green colored rectangles are provided by Maven, and the pink colored rectangle shaded is the output, the deployment artifacts from your project. These custom plugins are optional. The rest of the inputs are mandatory. And here you can see project object model pom.xml and repository, local or remote, are connected to Maven build system. Maven plugins are connected to Maven build system. Custom plugins are connected to Maven build system. Maven build system is connected to project artifacts, and this is output. Here you can see Maven here you can see the libraries connected to pom.xml and Java source code is connected. Pom.xml is connected to Java source code and other assets, and project is connected to Maven, and Maven interacts with Maven local repository and more Maven remote repository, and Maven is connected to compile, test, and package, and that is connected to deploy. With regarding benefits of Maven, consistent build. Maven promotes consistency in build process across different projects. This helps maintaining standardized development environment, leading to fewer configuration issues. Automated testing with Maven built-in support for testing, developers can easily run unit tests, generate reports, and integrate testing into the build process. Project documentation. Maven can automatically generate project documentation, including Java docs and reports, making it easier for developers to understand and use the code base. Continuous integration. Maven is often used in CI/CD, continuous integration, continuous deployment pipelines. CI tools like Jenkins, Travis CI, and GitLab CI can be configured to trigger Maven builds whenever changes are pushed to the version control. Code quality analysis. Maven can be integrated with code analysis tools like SonarQube or FindBugs to ensure code quality and identify potential issues in the code base. Project reporting. Maven generate various reports such as test reports, code coverage reports, and project documentation, making it easier for developers and stakeholders to track project progress and identify areas for improvement. Managing project profiles. Maven supports the use of profiles to handle different build configurations such as development, testing, and production. This feature allows developers to manage build setting for different environments efficiently. Here you can see how the Maven works. To start using Maven, developers need to install it on their system and create a POM for their project. Once the POM is set up, and they can use Maven commands like Maven clean install or Maven test to execute various build phases. Integration with IDEs. Most modern integrated development environments, IDEs like Eclipse and IntelliJ IDEA, have built-in support for Maven, making it seamless to import Maven projects and leverage its features within the IDE. Plugin ecosystem. Maven has a rich plugin ecosystem, allowing developers to extend its functionality and integrate with other tools, making it a flexible choice for various project requirements. Servlet library and another Java library is connected to pom.xml. Spring library is connected to pom.xml. Spring library, here the Spring library and Servlet library and another Java libraries are connected to pom.xml. And here the step 2, another Spring library, Servlet library, and another Java library connected to Java source code via import. Here the Java source code and pom.xml are in the Java project. Here the Java project is connected to compile and build, and compile here then compile and build interacts with Maven install and build. And 5, the pom.xml is connected to Maven install and build. The 6, the Maven repository local is connected to Maven install and build via install, and 7, Maven repository online is connected to download to Maven via download and install. The 8, the compile and build is connected to Java apps. Here the Maven repository local, here the Windows C colon for username /m2 in Unix /home/. your username /.m2. Here the online Maven repository online is http://mavenrepository.com. Here you can see the Maven release process. The 3 build life cycles of Maven are clean up the artifact that are created by prior builds. Default build used to create the application site for the project generate site documentation. Here is a nice diagram which explains the Maven build and release cycle. Here the developer, here the 2.0 snapshot is connected to CVS via check-in code. Here the release prepare 2.0 snapshot is connected to CVS and 2.0 via update POMs and 3 compile and test. Here the update then release prepare 2.0 snapshot is connected to CVS via tagging release and check-in POMs. Then 2.0 is connected to 2.1 snapshot via update POMs and then compile and test. Then 2.1 snapshot is connected to CVS via 7 via check-in POMs. Then CVS is connected to 2.0 via checkout text code. Here the 2.0 is connected to Nexus via 2.0 release via compile, test, and then deploy artifact release perform here. And here the 11 CVS connected to is 2.1 snapshot via check out POMs to the developer. Here this 2.0 snapshot 2.0 and 2.1 snapshot and Nexus are in Maven. Here the packaging, for example the jar packaging will bind the following goals to build phases of the default lifecycle. The most common way is to set the packaging for your project via the equally named pom element packaging. Some of the valid packaging values are jar, var, ear, and pom. If no packaging value has been specified, it will default to jar. Each packaging contains a list of goals to bind particular phase. For example, the jar packaging will bind the following goals. To build phases of the default lifecycle. This is an almost standard set of binding. However, some packaging handle them differently. For example, a project that is purely metadata packaging via value is pom only binds goals to the install and deploy. Install and deploy phases. For a complete list of goals to build phase bindings of some of the packaging types. Note that for some packaging types to be available, you may also need to include the particular plugin in the build section of your POM. Specify extensions true for the plugin. Fun example of plugin that require this is Plexus plugin, which provide Plexus application and Plexus service packaging. Here you can see the phase, and here you can see the goal plugin, goal for the jar packaging. Here process resources and compile. Here compile, process test resources and test resources. Here test compile, here compile, test compile, test surefire test, package jar, install and deploy. Here you can see clean lifecycle. Here the pre-clean execute processes needed prior to the actual project cleaning. Clean remove all files generated by the previous build. And post clean, execute processes needed to finalize the project cleaning, and these are phases. Here you can see the phases of default lifecycle. Validate the project is correct and all necessary information is available. Initialize build state, for example set properties or create directories. Generate sources, generate any source code for inclusion in compilation. Generate sources, process sources, process the source code, for example to filter any values. Generate resources, generate the resources for inclusion in the package. Process resources, copy and process the resources into the destination directory ready for packaging. Compile the resource source of the project. Process classes, post-process the generated files from the compilation, for example to do bytecode enhance on the Java classes. Generate test cases, test sources, generate any test source code for inclusion in the compilation. Process test sources, process the test source code, for example to filter any values. Generate test source resources, create resources for testing. Process test resources, copy and process the resource into the test destination directory. Test compile, compile the test source code into the test destination directory. Process test classes, post process the generated files from the test compilation, for example to do bytecode enhancement on Java classes. Run test using a suitable unit testing framework. These tests should not require the code be packaged or deployed. Pre-package, perform any operation necessary to prepare the package before actual packaging. This is often result in unpacked processed version of the package. Package, take the compiled code and package it in its distributed format such as jar. Pre-integration test, perform any actions required before integration tests are executed. This may involve things such as setting up the required environment. Integration test, process and deploy the package if necessary into an environment where integration tests can be run. Post-integration test, perform actions required for after integration tests have been executed. This may include clean up the environment. Verify, run any checks to verify package is valid and meets quality criteria. Install the package into the local repository for use as a dependency in other project locally. Deploy done in an integration or release environment. Copies the final package to the remote repository for sharing with other developers and projects. Here you can see the phases. Validate, install, generate resources, process resources, generate resources, process resources, compile, process classes, generate test class sources, process test sources, generate test resources, process test resources, test compile, process test classes, test, prepare package, pre-integration test, integration test, post-integration test, verify, install and deploy. Here you can see clean lifecycle bindings. Here the phase and plugin. Here the clean and binding is plugin goal is clean. Here you can see default lifecycle bindings, packaging, EJB3, Java, Era, and WA. These are the phases and plugin goals. Process resources, then plugin goal is resources, compile, process test resources, test resources, test compile, test, surefire test, package, EJB or EJB3 or JA or PA or RRA or WAWA, install, deploy. So here you can see the default lifecycle bindings for packaging EAR. Here the phases and these are the plugin goals. Generate resources, EAR generate application.xml, process resources, package EAR, install, deploy. Here you can see the default lifecycle bindings for packaging Maven plugin. Here you can see the phases and here the goals. Generate resources, plugin descriptor, process resources, compile, process test resources, test compile, test, surefire test, package, jar, plugin, add packaging, add plugin artifact metadata, install, deploy. Here you can see default lifecycle. Default lifecycle is defined with phases without any associated plugin binding. Plugin bind for the life cycles are defined separately for each packaging. Here you can see the phases: validate, initialized, generate resources, process resources, generate resources, process resources, generate sources, process sources, generate resources, process resources, compile, process classes, generate test sources, process test sources, generate test sources, process test sources, test compile, process test classes, test, prepare package, pre-integration test, post-integration test, verify, install, and deploy. Here you can see clean life cycle. Clean lifecycle phases are defined within their plugin bindings. Here pre-clean, clean, and post-clean. So here you can see the Maven clean plugin. Here you can see wrapper lifecycle here. Wrapper lifecycle phase defined within their plugin bindings. Here wrapper, and here the Maven wrapper plugin. Here the plugin bindings for default lifecycle reference. Here you can see the plugin bindings for jar packaging. Here you can see the Maven resource plugin resources, and this is plugin version. Maven compiler plugin compile, Maven resource plugin test resources, Maven compiler plugin test compile, Maven surefire plugin test, Maven jar plugin jar, Maven install plugin install, and Maven deploy plugin deploy. Here you can see plugin bindings for EJB packaging. Here you can see Maven resource plugin resources, Maven compile plugin compile, Maven resource plugin test resources, Maven compile plugin test compile, Maven surefire plugin test, Maven EJB plugin EJB, Maven install plugin install, Maven deploy plugin deploy. Here you can see Maven plugin in the Maven plugin bindings for default lifecycle reference in the plugin bindings for Maven plugin packaging. Here you can see Maven resource plugin resources, Maven compile plugin compile, Maven plugin descriptor, Maven resource plugin test resources, Maven compile plugin test compile, Maven surefire plugin test, Maven jar plugin jar, Maven plugin add plugin artifact metadata, Maven install plugin install, Maven deploy plugin deploy. Here you can see plugin bindings for default lifecycle reference. Plugin bindings for var packaging. Here the Maven resource plugin resources, Maven compile plugin compile, Maven resource plugin test resources, Maven compile plugin test compile, Maven surefire plugin test, Maven var plugin var, Maven install plugin install, Maven deploy plugin deploy. Here you can see plugin bindings default lifecycle reference plugin bindings ER packaging. You can see Maven ER plugin generate application XML, Maven resource plugin resources, Maven ER plugin ER, Maven install plugin install, Maven deploy plugin deploy. Here you can see the plugin binding for default lifecycle reference, the plugin binding for raw package. Here Maven resource plugin resources, Maven compile plugin compile, Maven resource plugin test resources, Maven compile plugin test compile, Maven surefire plugin test, Maven raw plugin raw, Maven install plugin install, Maven deploy plugin deploy. Here you can have here the phases and plugin goals. Here the when we run Maven package, MEN package in the Java project, plugins that are plugged into phases are shown in this figure. Lifecycle phases don't come with any functionality to carry out tasks. They really rely on plugins. For example, compile plugin doesn't actually compile the Java source. It's a delegated job to compile. Goal of Maven compile plugin, which invokes the rusty old Java C to compile the project. When the lifecycle phase is executed, Maven builds specific plugin goals to lifecycle phases depending on the Maven, on the project and packaging type. For example, when we run Maven package in Java project, the plugins that are plugged into phases are as shown in this figure. To compile phase, Maven builds compile goal of the Maven compiler plugin. Similarly, test phase, it binds test goal of Maven Surefire plugin. So on. What happened at package phase is a bit interesting. In a Java project, Maven binds Java goal of Maven Java plugin. However, when we run the same command in web app project, Maven binds var goal of the Maven var plugin. Which plugin and goals bind to the phases depend on project and also package, var, Java, etc. type. Here you can see lifecycle phases and here plugin goals. Here process resources is interacts with this resources. Here compile interacts with compile. Here process classes, process test resources interacts with resources, test resources, test compile interacts with compiler, test interacts with Surefire test, prepare package interacts with jar. Here the lifecycle phases, process resource, compile, process classes, process test resource, test compile, test, prepare package. Here the plugin goals, resources, compile, resources test resource, compile, test compile, Surefire test, jar. The default lifecycle has the following build phases. The validate, validate the project is correct and all necessary information is available. To compile, compile the source code of the project. Test the test the compiled source code using a suitable unit testing framework. These tests should not require the code be packaged or deployed. Package, take the compiled code and package it in its distributable format such as jar. Integration test, process and deploy the package if necessary to an environment where integration test can be run. Verify, run any checks to verify the package is valid and meet the quality criteria. Install the package into local repository for use as a dependency in other projects locally. Deploy, done in the integration or release the environment, copies the final package to the remote repository for sharing with other developers and the project. These lifecycle phases plus the other lifecycle phases not shown here are executed sequentially to complete the default lifecycle. Here you can see lifecycle phases. Here plugins. This is pom, and here the machine is connected to Maven. Here the machine is connected to compile via Maven compile, and here the generate sources, and here the compile is Maven compiles. Machine is connected to compile via Maven compile, and Maven compile is connected to here compiler. The compile goal test compile here. Here test compile is connected to compiler. Here test compile goal here. Here test is connected to Surefire test goal here, and here machine is connected to a Maven test. Connected to the package via MVN test, and here the integration test, and install is connected to jar via jar goal, and install goal via pom. Here Maven MVN install is connected to deploy, and here the pom is here. This connectivity is going through pom, and these are the plugins: arc type, compiler, Surefire, jar, and install. Here the plugins define goals. Goals can be bound to phases. Goals from multiple plugins can be bound to single phase. Maven is a plugin execution framework. Plugins are an assembly of goals, code written as mojos. Maven plain old Java project objects. Modern mojos are not restricted to being written in Java. Goals have names and can be bound to phases. A mojo declares its goal name and optionally a phase associated with which binds the class to a part of a life cycle. Plugins is typically a .jar file which contains the mojo classes and meta-ina/maven plugin.xml. This plugin.xml is generated as a part of the Maven execution of the plugin code. Plugin 1 is one interacts with goals here, and other plugins are also interacts with goals mojo here. It has a name and phase here. Here the phase 1, phase 3 here, again phase 1 here. So goals mojos are connected to phases here. Phase 1 here. This goal is see the plugin 1 goal is connected to this interact with this goal, and this goal is connected to phase 1, and here plugin 3 interacts with this goal, and this goal is connected to phase 1. Here the plugin 2 interact with this goal, and this goal is connected to phase 3. This is a life cycle, and these are the phases: phase 1, phase 2, phase 3, and these are plugins, and these are life cycle. Here you can see the association between life cycle and phases, life cycle phases, goals, and plugins. Maven goals are granular and typically perform one task. Multiple goals need to be executed in an ordinary fashion to perform complex operations such as generating artifact or documentation. Maven simplifies these complex operations via lifecycle and phase abstractions, such as build-related operations could be computed with a handful of commands. Maven build lifecycle constitutes a series of stages that are executed in the same order, independent of artifact being produced. Maven refers to the stages in a lifecycle as phases. Every Maven project has the following 3 built-in lifecycles. Default, this lifecycle handles the compiling, packaging, and deployment of Maven project. Clean, this lifecycle handles the deletion of temporary files and generated artifact from the target directory. Site, this lifecycle handles the generation of documentation and site generation. To better understand the build lifecycle and its phases, let's look at some of the phases associated with the default lifecycle. Validate runs checks to ensure that the project is correct and all dependencies are downloadable and available. Compiles the source code. Test runs unit test using frameworks. This step doesn't require that the application be packaged. Assembles the compiled code into a distributed format such as Java. Install the package archive into local repository. The archive is now available for use by any project running on that machine. Deploy pushes the build archive into a remote repository for use by other teams and team members. Maven lifecycle is an abstract concept and can't be directly executed. Instead, you execute one or more phases. For example, the command mun package will execute the package phase of the default lifecycle. In addition to clearly defining the ordering of phases in a lifecycle, Maven also automatically executes all the phases prior to the requested phase. So when mun package command is run, Maven will run all prior to phases such as compiled and test. A number of tasks needed to be performed in each phase. For that to happen, each phase is associated with 0 or more goals. The phase simply delegates those tasks to its associated goals. This figure shows the association between lifecycle, phases, goals, and plugin. it is valid for a Maven phase to have phase not have any goals associated with it. In that case, Maven will skip the phase execution, such phases serves as placeholders for users and third-party vendors to associate their custom built goals. Here you can see the phases are in life cycle. Here the phases are phase 1 is connected to phase 2, phase 2 is connected to phase 3, phase 3 is connected to phase 4, phase 4 is connected to phase 5, phase 6 is connected to 5 is connected to phase 6. Here the phase 2 is connected to goal A, and here the and plugging and his goal B, and phase 4 is connected to goal C and plugging 2, and here the phase 6 is connected to goal D in plugging 3. Plugin goal D interacts with plugin 3. In other words, phase 1 is connected to phase 2 here. Phase 2 is connected to goal A, and then and goal B, and here these goals are interacts with plugin 1. Phase 2 is connected to phase 3, and phase 3 is connected to phase 4. Phase 4 is connected to goal C, and that interacts with plugin 2. Here phase 4 is connected to phase 5, phase 5 is connected to phase 6, phase 6 interacts with goal D, and that connected to goal D, and that interacts with plugin 3. Now here you can see default lifecycle for VAR project. The packaging element in pom.xml will automatically assign the right goals to each of the phases without any additional configuration. Remember that this is a benefit of COC. For example, if the packaging element is jar, then the package phase will be bound to jar goal in the jar plugin. Similarly, for the var artifact, pom.xml will bind the package to var goal in the var plugin. This figure shows the portion of the internal lifecycle associated with the var project. When you run the package phase, the test phase is also run, and all the unit tests get executed. If there are any failures in the test phase, the build fails. This is the described desired behavior. However, there are times, for example, when dealing with legacy project, where you would like to skip compiling and running test, so you can build the project successfully. You can achieve this using maven.test.skip property. Here the project resources is connected to resources, and it actually interacts with resources, and project resources is connected to compile. Compile is connected to compile. It actually interacts with compiler. Compile is connected to test. Test is connected to surefire. Surefire interacts with test. Test is connected to package. Package is connected to var. Var is interacts with var. Package is connected to install. Install is connected to install. Install interacts with install. Install is connected to deploy. Deploy is connected to deploy, and deploy interact with deploy. Here you can see how to build Maven lifecycle. Sequence of steps which is defined in order to execute the task and goals of any Maven project is known as build lifecycle. Maven 2.0 version is basically a build lifecycle oriented and clearly says that these steps are well defined to get desired output after successful execution of the build lifecycle. Here you can see the pom section and dependency manager and lifecycle here. Here the pom.xml is connected to pom.xml is in the pom here. Here manager plugins and dependency are in dependency manager. Repositories in dependency manager and pom. Here the compile, test and install are in lifecycle. Here pom.xml is connected to manager. Manager is connected to project information, dependencies and plugin, and those are connected to repositories. Sorry, the dependencies and plugins are connected to the repositories, and repositories are connected to plugins and dependencies. Here for example, here this plugin is connected to compile and test, and this plugin is connected to install. Here you can see a high-level diagram that tries to show how my Maven build life cycles, phases, plugins, and goals interact between each other. Here you can see the life cycles. Here, default, clean, and sites are in life cycles. Here the default phases, compile, test, install, etc., and clean phases, pre-clean, clean, post-clean. Site phases, feed site, post site deploy are in phases. Here the plugin clean, plugin compile, and other plugins are in plugins and goals. And here goal clean in plugin clean. Here goal compile in compiler. Here goals are in other plugins. Here the default is connected to default, clean, and site are connected to phases. Here the default is you can see the default phase here, and here the clean phase here, and site phases default phases are here, and clean phases are here, and site phases are here. The phases are connected to plugins, so goals here. As an example, we can consider this. Here's an overview of the top elements under settings. The settings element in the settings .xml file contains elements used to define values which configure Maven execution in various ways, like pom.xml, but should not be bundled to any specific project or distributed to an audience. These include values such as local repository location, alternative remote repository servers, and authentication information. So this is in settings.xml file. Now we are considering simple values. Half of the top level settings elements are simple values representing a range of values which describe elements of the build system that are active full time. Here local repository, this value is the path of this build system local repository. The default value is $use open braces user.home closing brace /m2 /repository. This element is especially useful for a main build server, allowing all logged in users to build from a common local repository. Interactive mode, true if Maven should attempt to interact with the user for input, false if not. Default is default to true. Offline, true if this build system should operate in offline mode. Default to false. This element is useful for build servers which cannot connect to a remote repository, either because of network setup or security reasons. As an example 3, we can consider this. invalid repository exception, class invalid repository exception signals an error when adding a repository to the model resolver. This is in package org.apache.maven.model.resolution. Here you can see building Maven. Here we are considering a class build in package org.apache.maven.api.model. The build element contains information required to build the project. Default values are defined in superpom. That is related to API. Here the why would I want to build Maven? Here the in building Maven or a plugin or any component yourself is for one of two reasons. To try out bleeding edge features or bug fix issues can be found in Jira. To fix a problem you are having and submit a patch to the developers team. Now we are considering checking out resources. All of the source code for Maven and its related libraries are managed in the ASF source code repositories. Now we are considering building a Maven plugin or component is like any Maven build. In building a Maven plugin or component in building Maven. Here you can see the command, and here running integration test before submitting a patch. It is advised to run the integration test which are available in the run here the run-its profile. Now we are considering building Maven core. To do this, run from the source directory. Until Maven 3.3, the Maven core build could be bootstrapped with any ant build. This bootstrap has been removed from in Maven 3.5. You need the pre-built Maven to build the Maven from source. To do this, run from the source directory. The assembles will be created in Apache Maven and can be manually unzipped to the location where you like the resulting Maven installed. If you want to have the resulting Maven directly copied to a directory, you can use the distribution target dir property. Here, running the full Maven core integration test before checking in a change or submitting a patch to Maven core. It is required to run the core integration test using your local build of Maven. Run this one. Now we are considering build lifecycle basics in introduction to the life cycle. The build lifecycle is made up of phases. For example, the default lifecycle comprises of the following phases. For the complete list of lifecycle phases, refer the lifecycle reference. Each of the build lifecycles are defined by a different list of build phases, wherein a build phase represents a stage in the life cycle. For example, the default life cycle comprises of the following phases. For the complete list of the life cycle phases, refer the life cycle references. Validate the project is correct and all necessary information is available. Compile the source code of the project. Test the compiled source code using suitable unit test framework. These tests should not require the code to be packaged or deployed. Take the compiled code and package it in distributable formats such as jar. Run the checks on the result of the integration test to ensure quality criteria is met. Install the package into the local repository for use as a dependency in other project locally. Deploy done in the built environment. Copies the final package to the remote repository for sharing with other developers and projects. These lifecycle phases plus other lifecycle phases not shown here are executed sequentially to complete the default lifecycle. Given the lifecycle phases above here, this means that when the default lifecycle is used, Maven will first validate the project, then try to compile the sources, run those against the tests, package the binaries, for example jar, run integration test against the package, verify the integration test, install the verified package to the local repository, deploy the installed package to a remote repository. Now we are considering usual command line calls. If you are uncertain what you want, the preferred phase to call is this one. You should select the phase that matches your outcome. If you want your jar, run package. If you want to run the unit test, run test. If you are uncertain what you want, the preferred phase is called, preferred phase to call is this one, verify. This command execute each default lifecycle phase in order to validate, compile and package etc. before executing verify. You only need to call the last build phase to be executed, in this case verify. The most cases the effect is the same as the package. However, in the case where the integration test, these will be executed as well. And during the verify phase, some additional checks can be done. For example, if your code written according to the predefined live check style rules. In the built environment, use the following call to build and deploy artifact into the shared repository. The same command can be used in a multi-module scenario, that is a project with one or more sub-projects. Maven traverses into every sub-project and execute clean, then execute deploy, including all the prior build phase steps. Now we are considering plugins. Plugins in setting up your project to use built lifecycle. So to use the Modelo plugin and have it generate sources from a Modelo model and incorporate that into the build, you would add the following to your POM and in the plugins section of the build. You can use packaging. That's the common way to set packaging. Set the packaging for your project in the life cycle. And second way is to add goals to phases is to configure plugins in your project. Plugins are artifacts that provide goals to Maven. Furthermore, a plugin may have one or more goals wherein each goal represents a capability of that plugin. For example, a compiler plugin has two goals, compile and test compile. The former compiles the source code of your main code, and while the latter compiles the source code of your test code. As you will see, the plugins can contain information that indicates which lifecycle phase to bind to the goal to. Note that adding the plugin on its own is not enough information. You must specify goals you want to run as part of your build. Goals that are configured will be added in the goals already bound to the lifecycle from the packaging selected. If more than one goal is bound to the particular phase, the order is used to indicate that those packaging are executed first, following by those configured in the POM. Note that you can use the executions element to gain the more control over the order of particular goals. For example, the Mojo plugin binds by default. For example, the Modelo plugins by default its goal Modelo.java. to the generate sources phase. Note the modulo Java goal generates Java source code. So to use modulo plugin and have it generate sources from a model and then incorporate that into build, you would add the following to your POM in the plugin section of the build. You might wonder why executions element is there. That is so you can run the same goal multiple times with different configurations. If needed, separate executions can then be can also be given an ID, so that during inheritance and application of profiles you can control whether goals and configuration is merged or turned into an additional execution. When multiple executions are given that match a particular phase, they are executed in the order specified in the POM with inherited execution running first. Note, in the case of modulo Java, it's only makes sense the generate sources phase, but some goals can be used more than one phase, and there may not be sensible a sensible default. For those, you can specify the phase yourself. For example, let's say you have a goal display time that echoes the current time to the command line, and you want it to run process test resources phase to indicate when the tests are started. This would be configured like so here. Then an example we can consider this one. Actually, this is a warning. Some problems were encountered while building an effective settings. Unrecognized tag, build, position, start tag, start underscore tag seen in activation, etc. and build at /home/guest/.m2/settings.xml line 16 column 13. This is occurred during the command mun clean install. Now we are focusing on pom.xml. A project model or POM is the fundamental unit of work in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build the project. It contains default values for most projects. Examples for this is the build directory, which is a target, source directory, which is src/main/java, the test source directory, which is src/test.test/java, and so on. When executing a task or goal, Maven looks for the POM in the current directory. It reads the POM, gets the needed configuration information, then executes the goal. Here you can see POM overview. Here the asterisk element with asterisk element may be overridden, at least mostly, by profile element settings. And elements with here element with double asterisk profile elements are the asterisk dash suffixed elements. Here this sign contains elements for meant inheritance. Maven projects dependencies uh, builds, artifacts, all of these are objects to be modeled and described. These objects are described by an XML file called a project object model. The POM tells Maven what sort of project it is dealing with and how to modify default behavior to generate output from source. In the same way, a Java web application has a web.xml that describes, configures, and customizes the application. A Maven project is defined by presence of pom.xml. It is a descriptive declaration of a project Maven. It is the figurative map that Maven needs to understand what it is looking at when it builds your project. You can also think of pom.xml as an analogous to Makefile or an ant build.xml. When you are using GNU Make to build something like MySQL, you will usually have a file named Makefile that contains explicit instruction for building a binary from source. When you are using Apache Ant, you likely have the file named build.xml that contains explicit instruction for cleaning, compiling, packaging, and deploying an application. Make, Ant, and Maven are similar in that they rely on presence of a commonly named file such as Makefile, build.xml, or pom.xml, but that is where the similarities end. If you look at Maven pom.xml, the majority of POM is going to deal with descriptions. Where is the source code? Where are the resources? What is the packaging? If you look at an ant build.xml file, you will see something entirely different. You will see explicit instructions for tasks such as compiling a set of Java classes. The Maven POM is declarative, and although you can certainly choose to include some procedural customizations via the Maven Ant plugin, for the most part you will not need to get into gritty procedural details of the build if your project's built. POM is also not specific to building Java projects. While most of the while Maven default plugins are targeted at building jar artifacts from a set of source, test, and resources, there's nothing preventing you from defining a POM for a project that contains C# resources and produces some proprietary Microsoft binary using Microsoft tools. We have established that the POM describes and declares. It is unlike an ant or make in that it doesn't provide explicit instructions, and we have noted that POM concepts are not specific to Java. Here you can see the project object model and overview. POM contains 4 categories of description and configuration. The general project information, This includes a project name, the URL for a project, sponsoring organization, a list of developers, and contributors, along with your project, along with your contributors, along with the license for a project. In build settings, in this section we customize the behavior of the default Maven build. We can change the location of sources and sets and tests. We can add new plugins. We can attach plugins goals to the lifecycle, and we can customize the site generating parameters. Build environment. The build environment consists of profiles that can be activated for use in different environments. For example, during development, you may want to deploy to a development server, whereas in production you want to deploy to a production server. The build environment customizes the build settings for specific environments. And is often supplemented by custom settings.xml in title/.m2. And POM relationships. A project rarely stand alone. It depends on other projects, inherits POM settings from parent projects, defines its own coordinates, and may include submodules. And if we reconsider this, POM stands for Project Object Model. It is an XML representation of a Maven project held in a file named pom.xml. When in the presence of Maven folks, speaking of a project is speaking the philosophical sense beyond a mere collection of files containing code. A project contains configurable files as well as the developers involved and roles that they play, and the defect tracking system, the organization and licenses, the URL of where project lives, the project dependencies, and all of other little pieces that come into play to give code life. It is a one-stop shop for all things concerning the project. In fact, in Maven world, a project does not need to contain any code at all, merely a pom.xml. The POM contains all necessary information about the project as well as configurations of plugins to be used during the build process. It is declarative manifestation of who, what, and where, while build cycle is the when and how. That is not to say that POM cannot affect the flow of the life cycle. It can. For example, by configuring Maven-Antran-plugin, one can embed Apache and task inside the POM. It is merely a declaration, however, whereas a build.xml tells and precisely what to do when it is run procedural. The POM states its configuration declarative. This some external the external force causes the lifecycle to skip the AND plugin execution. It does not stop the plugin that are executed from doing their magic. This is unlike a build.xml file, whereas tasks are almost always dependent on the lines executed before. Here Maven coordinates the POM defined above is the bare minimum. I mean, here group ID colon artifact ID version group ID colon artifact ID version group ID colon artifact ID colon version are all required fields. All the group ID and version do not need to be explicitly defined if they are inherited from a parent. These three fields act much like an address and timestamp in one. This makes a project place in a repository act like a coordinate system for Maven projects. Project ID, this is generally unique amongst an organization or a project. For example, all core Maven artifact do well should live under the group ID org.apache.maven. Group IDs do not necessarily use the dot notation. For example, the JUnit project. Note that the --noted group ID does not have to correspond to package structure that the project contains. It is, however, a good practice to follow. When stored within a repository, the group acts much like the Java packaging structure does in an operating system. The dots are replaced by OS-specific directory separators such as / in Unix, which becomes a relative directory structure from the base repository. Artifact ID. The artifact ID is generally the name that the project is known by. Although the group ID is important, people within the group will rarely mention the group ID in discussion. It along with the group ID creates a key that separates this project from every other project in the world. At least it should. Along with the group ID, the artifact ID fully defines the artifact's living quarters within the repository. As an example, my dash project lives in $m2_repo/org/code/host/mojo/my project. Version. This is the last piece of the naming puzzle. Group ID colon artifact ID denotes a single project. But they cannot delineate which incarnation of the project that we are talking about. Do we want JUnit colon JUnit of 2008 version 4.12 or of 2007 version 3.8.2? In short, code changes. Those changes should be versioned. In this element keeps those versions in line. It is also used within an artifact repository to separate versions from each other. For example, my dash project version 1.0 files live in the directory structure $-repo/org/codehost/mojo/my project/1.0. These three elements given here to a specific version of the project here, letting Maven know who we are dealing with. and when it's in its software life cycle we want them. With regarding packaging, now that we have our address structure of group id colon artifact id colon version, there is one more standard label to give us a really complete what, that is project packaging. For example, pom.xml colon my dash project colon 1.0 define can be packaged as a jar. We could make it into WAR by declaring a different packaging. When no packaging is declared, Maven assumes the packaging is default jar. POM relationships. The most powerful aspect of Maven is its handling of project relationships. This include dependencies and transitive dependencies, inheritance, and aggregation. Multi-module projects. Dependency management has a long tradition of being a complicated mesh for anything but the most trivial of project. Jarmageddon quickly ensures as a dependency tree become a large and complicated. Jar hell follows, where versions of dependencies on one system are not equivalent to the versions developed it either by wrong version given or conflicting versions between similarly named jars. Maven solves both problems through a common local repository from which to link projects correctly, versions and all. Dependencies. The cornerstone of POM is its dependency list. Most projects depends on others to build and run correctly. If Maven does for you, this is if all Maven does for you is manage this list, you will gain a lot. Maven download and links the dependencies on compilation as well as on other goals that require them. As an added bonus, Maven brings in the dependencies of all those dependencies, transitive dependencies, allowing your list to focus solely on dependencies that your project requires. One of inheritance. One powerful addition that Maven brings to build management is concept of project inheritance. Although in build systems such as Ant, inheritance can be simulated, Maven makes project inheritance explicit in the project object model. And the super POM, POM, similar to inheritance of the objects in object-oriented programming, POMs that extend parents POM inherits certain values from the parent from that parent. Moreover, just as Java objects ultimately inherits from java.lang.object, all project object models inherits from a base super POM. Dependency management. Beside inheriting certain top-level elements, parents have elements to configure values for child POMs and transitive dependencies. One of these elements is dependency management. It is used by POMs to help manage dependency information across all of its children. If my dash parent project uses dependency management to define a dependency on JUnit colon 4.12, then POMs inheriting from this one can set their dependency giving the group ID equal JUnit and artifact ID equal JUnit only, and Maven will fill the version set by the parent. The benefit of this method are obvious. Dependency details can be set in one central location, which propagate to all inheriting pumps. Aggregation or multi-module. A project with modules known as a multi-module or aggregator project. Modules are projects that this POM lists and executed as a group. A POM package projects may aggregate the build of a set of projects by listing them as modules, which are relative path to directories or POM files of those projects. Properties are the last required piece to understand POM basics. Maven properties are value placeholders like properties in AND. Their values are accessible anywhere within a POM by using the notation $, open curly brace, close curly brace, where X is the property, or they can be used by plugins as default values. And in this diagram you can see properties here. Build settings. Beyond the basics of POM given before, given here, there are two more elements that must understood before claiming basic competency of the POM. They are built element that handles things like declaring your project's directory structure and managing plugins, and reporting elements that largely mirrors the built element for reporting purposes. The built, according to the POM 4.0.0 XSD, the built element is conceptually divided into two parts. There is a base build type, which contains the set of elements common to both built elements, the top level built element and the project, and the built element and the profiles, covered profiles. There is a build type which contains base build set as well as more elements for the top level definition. The basic built element set. Base build is exactly as it sounds, the base set of elements between the two built element in the POM. Resources, another set of built element, is specifying where resources exist within your project. Resources are not usually code. They are not compiled, but are items meant to be bundled within your project or used for various other reasons such as code generation. Plugins, beyond the standard coordinate of group ID : artifact ID : version, there are elements which configure the plugins or this build interaction with. Plugin management is an element that is seen along side plugins. Plugin management contains plugin element in which the same way, except that rather than configuring plugin information for this particular project build, it is intended to configure project builds that inherit from this one. However, this only configured plugins that are actually referred within the plugin element in the children or the current POM. The children have every right to override plugin management element definitions. The build element set, the build type in the XSD denotes denotes those elements that are available for the project built, despite the number of extra element 6, there are really only 2 groups of elements that project build contains that are missing from the project from the profile build: directories and extensions. Directories, the set of directory element live within the parent built element, which set various directory structures for the POM as a whole. Since they do not exist in profile build, these cannot be altered by profiles. Extensions are a list of artifacts that are to be used in this build. They will be included in the running build class path. They can enable extensions to build process, such as add an FTP provider for the wagon transport mechanisms, as well as make plugins active which make changes to the build lifecycle. In short, extensions are artifacts that are activated during build. The extensions do not have to actually do anything for contain mojo. For this reason, extensions are excellent for specifying one out of multiple implementation of common plugin interface. Reporting contains the elements that correspond, especially for the site generation phase. Certain Maven plugins generate reports defined and configured under report element. For example, generating Java doc reports. Much like the built element's ability to configure plugins, reporting commands the same ability. The glaring difference is that rather than fine-grained control of plugin goals within the executions block, reporting configures goals within report set elements. And subtler difference is that a plugin configuration under the reporting element works as a built plugin configuration. Although the opposite is not true, a built plugin configuration does not affect a report plugin. Report sets. It is important to keep in mind that an individual plugin may have multiple goals. Each goal may have separate configuration. Report sets configure execution of a report plugins goals that does this familiar deja vu. The same thing was said about build's execution element, with one difference: you cannot bind a report to another page. Sorry. Here you can see more project information. Several elements do not affect the build, but rather document the project for the convenience of developers. Many of these elements are used to fill in project details when generating the project's website. However, like all POM declarations, plugins can use them for anything. Followings are the simplest element: name, description, URL, inception. Here, name. Projects tend to have conventional names beyond the artifact ID. The Sun engineers did not refer to their project as Java-1.5, but rather just called it Tiger. Here is where to set that value. Description, a short human readable description of the project. Although this should not replace formal documentation, a quick comment to any readers of the POM is always helpful. URL, the project's homepage. Inception year, the year the project was first created. Licenses are legal documents defining how and when a project or parts of a project may be used. A project should list licenses that apply directly to this project, and not list licenses that apply to the project's dependencies. Organization. The most projects are run by some sort of organization, business, private group, etc. Here is where the most basic information is set. Developers. All projects consist of files that were created at some time by a person. Like other systems that surround a project, so to do this, people involved with a project have a stake in the project. Developers are presumably members of the project's core development. Note that although an organization may have many developers, programmers as members, it is not good form to list them all as developers, but only those who are immediately responsible for the code. A good rule of thumb is if the person should not contacted about the project, they do not need to be listed here. Contributors are like developers, yet play an auxiliary role in a project's lifecycle. Perhaps the contributor sent in a bug fix or added some important information. A healthy open source project will like to have more contributors than developers. In the environment settings, in the issue management, this define the defect tracking system, Bugzilla, TestTrack, ClearQuest, etc. used. Although there is nothing stopping a plugin from using this information for something, it's primarily used for generating project documentation. Continuous integration management. Continuous integration build system based upon triggers and timings such as hourly or daily have grown in favor over manual builds in the past few years. As build systems have become more standardized, so have the systems that run the trigger those builds. Although the majority of configuration is up to the specific program used, continuum, cruise control, etc., there are a few configurations which may take place within the POM. Maven has captured a few of recurring settings within a set of notifier elements. A notifier is a manner in which people are notified of a certain build status. Mailing lists. Mailing lists are a great tool for keeping in touch with people about project. Most mailing lists are for developers and users. SCM, the software configuration management, so-called the source code control management or succinctly version control, is an integral part of any healthy project. If your Maven project uses a SCM system, it does, doesn't it? Then here is where you place that information into POM. Prerequisites. POM may have certain prerequisites in order to execute correctly. The only element that exists as prerequisite in POM 4.0.0 is the Maven element, which takes a minimum version number. Repositories. Repositories are collection of artifacts which adhere to Maven repository directory layout. In order to be a Maven repository artifact, the POM file must live within the structure $base _ repo / group ID / artifact ID / version / artifact ID - version.pom. $base _ repo can be local file structure or remote base URL. The remaining layout will be same. Repositories exist as a place to collect and store artifact. Whenever a project has a dependency upon an artifact, Maven will first attempt to use a local copy of the specified artifact. If that artifact does not exist in the local repository, it will then attempt to download from the remote repository. The repository element within a POM is specify those alternate repositories to search. Plugging repositories are home to two major types of artifact. The first are artifacts that are used as dependencies of other artifacts. These are the majority of artifacts that reside within Central. The other type of artifacts is plugins. Maven plugins are themselves a special type of artifacts. Because of this, plugin repositories may be separated from other repositories, although I have yet to hear a convincing argument for doing so. In any case, the structure of plugin repositories element block is similar to the repositories element. The plugin repository element each specify a remote location where Maven can find new plugins. Distribution management. Distribution management act precisely as it sounds. It manages the distribution of the artifact and supporting file generated throughout the build process, starting with the last element first. Repository, whereas the repository's element is specified in the POM the location and manner in which Maven may download remote artifact for use by current project. Distribution management specifies where and how this project will get a remote repository when it is deployed. Repository element will be used as for snapshot distribution if the snapshot repository is not defined. Site distribution. More than distribution to the repository, distribution management is responsible for defining how to deploy the project site and documentation. And relocation projects are not static; they are living things. A common thing that happen as project grow is that they are focused to move more suitable quarters. For example, when your next widely successful open source project moves under the Apache umbrella, it would be good to give users a heads up that the project is being renamed to org.apache.my-project:1.0. Besides specifying new address, it is good form to provide message explaining why. Profiles. A new feature of POM 4.0 is the ability of a project to change settings depending on the environment where it is being built. A profile element contains both an optional activation, a profile trigger, and a set of changes to be made to the POM. If that profile has been activated, for example, a project built for test environment may point to a different database than that of the final deployment, or dependencies may be pulled from different repositories based upon JDK version used. The element of profiles are there. Activations are the key of the profile. Power of profile comes from its ability to modify the basic POM only under certain circumstances. Those circumstances are specified via an activating element. The base built element set, if we revisited, the reasons for two types of built element reside in fact that that does not make sense for a profile to configure built directories and extension as it does in the top level of a POM. Regardless of in which environment the project is built, some values will remain constant, such as directory structure of a source code. If you find your project needing to keep two sets of code for different environments, it may be prudent to investigate refactoring project into two or more separate projects. Here you can see POM, and you can see POM relationships. Under that you can see coordinates. Under that you can see group ID, artifact ID, and version. You can see on aggregation, and you can see modules under that, and you can see inheritance under POM relationships. Here you can see parents, dependency management, and under dependencies you can see dependency management and dependencies. Here you can see project information under POM, and you can see name, description, URL, inception year, licenses, developers, contributors, and organization under project information. Here you can see build system under POM, and you can see properties, packaging, build, and reporting under build system. Here you can see build environment under POM, and you can see environment information, Maven and Maven environment under build environment. You can see issue management, CI management, mailing list, and SCM under environment information. And you can see pre-request, repositories, distribution management, profiles under Maven environment. And you can see repositories, plugin repositories, and repositories and plugin repositories under repositories. And you can see profile under profiles, and activation and suffix elements under profile. Here you can see element may be overridden at least mostly by profile element settings. Here modules, dependency management, build, reporting, repositories, plugin repositories, distribution management, and profile elements that are the asterisk dash suffix element here under profile. These are the element contains element meant for inheritance. Here you can see dependency management and build. Here you can see the super pom is always the best parent. The super pom all Maven projects POMs extend the super POM, which defines a set of defaults shared by all projects. The super pom is a part of Maven installation. Depending on the Maven version, it can be found in the maven-x.y.z- etc.jar or maven-model-builder.xy.z.jar file in $open curly brace m2 underscore home close curly brace /lib. If you look in this jar file, you will find a file named pom-4.0.0.xml under the org.apache.maven.model package. It is also published on the Maven reference site that is available on each version of Maven separately, and for example Maven 3.1.1, it can be found on the Maven model builder documentation. Here you can see inherit from. So com.company.killerapp-stores 1.0-snapshot is inherit from here, and com.mycompany-killer-app-api 1.0-snapshot and com.mycompany-killer-app-model 1.0-snapshot are inherit from these three inherit from com.mycompany-killer-app 1.0-snapshot, and this is this inherits from superpom here. Here you can see the default lifecycle bindings, packaging pom. Here you can see the phases and the plugin goals here, this package and install, deploy. Here you can see the plugin bindings for packaging. Here you can see the Maven install plugin install and Maven deploy plugin deploy. Here you can see again, this diagram shows what is pom. Here you can see the pom.xml here. Pom or project object model is the basic unit of Maven. POM is actually an XML file that contains all the configuration and information which is useful to build the Maven project. Inside POM, the configurations which are specified are nothing but the dependencies and goals that can be executed. You can specify some other information as well inside POM, like project version, developers, mailing list, etc. Here you can see the pom.xml here, and here you can see the POM project object model is connected to POM, and here project object model interacts with dependency manager. Dependency manager is connected to repositories, and project object model and dependency manager interacts with project lifecycle. Project lifecycle interacts with plugins. Plugins interacts with source code, generated code, resources, binary files. Sorry, actually plugins are connected to source code, generated code, resources, and binary files. Here you can see the advantages. Here the main advantage of pom.xml are when you declare the required dependency inside the pom.xml, then the Maven download all the required dependencies in the form of a jar. It will be available to to Java class path in Eclipse IDE, for example. You can also add new libraries to projects. You don't have to search anywhere to download the files. Maven automatically download all the required files for the given version from the Maven central repository. It can work in IDEs, in the CI servers, as well as on the command line. Here you can see Maven reads, step 1 reads pom.xml, then the download dependencies into the local local repository. 3 the execute life cycles, build phases, and or goals, then executes plugins, all execute according to the selected build profile. Here you can see Maven is connected to POM file via reads pom.xml. Within the POM you can see build life cycles. It has goals and phases and goals, and dependencies, jars, build plugin, and build profiles. Dependencies, jars are connected to Maven local repository. Here you can see the visual of plugin element. The types of plugin, broadly plugins are of 2 types. Build plugins configured in POM for project POM under the build element. Such plugins are executed as part of the default build lifecycle. Reporting plugins configured as the project POMs under reporting element. Such plugins are executed as part of the site lifecycle. Furthermore, plugins can be classified as core plugins where goals are bound to the core phases. Clean, compile, install resources, etc. Packaging plugins related to output artifact packaging. Examples include plugins EAR, Java, etc. Reporting plugins related to the site lifecycle and used to generate reports. Examples include check style, Javadoc, project info, reports, etc. Tooling plugins related to general tooling during the Maven execution. Examples include assembly help, enforcer, tools chain, etc. Plugin from Maven versus custom plugins. The official Maven plugins developed as part of the Apache Maven have standard naming convention. Plugin dash plugin short name dash plugin. This naming convention is reserved as should not be used by plugins which do not have group ID of org.apache.maven.plugins and are not found on the Maven repository under org/apache/maven/plugins directory. Plugins developed with other group IDs typically have the name of plugin short name dash maven dash plugin. Standard plugins from Apache Maven have consistent site structure under common site https maven.apache.org plugins index then .html. Each plugin landing page has a few menu items under its navigation panel. Introduction page which provide an overview of the plugin. The goals page which lists all goals defined by the plugin and a deep explanation of goals intent. The usage page provides configuration options and any relevant information regarding constraint for the plugin. And FAQ page is for responses for frequently asked questions. There are additional pages for license and download of the plugin as well. In addition to the standard menu items, the plugin landing page can provide links to examples and project documentation. The plugin site is the best way to start understanding plugin provided by Apache Maven. Plugins developed by external to Apache Maven should attempt to follow the similar conventions to ensure easier implementation by users. How to use plugins in the project POM. The plugins are configured in POM under either build or the reporting or the profiles, then profile element. The plugin can be located using standard Maven GAV group artifact version coordinates. In addition to the location coordinates, the plugin has few other elements that are optional. Extensions. The extension flag to an extension. The extensions is a flag to determine if Maven extensions from the plugin should be loaded. The value is a true or false. However, the current data type in the schema is a string for some technical reasons. The default value is the false and it is rarely enabled. Typical use cases for enabling this is when defining custom lifecycle or packaging types. Inherited is a boolean flag that is true by default. As with extension, the data type in the schema is a string. Setting inherited to false prevent propagation of the configuration to any child POM of the current one. Executions. The execution is a complex element and contains set of execution elements. As its core, Maven executes such definitions. The execution specified the set of goals to execute defining during the life cycle. The execution is a complex element that has a unique ID, phase, a phase to bind, and one or more goals to an inherited flag, similar to the one defined for a plugin, and also set as a string data type. The goals element, which is set a string goal element that are bound to the phase, and the generic configuration element. Dependencies. Dependencies is a complex element and contains a set of dependency elements. The dependency defines the listed the dependency elements. Configuration is a complex element which allows for a free form DOM configuration used by the plugin. Configuration specified specifics are typically listed and recommended in case of custom plugins in the usage page for a given plugin. Plugin inheritance. Plugins have inheritance logic similar to dependencies. A plugin declared in a parent pom is inherited into the child pom unless the parent declared inheritance flag to false. Setting the inheritance flags to false break the inheritance. In addition, the plugin management section in the pom functions the same way of dependency management works for a dependency. There's currently no equivalent in a build of materials for a plugin, although there is an open source issue for introducing such facility. Mixing Maven plugin, not officially an Apache Maven plugin, but the mixing-maven plugin deserved a special mention. The plugin allows for including multiple plugin management sections without needing to inherit the plugins from a single parent. Using this plugin allows a build behavior to be made more modular. Here you can see the Maven pom plugins. Here you can see group ID, artifact ID, version, extensions, and inherited. Here the executions, and under execution and execution is there, and under execution ID, pace, inheritors, and goals, and configuration. Under goals you can see goal. Here you can see dependencies and configuration. Here we are considering how does Maven assemble the effective POM. An effective POM is an assembly of execution steps, properties and profiles, the content that Maven can execute for a project, and an exhaustive set of dependencies and plugins needed for such an execution, determination of any transitive dependencies of independencies, full depth imaginable, any conflict resolution in terms of dependency version. How does Maven assemble the effective POM? Maven assemble its effective POM by traversing the layers that act as building blocks. Each layer used as the ability to override or enrich the content of what become the effective POM. Maven internal defaults and super POMs are built built into the Maven installation, so ideally not subject to customization. The layers below the global settings and user settings are, as their name suggests, inclined towards the hosting and overriding any settings for Maven. The parent bill of material and project POMs are where Maven instructions can be customized. Default values above the layers are utilized if no customization is made. Now we are going to explain the layers. They're going through the layers here. Maven internal defaults. This layer is within the Maven's own code unless the intent is to modify the Maven source code. It is safe to assume that the default are not modifiable. The location is internal to the Maven installation. Maven superpom. This superpom exists in the Maven own code. Once again, unless the intent is to modify Maven's own source code, it is same to assume that the superpom is not modifiable. Location is internal to the Maven installation. Maven global settings. The Maven one Maven is installed or unarchived on a computing device. It creates a directory structure. One of these base directories listed base directories is conf. This directory contains settings.xml, referred to as global settings file. Since this file extent exists on the local computing device, it is editable. Typically, any settings that apply to all projects being managed on the computing device are managed in this global settings.xml. Examples may include proxy settings, corporate server URLs, mirrors, etc. It should not often be modified in any case. Location is in Unix and Mac OS. Maven installation /conf/settings.xml. In Windows, Maven installation /conf and /settings.xml. Maven user settings, similar to global settings but at a different location. It is possible to create a user settings file. This file is named also named settings.xml, but it is its location is under user home in an .m2 directory. The purpose of the user settings.xml is to set up any settings that apply to projects managed by a specific user. There could be multiple users on a given computing device. Examples include the usernames and passwords to connect to network, repository ordering, etc. Locations, Unix or macOS, user.home /.m2./settings.xml. In Windows, user.home for /.m2/settings.xml. Parent or build of materials POMs. Maven has an inheritance and version trait model. Maven can inherit content from and version traits from a build of materials POM. Typically, parent POMs contain reusable dependencies, plugins, and properties used by a project POM. The build of material POM is a specialized POM that allows group together dependency versions of dependency that are known to be valid and tested to work together. Using BOM POM reduces the developer grief from having to test compatibility of different dependencies. Modification of either is possible if there is a need and entitlement to change. Since changes to either can impact several other projects, appropriate version increment and reuse are recommended for changes. The locations is various locations either on device or elsewhere in some repository. Project POM, this is the project object model for the project. Project specifies specific Maven instructions are detailed in this location. Typical content include a unique set of coordinates used to identify the project name and description of the project, a set of developers associated with the project, any source control management details specific to the project, all project specific dependencies and plugins, any profiles that allow for alternative executions of Maven on this project, and so on. All this will be covered in the file containing this POM is by convention named pom.xml, but other names can be used. If an alternative name is used, then the Maven executable will need to be pointed to the file name of for the execution. The location Unix or Mac $project /pom.xml. In Windows $project /pom.xml. Here you can see effective POM here, and here you can see Maven internal default. Each lower section overrides the prior values. Maven super POM, base POM, all other POMs inherited this POM. Maven global settings located in the conf directory under the Maven installation directory. Maven user settings located in the .m2 directory under the user home directory. Parent or bill of materials POMs, inheritance and trait structured for project POMs to inherit from. Maven project POM, content of the project POM, and here you can see effective POM. Here you can see hierarchies, POM hierarchies. Here we are going to describe the hierarchy of Maven POMs. Parent POM. The parent POM is a POM from which the current project POM can be inherited. For the project current POM can inherit content. The project POM can depend on exactly one parent POM. This single parent inheritance is one way. The parent POM is unaware of the POMs that inherit from it. Here. The single parent inheritance is one way. The parent POM is unaware of the POM that inherits from it. The child POM declares the parentage in its own pom.xml. The standard file to hold the POM can be customized to a different name. Any number of POMs can declare another POM as their parent. Usage, while we will delve into the content in the future, the parent POM can be used to declare reusable portions of the POM that individual child POM can inherit. This helps in both maintenance and to reduce clutter. Aggregator POM. The aggregator POM, also known as reactor POM, that can sequence the build of many projects. An aggregator POM specifies all the projects that can be built, managed together. The child POMs, remain unaware of the aggregator POMs that invoke it. A child POM can be listed in more than one aggregator POMs. The aggregator POMs list the child POM by name in its own pom.xml as a module. As the declared module suggests, this pattern is for modular builds of projects. There is no inheritance of any content from the aggregator POM. Usage, while the aggregator POM can be used to ensure the sequence of build and maintain a list of projects that should be built, managed together. Build of materials POM. Build of materials POM is a POM that can declare bundles of dependencies that have been tested to work well together. The abundance of artifacts and versions of each can at times lead to confusion and needs for trial and error mechanism to determine compatibility or might function right functionality. A build of material POMs reduces that overhead. Build of material POM is a means of multiple inheritance too. Since a project POM can import multiple build of material POMs, the build of material POMs is unaware of the child POMs that import it. The child POMs declare the build of material in the project POM. Usage, the build of material POMs can be used to bundle well working dependencies with right versions together to avoid repetition for every project. The POM can be both parent as well as aggregator. This allows for a two-way relationship in a tightly knit set of modules that depends on a common set of inheritance content. Here you can see POM hierarchies. Here you can see percentage. Here the parent is connected to another parent. Parent POM is connected to another parent POM via dependencies, plugins, properties, and another parent POM is connected to here the project POM via dependencies, plugins, and properties. Here the child knows the parent, and parent doesn't know the child. Here you can see the aggregation. Here the aggregate POM is interact with the POM. Here the POM 1, project 1 POM, project 2 POM, project 3 POM, and project 4 POM via no inheritance of contents. The child does not know aggregator, and aggregator knows child. Here you can see the build of materials. Here the build of materials POM is connected to project 1 POM, project 2 POM, project 3 POM, project 4 POM. Likewise, the project POMs via dependencies, plugins, and properties. here the child knows build of here the child knows build of materials. The build of materials does not know the child. Here we are considering transitive dependencies. With direct dependencies, the things you use yourself in your own code for the own code, and transitive dependencies things so here in the direct dependency, things you use yourself in your own code. For the transitive dependencies, things others use for things you use, pulled in recursively. Here you can see that your code is connected to direct dependency A, direct dependencies. Here the A and B, and here the direct or transitive dependency Z, and here the direct dependency B is connected to direct or transitive dependency Z here. Here your code then direct dependency B is connected to direct or transitive dependency Z. Here the direct dependency is connected to transitive dependency TA and TB, and here the transitive dependency TB and direct dependency B is connected to transitive dependency TC. Now we are considering bill of materials BOM. Larger projects like Payakara, Amazon, SDK, etc. provide list of direct dependencies. This comes in handy when adding these dependencies transitive for us as a direct dependencies like here. Here you can see your POM, and your POM is connected to your POM inherits Maven super POM, and your POM import is connected to some BOM via import, and some BOM is depend on direct and transitive dependency, and here the your POM depend on some version direct and transitive dependency here. Here you can see the parent POM and super POM. Any project may be a child of a parent. Project silently inherit from super POM, which is a global Maven standard parent POM. Children may also be aggregated by a parent without them knowing, or for convenient built for larger projects. Here you can see any POM inherits Maven super POM, and parent one POM inherit Maven super POM, and parent one POM aggregate submodule 1 POM and submodule 2 POM here. Now here you can see the parent POM and super POM. The children may children may inherit dependencies, properties and settings and plugins, etc. from parents, making it possible to share common ground. Both apertures may combine. May be combined. The children may import as many BOMs as they want, but can have only a single parent to inherit from at a time. Here you can see parent pom inherits Maven super pom. Here the parent pom aggregates submodule 1 pom and submodule 2 pom here, and submodule 1 pom inherits parent and submodule 2 pom inherits parent pom, and here the dependency here inherit is parent submodule 1 pom is connected to dependency via inherit depends on, submodule 2 pom is connected to dependency via inherit depends on, and parent pom is connected to dependency via depends on. Here you can see transitive dependencies. Maven is compatible. Maven is comfortable for developers. It handles recursive resolution, downloading and adding and dependency of dependencies. However, as lifecycle of a box coordinate, you might find yourself in version conflict hell sooner or later without knowing, but experiencing unintended side effect. When you look at the topmost in this case here the version 2.0 will be included. If you know something about semantic versioning, the red alert should ring in your mind right now. How do we know that B is compatible with Z version 2.0 when depending on Z version 1.0? Another scenario getting us in trouble, a direct use of transitive dependencies. Imagine the following: we rely on Z in our code, but do not include a direct dependency for it. Within the POM, now assume B is updated and removed its dependency on Z. You definitely don't want to head down that road. Follow the rules to be safe. 1. Do not use transitive dependencies implicitly. Add the direct dependency for transitive depths you reuse in your code. 2. On every build, check that no implicit usage was added by accident. 3. Explicitly declare versions of transitive dependencies in use of multiple direct dependencies. On every build, check that there are no converge problems hiding in the shadows. 5. Do special test on every build to verify these explicit combinations work. You can manage versions of transitive dependencies in 4 ways. One is explicitly declare transitive dependency in dependency management within the version tag. That's a good and safe practice. And 2 is for more complex transitive dependency, use bill of materials BOM within dependency management. Many bigger projects provide them, making the POM much less bloated compared to adding every bit yourself. That's a safe and good practice. And 3, using optional and exclusion tags on direct dependency that request the transitive dependency. Last resort, you really should avoid this, not explained or used here. It's better to avoid or don't. And 4, make transitive only dependency not used in code and direct use 1 and add version tag. Typically bad idea, don't do that. And this is another better avoid or don't. And here you can see your code is connected to direct dependency B, and here set version 2.0 and direct dependency B is connected to shared version 1.0 here. Here you can see a short comparison with Ant in Maven dependency management. What is the difference between Maven dependency management and ant dependency management? First of all, the ant only manages project build phases, delegating dependency management to Apache Ivy. This works together. Therefore, the two tools handles a different task in details. First, the ant runs built from build.xml file. Ivy downloads dependencies written in a list inside iv.xml file into local repository. On the other hand, the Maven manages both aspect build phases and dependencies starting from a single file called pom.xml. The note this actually the Maven has built-in phases that can be managed by developer from pom.xml. On the other hand, working with ant phases must be created from build.xml. Here you can see here the ant project root directory. Here the build.xml is content to contain the description of build phases, and here iv.xml is content to contains dependencies list. Here the Maven project root directory, and here the pom.xml is content to contains description of build phases and the dependencies list. Here you can see the structure of the pom.xml file. The pom file is an XML file that contains all project information and instruction for Maven program MVN to build the project. Here's a quick description of pom file with the main section and how to fill them. Again, here you can see the parent pom reference. This is optional, and here you can see then we are coming to artifact definition and description. Here you can see the artifact ID, the unique ID name, no uppercase character and space. Group ID, unique group ID, institution name, no uppercase character and space. Version number, format is major.minor, patch add dash snapshot suffix for in progress version. Here you can see the packaging, name, description, URL, organization, licenses, developers, etc. Here you can see a build definition. The instruction used to build the project, Java compiler, Java compiler version, inclusions, exclusion, or inclusions or exclusions patterns, specific specific jar generation. Lot of things can be done here. Here the list of dependencies, all dependencies required by the projects. Here the external repositories, links, external repository links and deployment information. Give the give target link for third-party artifacts and target link for uploading the artifact on the Maven server. Here you can see the version requirements have the following syntax in dependency version requirement specification. Dependencies version element define versions requirements which are used to compute dependency versions. Soft requirements can be replaced by different versions of the same artifact found elsewhere in the dependency graph. Hard requirements mandate the particular version or versions and over soft requirements. If there are no versions of the dependency that satisfy all hard requirements for that artifact, the build fails. The version requirements have the following syntax. Here the soft requirement for 1.0 and use 1.0 if no other version appears earlier in the dependency tree. Here the hard requirement for 1.0 use 1.0 and only 1.0. Here the hard requirement for any version less than 1 point less than or equal 1.0. Here the hard requirement for any version between 1.2 and 1.3 inclusive. Here the 1.0 less than grade less than or equal x less than or equal and less than or equal 2.0. The hard requirement for any version between 1.0 and inclusive and 2.0 exclusive. Hard requirement for any version greater than or equal to 1.5. Hard requirement for any version less than or equal to 1.0 then or greater than or equal to 1.2 but not 1.1. Multiple requirements have separate commas. Here the hard requirement for any version except 1.1. For example, because 1.1 has the critical vulnerability, Maven picks the highest version of each project. Maven picks the highest version of each project that satisfy all the hard requirement of the dependencies on that project. If no version satisfies all the hard requirements, the build fails. Now as an example, we can consider the minimum requirement for a POM are following. The minimum requirement for a POM are following here: project, root, model version should be at least should be set to 4.0.0 this version, and group ID, the ID of the project's group, artifact ID, the ID of the artifact project, the ID of the artifact project, version, the version of the artifact under the specified group. The POM requires that it's a group ID, artifact ID, and version be configured. These are three values from project's fully qualified artifact name. This is in the form of group ID colon artifact ID colon version. As an example, we can consider here com.mycompany.app colon my dash app colon 1. Also, if configuration details are not specified, Maven will use their defaults. one of these default values is the package type. Every Maven package, every Maven project has a package name, package type. If it is not specified in the pom, then the default value jar would be used. Furthermore, you can see that in the minimal pom here, the repositories are not specified. If you build your project using the minimal pom here, it would inherit the repository's configuration in the super pom. Therefore, when Maven uses the dependencies in this minimal pom, it would know that these dependencies will be downloaded from https repo.maven.apache.org/maven2, which has specified in the super pom. As an example 2, we can consider this one, the plugins. Here, beyond the standard coordinate of group ID artifact ID version, there are elements which configure the plugin or these builds interact with extensions, true or false, whether or not to load extensions of this plugins. It is by default false. Extensions are inherited, true or false, whether or not this plugin configuration should apply POMs which inherit from this one. Default is true. Configuration, this is specific to individual plugin. Without going too in depth into the mechanics of how plugin works, suffix it to say that whatever properties that the plugin mojo may expect, these are getters and setters in the Java mojo bin, for example, can be specified here. In this example, we are setting the classifier property to test maven jar.plugin in mojo. It may be good to note that all configuration elements, wherever they are within POM, are intended to pass values to another underlying system, such as a plugin. In other words, values within configurations element are never explicitly required by the POM schema, but the plugin goal has every right to require configuration values. Dependencies are seen a lot within POM and are an element under all plugin element blocks. Dependencies have the same structure and function as under the base build. The major difference in this case is that instead of applying as dependencies of the project, they now apply as dependencies of the plugin that they are under. The power of this is to alter the dependency list of a plugin, perhaps removing an unused runtime dependency via exclusions, or by altering the version of a required dependency. Executions. It is important to keep in mind that the plugin may have multiple goals. Each goal may have a separate configuration, possibly even building a plugin goal to a different pace together. Executions configure the execution of a plugin goals. For example, suppose you wanted to bind the /run goal to the verify pace. We want the task to echo the build directory as well as avoid passing on this configuration to its configuration, assuming it is a parent by setting inherited or false. Now we are considering the field static final pom here in interface type in package org.apache.maven .api. Now we are considering a package org.apache.maven.api.model, Maven immutable pom, project object model classes generated from Maven.mdo model. The root class is model. Now we are considering interface super pom provider in package org.apache.maven.api.services provides the super pom that all models implicitly inherit from. Now we are considering Maven. This is reference for the Maven project descriptor used in Maven. The project in Maven, this element is the root of the descriptor. It has elements like group ID, artifact ID, version, relative path. Regarding API, the interface project in package org.apache.maven.api interface representing a Maven project. Projects can be built using project builder service. Parent, this element contains the parent element contains information required to locate the parent project from which this project will inherit from. Not the children of this element are not interpolated and must be given as literal values. With regarding API, the class parent in package org.apache.maven.api model, the parent element contains information required to locate the parent object from which the project will inherit from. Not the children of this element are not interpolated and must be given as literal values. Organization specifies the organization that produces this project. With the API class organization in package org.apache.maven.api.model specifies the organization that produces this project. License describe the licenses for this project. This is used to generate the license page of the project's website, as well as being taken into consideration in other reporting and validation. The licenses listed for the project are that of the project itself and not of dependencies. The class license in package org.apache.maven.api.model describe the licenses for this project. This is used to generate the license page of the project's website and as well as the being taken into consideration in other reporting and validation. The licenses listed for the project are that of the project itself and not of dependencies. Developer information about the one of the committers on this project. The class developer regarding API, the class developer in package org.apache.maven.api.model information about one of the committers on this project. Contributor, description of a person who has contributed to the project but who does not have commit privileges. Usually these contributors come in the form of patches submitted. Class regarding API, class contributor in package org.apache.maven.api.model description of a person who has contributed to the project who does not have commit privileges. Usually these contributions come in the form of patches submitted. Mailing list, this element describes all of the mailing lists associated with the project. The auto-generated site references this information. The class mailing list in package org.apache.maven.api.model. This element describes all of the mailing list associated with the project. Auto-generated site references this information. Pre-request describe the pre-request a project can have. Class pre-request in package org.apache.maven.api.model describe the pre-request a project can have. SCM, the SCM element contains information required to the SCM source control management of a project. Regarding API, the class SCM in package API.model. The SCM element contains information required to the SCM source control management of the project. Issue management. Information about the issue tracking or bug tracking system used to manage this project. Class issue management in package API.model. Information about the issue tracking or bug tracking system used to manage this project. CI management. The CI management element contains information required to the continuous integration system of the project. The class CI management in package API.model. The CI management element contains information required to the continuous integration system of the project. The notifier configures one method for notifying users or developers when the build breaks. Class notifier in package API.model configured one method for notifying users or developers when a build breaks. Distribution management. This element describes all that pertains to distribution for a project. It primarily used for deployment of artifact and the site produced by the build. Class distribution management in package API.model. This element describes all that pertains to distribution for a project. It's primarily used for deployment of artifact and the site produced by the build. Releases. The download policy. With regarding API, the method at not null public deploy repository dot releases repository policy releases in class deployment repository dot builder in package Apache.maven.api.model. Snapshots is a download policy, and in regarding API at not the method at not null at non-null public deployment repository dot builder snapshots repository policy snapshots in class deployment repository dot builder in package Apache.maven.api.model. Relocation describes where an artifact has moved to. If any of the values are omitted, it is assumed to be the same as it was before. Class relocation in packaged API.model describe where an artifact has moved to. If any of the values are omitted, it is assumed to be the same as it was before. Dependency management section for management of default dependency information for use in a group of POMs. Regarding API, the class dependency management in package API.model section for management of default dependency information for use in a group of POMs. The dependency element contains information about dependency of the project. The class dependency in package Apache.maven.api.model. The dependency element contains information about the dependency of the project. Exclusion. The code the exclusion element contains information required to exclude an artifact to the project. The class exclusion in package Apache.maven.api.model. The exclusion element contains information required to exclude an artifact to the project. Build. The build element contains information required to build the project. Default values are defined in a superpom. Regarding API, the class built in package Apache.maven.api.model. The build element contains information required to build the project. Default values are defined in the superpom. Extension. Extension describes build extension to utilize. With regarding API, the class extension in package Apache.maven.api.model describe build extension to utilize. Resource. This element describe all the class path info resources associated with the project or unit test. With regarding API, the class resource in package Apache.maven.api.model. This element describe all of the class path resources associated with the project or unit test resource. This element describes all of the class paths resources associated with the project or unit test. With regarding API, the method at non-null public build.build test resources, collection resource, test resources in class build.build in package api.model. Plugin management, section for management of default plugin information for use in a group of POMs. With regarding API, the class plugin management in packaged org.apache.maven.api.model, section for management of default plugin information for use in a group of POMs. Plugin, the plugin element contains information required for a plugin. The class plugin in package org.apache.maven.api.model. The plugin element contains information required for a plugin. Execution, the execution element. The execution element contains information required for execution of a plugin. With related to API, the class plugin execution. In the package org.apache.maven.api.model. The execution element contains information required for execution of a plugin. Reporting, section for management of reports and their configuration. With regarding API, the class reporting in package org.apache.maven.api.model, section for management of report and their configuration. Plugin, the plugin element in contains information required for a report plugin. Regarding API, the class plugin in package org.apache.maven.api.model. The plugin element contains information required for a plugin. Report set represent a set of reports and configuration to be used to generate them. With regarding API, the class report set in package org.apache.maven.api.model represent a set of reports and configuration to be used to generate them. Profile, modification to the build process, which is activated based on the environment parameters, so command line arguments. Regarding API, the class profile in package org.apache.maven.api.model, the modification to the build process, which is activated based on the environment parameters, so command line arguments. Activation, the conditions within a build runtime environment which will trigger the automatic inclusion of a build profile. Multiple conditions can be defined which must be satisfied to activate the profile. Regarding class API, the class activation in package org.apache.maven.api.model, the conditions within the build runtime environment which will trigger the automatic inclusion of build profile. Multiple conditions can be defined and which must be all satisfied to activate the profile. OS, this is an activator which will detect an operating system's attribute in order to activate its profile. Class, with regarding API, the class activation OS in package org.apache.maven.api.model. This is an activator which will detect an operating system's attribute in order to activate its profile. Property, this is the property specification used to activate the profile. If the value is an empty, then the extension of the named property will activate the profile. Otherwise, it does case sensitive match against the property value as well. With regarding API, the class activation property in package org.apache.maven.api.model. This is the property specification used to activate a profile. The value field is empty. Then the extension of the name property will activate the profile. Otherwise, it does the case sensitive match against the property value as well. File. This is the file specification used to activate the profile. The file value is the location. The missing value is the location of the of a file that needs to exist, and if doesn't, the profile will be activated. On the other hand, the exist will test for an existence of the file, and if it is there, the profile will be activated. With regarding API, the class activation file in package org.apache.maven.api.model. This is the file specification used to activate the profile. The missing value is the location of the file that need to exist. and if it doesn't, the profile will be activated. On the other hand, the exist will test for existence of the file, and if it is there, the profile will be activated. Build, the build configuration in a profile, the class built-in package or Apache.maven.api.model. The built element contains the information required to build the project. Default values are defined in the super pom. Now we are considering what is pom in introduction to pom. The example for this is the build directory with the file regarding the file structure, which is the target, the source directory, which is the source main Java, the test source directory, which is source test Java, and so on. And a project object model, or pom, is a fundamental unit of work in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build the project. It contains different default values for most projects. Example for this is the build directory, which is the target, the source directory, which is source main Java, and the test directory, which is source test Java, then and so on. When executing a task or goal, Maven looks for a pom in the current directory. It reads the pom, gets the needed configuration information, then executes the goal. Some of the configuration that can be specified in the pom are the project dependencies, the plugins or goals can be executed, the build profile, and so on. Other information such as project version, description, developers, mailing list, and such can be specified. Now we are considering a super pom. You can see the super pom for Maven 3.6.3 in Maven core reference documentation. This is a segment of it. The super pom is Maven's default pom. All poms extend the super poms unless explicitly set, meaning the configuration specified in the super pom is inherited by the poms you created for your projects. Now we are considering minimal pom. Here is an example. The minimum requirement for a pom are following here. Project root, model version should be set to here 4.0.0 here. Group ID, the ID of the project's group. Artifact ID, the ID of the artifact's project. Version of the artifact under the specified group. Here's an example. Pom requires its group ID, artifact ID, and version be configured. These three values from the project's fully qualified artifact name. This is in the form of group ID, colon artifact ID, colon version. As for the example here, its fully qualified artifact name is com.company.app colon my-app colon 1. Also, as mentioned before, if the configuration details are not specified, the Maven will use their defaults. One of those defaults values is the packaging type. Every Maven project has a packaging type. If it is not specified in the pom, then the default value jar would be used. Furthermore, you can see the minimal pom, the repositories were not specified. If you build your project using minimal pom, it would inherit the repositories configuration in the super pom. Therefore, the Maven sees the dependencies in the minimal pom. It would know that these dependencies will be downloaded from https://report.maven.apache.org/maven2, which was specified in the super pom. We are considering example in project inheritance. The example com.mycompany.app colon my-module colon 1 pom. Here the as an example, let us reuse the artifact, this one, the com.company com.company.app my dash app 1:1, and let us introduce another artifact com.mycompany dot app colon my dash module colon 1. Here this one, and let us specify their directory structure as the following. They note the my dash module /pom.xml is the pom of the com.company dot app colon my dash module colon 1, while the pom.xml is the pom of the com.company dot app colon my dash app colon 1. The solution is here. The now if we were to turn the com.mycompany dot this one dot app colon my dash app to 1 into parent artifact of the com.mycompany dot my dash module colon 1, so we'll have to modify the com.mycompany dot app dot my module colon 1's pom in the following configuration. This is com.mycompany dot app colon my dash module colon 1's pom. Notice that we now have an added section, the parent section. This section allows us to specify which artifact is the parent of our pom, and we do so by specifying the fully qualified artifact name of the parent pom. With this setup, our module can now inherit some of the properties of our parent pom. Alternatively, you can now if you want the group ID or version ID, group ID or the version of your modules to be the same as your parent, you can remove the group ID or version identity of your module in its pom. This allows here this one. This allows the module to inherit group ID or version of its parent's pom. Now we are considering project example in project aggregation. Here the with related to the previous scenario with the previous original artifact poms and directory structure, here the com.mycompany.app colon my dash app colon 1's pom here, and here the com.mycompany.app my dash module my module colon my dash module colon 1, and here the directory structure. The solution is here. If we want to aggregate my module into my app, we would only have to modify my app. In the revise com.mycompany.app my dash app colon 1, the packaging section and the module section were added. For packaging, its value was set to pom, and for module section we have the element module my dash module. The value of module is the relative path from the com.mycompany.app colon my dash app colon 1 to com.mycompany.app colon my module colon 1 once pom. By practice, we use the module's artifact ID as the module's directory name. Now, whenever a Maven command processes com.mycompany.app colon my dash app colon 1, that same Maven command would be run against the mycompany.app colon my dash module colon 1 as well. Furthermore, the some commands goal specifically handle project aggregation differently. Now we are considering project inheritance versus project aggregation. Here you can see com.mycompany.app colon my dash app colon 1's pom. Given the here the com.mycompany.app colon my app colon 1's pom. Here this one, and here the com.mycompany.app colon my dash module colon 1's pom. This is the and this directory structure. This is my module here. The solution is the to do the both project inheritance and aggregation. You only have to apply all three rules. The three rules are specify every child POMs in who their parents POMs is, and change the parent POMs packaging to value POM, and specify parent POMs directories in its modules. Here the here the com.mycompany.app colon my dash app colon 1's pom here. And here the com.mycompany.app colon dash dash my module, the my dash module and colon 1's pom. Now we are considering special variables in available variables in project interpolation and variables. Here the format of the Maven build timestamp can be customized by declaring the property maven.build.timestamp.format as shown in this example. The Maven Maven.build.timestamp the timestamp that denotes the start of the build UTC since Maven 2.1.-M1. The format pattern has to comply with the rules given in the API documentation for simple date format. If the property is not present, the format default to the value already given in the example. Here you can see a quick overview in a POM reference. This is a listing of the element directly under POM's project element. Notice that module version contains 4.0.0. That is the currently only supported POM version and is always required. The basics, the build settings, more project information, environment settings, now we are considering basics. This is unlike a build.xml file where the tasks are almost always dependent on the lines executed before it. The POM contains all necessary information about the project, as well as configuration of plugins to be used during the build process. This is a declarative manifestation of the who, what, and where while build lifecycle of when and how. That is not to say that POM cannot affect the flow of the lifecycle. It can, for example, by configuring Maven Ant plugin. You can embed Apache Ant task inside the POM. It is ultimately a declaration, however, whereas a build.xml tells the Ant precisely what to do when it is run procedural. The POM states its configuration declarative. If some external force causes the lifecycle to skip and the Ant plugin execution, it does not stop plugins that are executed from doing their magic. This is unlike a build.xml file where the tasks are almost always dependent on the lines executed before it. Now we are considering Maven coordinates in basics. This marks a specific place in the repository acting like a coordinate system for Maven projects. The project defines before bare minimum that allows the group ID dot artifact ID group ID colon artifact ID colon version are all required fields, although group ID and version do not need to be specifically defined if they are inherited from a parent. The three fields act much like an address and timestamp in one. This makes a specific place in a repository acting like a coordinate system for Maven projects. Group ID. This is generally unique amongst an organization or a project. For example, all core Maven artifacts do should live under the group ID or Apache.maven. Group IDs do not necessarily use the dot notation. For example, JUnit project. Note that the dot notation notated Group ID does not have to correspond to the package structure that the projects contain. It is, however, a good practice to follow. When stored within the repository, the group I acts much like the Java packaging structure does in operating system. The dots are replaced by OS-specific directory structure such as / in Unix, which becomes a relative directory structure from the base repository. In the example given, the the org.code host.mojo.group Mojo group lives in the directory $m2 underscore repo / code host /mojo. Artifact ID. The artifact ID is the generally name that the project is known by. Although the group ID is the important, people within the group will rarely mention the group ID in the discussion. They are often all be the same ID, such as Mojo host project group ID, org.code host.mojo. It along with the group ID creates a key that separates this project from every other project in the world. At least it should. Among with the group ID, the artifact ID fully define the artifacts living quarters within the repository. In the case of above project, the my project lives in $m2 underscore repo / code host / mojo / my project. Version. This is the last piece of the naming puzzle. Group ID artifact ID denotes a single project, but they cannot delineate which incarnation of the projects we are talking about. Do we want the JUnit of 2018 version 4.12 or the 2007 version 3.8.2? In short, code changes, those changes should be versioned, and this element keep those versions in line. This is also used within an artifacts repository to separate versions from each other. My project version 1.5 files live in the directory structure $m2 underscore repo / org / quotas / mojo / my project 1.0. The three elements given here point to a specific version of a project. Letting Maven know who we are dealing with and when its software lifecycle we want to use, we want them. Now we are considering packaging. We could make it into a var by declaring a different packaging. In API, the method at not null public model.builder packaging string packaging in class model.builder in package apache.maven.api.model. Now we have addressed the structure of group ID artifact ID version. There is one more standard label to give us really complete what that is the project's packaging. In our case, the example pom for org.code host.mojo mojo my project 1.0 defined above will be the package previous one as jar. We could make it into a var by declaring a different packaging. When no packaging is declared, Maven assumes the packaging is the default jar. The valid types are plexus role hints. Read more on plexus for explanation of roles and role hints of the component role. org.apache.maven.lifecycle.mapping.lifecycle mappings. The current core packaging values are pom, jar, maven -plugin, egb, var, er, rar. These define the default list of goals which execute on each the corresponding build lifecycle stage for a particular package structure. Now we are considering dependencies in POM relationships. As an added bonus, the Maven brings on the dependencies, those dependencies, transitive dependencies, allowing for your list to focus solely on the dependencies your project requires. With the API, we can consider at not null public model.builder dependencies collection dependencies in class model.builder in package org.apache.maven.api.model. The cornerstone of the POM is its dependency list. Most project depends on others to build and run correctly. If Maven does for you is the manage this list, you have gained a lot. Maven downloads and links the dependencies on compilation, as well as other goals that require them. As an added bonus, Maven plugins in the dependencies of those dependency transfer dependencies, allowing your list to focus solely on the dependencies your project requires. Group ID and artifact ID and version. You will see this element often. This trinity is used to compute the Maven coordinates of a specific project in time, demarcating it as a dependency of this project. Purpose of this computation is to select the version that matches all the dependency declaration due to transitive dependencies. There can be multiple dependency declaration for the same artifact. The value should be group ID and artifact ID directly corresponding to the group coordinates of the dependency, and version, the dependency version requirement specification that is used to compute the dependency's effective version. Since the dependency is described by Maven coordinates, you may be thinking this means that my project can only depend upon the Maven artifact. Answer is of course, but that's a good thing. This focuses you to depend solely on dependencies that Maven can manage. There are times, unfortunately, when a project cannot be downloaded from the central Maven repository. For example, the project may depend on a jar that has a closed source license which prevent it from being a central repository. There are three methods for dealing with this scenario. One, install the dependency locally using install plugin. The method is simplest and recommended method. To create your own repository and deploy it there. This is a favorite method for companies with the intranet and need to be able to keep everyone sync. There is a Maven goal called deploy-file, which is similar to the install-file goal. Read the plugins goal page for more information. 3. Set the dependency scope to system and define the system path. That's not recommended, however, but leads to us to explaining the following element. Classifier distinguishes the artifact that were built using from the POM but differ in the content. It is the same optional and arbitrary string that if % is append to the artifact name just after the version number. As a motivation for this element, consider for example a project that offers an artifact targeting Java 11, but at the same time it's also an artifact that still supports Java 1.8. The first artifact could be equipped with the Java with the classifier JDK 11 and the second with the JDK 8, such that client can choose which one to use. Another common use case for classifiers is to attach secondary artifact to the project's main artifact. If you browse the Maven Center repository, you will notice that the classifier sources and Java docs are used to deploy the project source code and API docs along with the package class files. Type corresponds to the chosen dependency type. Default to jar. When it usually represents the extension on the file name of the dependency, that is not always the case. A type can be mapped to a different extension and a classifier. The type often corresponds to the packaging used, though this is also not always the case. Some examples are jar, EJB, dash client and test dash jar. New types can be defined by plugins that set extensions to true. So this is not a complete list. Scope, this element refers to the class path that of the task at hand, compiling and runtime testing, etc., as well as how to limit the transitivity of dependency. There are 5 scopes available. Compile, this is the default scope used if none is specified. Compile dependencies are available in class paths. Furthermore, those dependencies are propagated to dependent project. Provided, this is much like compile but indicates you expect JDK or a container to provide it at runtime. It is only available on compilation and test class path, and it's not transitive. Runtime, the scope indicate that the dependency is not required for compilation but is for the execution. This is it is in the runtime and test class path but not in compiled class path. Test, this is scope. This scope indicates that the dependency is not required in the normal use of application, but it's only available for the test, compilation and execution phases. It is not transitive. And system, this scope is similar to provided, except that you have to provide this jar which contains it explicitly. Artifact is always available and is not looked up in the repository. System path, use only for dependency scope is system. Otherwise, the build will fail if this element is set. The path must be absolute, and so it is recommended to use the property to specify the machine specific path, such as $, open curly brace java.home, close closing curly brace / lib. Since it is assumed that the system scope dependencies are installed in a priori, Maven does not check the repositories for the project, but instead check to ensure that the files exist. If not, Maven fails the build and suggests that you download it and install it manually. Optional marks the dependency optional when this project itself is a dependency. For example, imagine a project A that depends upon project B. To compile a portion of code that may not be used at runtime, then we may have no need for a project B for all project. If so, the project X adds project A as its own dependency. Then Maven does not need to install project B and at all. Symbolically, if / greater than sign represent required dependency and dash greater than sign represent optional, although A equal and greater than A lead to B may be the case when building X to A to B would be the case building X. In the shortest terms, optional lets other projects know that you use this project and do not require this dependency in order to work correctly. Now we are considering properties. Their values are accessible anywhere in the POM by the using notation here, the $x, where the x is the property, or they can be used by plugins as default values. For example, in API, the public the method at non-null public model.builder properties map string properties. The properties are properties are the last required place to understand POM basics. Maven properties are value placeholders like properties in AND. their values are accessible anywhere within POM by using a notation $sign, and here the open curly brace x of close curly brace where x is a property, or can be used by plugins as default values, for example here. They come from 5 different types. One is the env.x. Prefixing a variable with env will return the shell environment. For example, $env path contains the path environment variable. The project .x a dot notated path in the POM will contain the corresponding elements value. For example, project version 1.0 is accessible via project.version. Settings.x a dot notated the path in the settings.xml will contain the corresponding elements value. Java system properties, all properties accessed via java.land.system.get properties are available as POM properties, such as open curly brace java.home close curly brace x set with the within properties element in the POM. Following project properties are reserved for Maven. Will become elements in future POM definition. Don't start your POM on properties with project. Here we are considering base built element set in built settings. Base built is exactly as it sounds, the base set of element between two built element of the POM. Here the default goal, the default goal of OP is to execute if none is given. If a goal is given, it should be defined as it is in the command line, such as jar colon jar. The same goes for the if a pace is defined, such as install. Directory, this is the directory where the build will dump its file, or in Maven parlance the build's target. It aptly default to $sign open curly brace close curly brace target directory. Final name, this is the name of the bundle project when it is finally built. Sans the file extension, for example my-project 1.0 jar. It default to $sign artifact ID and $sign version. The term file name term final name is a kind of misnomer. However, as plugins that build the bundled project have every right to ignore or modify its name, but they usually do not. For example, if the Maven jar plugin is configured to give you a jar, a class classifier of test, then the actual jar defined above will be built as my-project 1.0 test jar. Filter defines *properties files that contain list of properties that apply to resources which accept their settings. In other words, the name equal value pairs defined within the filter files replace $sign open curly brace name called close curly brace strings within resource on build. The examples here defines the filter.properties file under the filters directory. Maven's default filter directory is $ based directory / source and then / source / main / filters. Now we are considering licenses in more project information. Licenses are legal documents defining how and when the project or parts of a project may be used. Regarding API, we can consider @not_null, the method @not_null, public model.builder licenses, collection licenses in class model.builder in package of apache.model. Licenses are legal. A project should list licenses that apply directly to this project and not list licenses that apply to the project's dependencies. Name, URL, and comments are self-explanatory and have been encountered before it in other context. Using an SPDX identifier as the license name is recommended. The fourth license element is a distribution. This describes how the project may be legally distributed. The two standard methods are repo. They may be downloaded from the Maven repository, or manual. They may be manually installed. Now we are considering issue management in environment settings. Although there is nothing stopping the plugin from using this information for something, it's primarily used for generating project documentation. This defines the in the class with regarding API, the class issue management in package apache.maven.api.model. Information about the issue tracking or bug tracking system used to manage this project. This defines then the defect tracking system, Bugzilla, Test Track, Clear, Quest, etc. used. Although there is nothing stopping the plugin from using this information for something, it is primarily used for generating project documentation. Now we are considering the final. The Maven POM is big, however its size is also a testament to its versatility. The ability to abstract all of the aspects of a project into a single artifact is powerful, to say the least. Gone are the days of dozens of disparate build script and scattered documentation concerning each individual project. Along with Maven's other stars that make up the Maven galaxy, a well-defined build lifecycle, easy to write and maintain plugin centralized repository, system-wide and other user-based configuration, as well as the increased number of tools to make developers' jobs easier to maintain complex projects. The POM is a large but bright center. Now we are considering profiles in external files, in which areas of a POM can be customized by each type of a profile and why, and in introduction to build profile. Profile specified in external files, that is in settings.xml or profiles.xml, are not portable in strictest sense. The class with regarding API, the class settings in package maven.api.settings, the root element of the configuration file. Profiles in external files. Profiles specified in external files, that is in settings, so profiles.xml are not portable in a strict sense. Anything that seems to stand a high chance of changing the result of a build is restricted to the inline profile on the POM. Things like repository list could simply be a proprietary repository of approved artifact and won't change the outcome of the build. Therefore, you will only be able to modify the repositories and plugin repositories sections plus the extra properties section. The properties section allows you to specify free-form key value pairs, which will be included in the interpolation process for the POM. This allows you to specify a plugin configuration in the form of $open curly brace profile.path close curly brace. Now we are considering profiles in POMs. The profile specified in POMs can modify the following POM element. On the other hand, if your profiles can be reasonably specified inside the POM, you have many more options. Trade-offs, of course, that is that you only modify that project and its submodules. Since these profiles are specified inline there, and therefore they have a better chance of perceiving portability, it is reasonable to say you can add more information to them without risk of having information being unavailable to other users. Profiles specified in the POM can modify the following POM elements: repositories, plugin repositories, dependencies, plugins, properties not actually available in the main POM but used behind the scenes, modules, reports, reporting, dependency management, distributed management, a subset of built element which consists of default goal, resources, test resources, directory, final name, filters, plugin management, and plugins. POM element outside profiles. We don't allow modification of POM elements outside of POM profiles because this runtime modification will not be distributed when POM is deployed to the repository system, making the versions built of that project completely unique from others. While you can do this to some extent with the options given for external profiles, the danger is limited. Another reason is that the POM info is sometimes being reused from the parent POM. External files such as settings.xml and profiles.xml also do not support element outside the POM profiles. Let us take a scenario for elaboration. When the effective POM is deployed to an remote repository, any person can pick up its info out of the repository and use it to build Maven project directly. Now imagine that if we can set profiles in dependencies which are very important to a build and any other information outside the POM profiles in the settings.xml, the most probably we cannot expect someone else to use the POM from the repository and be able to build it. And we have to also think about how to share the settings.xml with others. Note that too many files to configure are very confusing and very hard to maintain. Bottom line is that since this is built data, it should be in the POM. Now we are considering bill of materials BOMs on POMs. Imports are most effective when used for defining a library in POMs, and the other projects have wished to use the library should import this POM into dependency management section in their POM. Imports are most effective. So in the API, we can consider class dependency management in package open.apache.maven.api model section for management detailed dependency information. Imports are most effective when used defining a library of related artifacts that are generally part of multi-project build. It is fairly common for one project to use one or more artifacts from these libraries. However, it has sometimes been difficult to keep versions of the project using artifact in sync with the version distribution library. Pattern below here allows how build of materials BOM can be created for use by other projects. The root project is the POM. It defines versions of all artifacts that will be created in the library, and other projects that wish to use the library should import this POM into dependency management section in their POM. The parent subproject has the POM as its parent. It is a normal multi-project POM. And the next, the actual project's poms. Sorry. The project that follows shows the library that can be used in another project without having specifically dependent on versions. Finally, when we create projects that import dependencies, beware of the following. Do not attempt to import POMs that define a submodule of the current POM. Attempt to do this will result in failing, since it won't be able to locate the POM. Never declare POMs importing a POM as parents or grandparents, etc. of the target POM. There is no way to resolve the circuitry, an exception will be thrown. When referring to artifact, those POMs have transitive dependencies. The project needs to specify versions those artifacts are as managed dependencies. Not doing so result a build failure, since artifact may not have been version specified. This should be considered the best practice in any case, at least keep versions of artifacts from changing from one build to next. Sorry, here this one DOM, and here artifact. Here the this one, and the and here the artifact ID is project 1 here. Now we are considering guide to create create the prototype files and the prototype pom.xml in guide to create archetypes. Next, the component of the archetype to be created is create an example for a prototype pom.xml is here. Then the next the archetype to be created is the prototype pom.xml. Any pom.xml will do. Just don't forget to the set artifact ID and group ID variables $ open curly brace artifact ID close curly brace / $ open curly brace group ID close curly brace. Both variables will be initialized from the command line when calling archetype : generate. An example for a prototype pom.xml is here. Now we are considering injecting pom property, settings.xml in plugin configuration and injecting pom properties via settings.xml. In example, we have plugin parameter that should contain a user specific value. This parameter have a common format creative directory structure, but depend on knowing the directory of the install application or something. Here the project configuration is here. Here you can see the settings.xml. When Maven loads the project pom, it will pick up the activated profiles from the active profiles section of the settings XML, settings.xml file and inject properties declared within the profile. When pom is interpolated, the application dash home property will already been injected, so it will allow the plugin parameter value to be resolved. Now we are considering project the project descriptor pom pom requirements in a introduction in Mojo API. The pom must declare a packaging element which describe this project as a Maven plugin project. Here you can see a packaging Maven dash plugin. With regarding API, we can consider the method at non-null public model.builder packaging string packaging in class model.builder in package model. Now we are considering pom code conventions in XML in Maven code style and code conventions. The following is the recommended ordering of Maven pom files. The team has voted during the end of June 2008 to follow a specific pom convention to order pom element. The sequence of this vote is that the Maven project descriptor is no more considered as the reference for ordering. The following is the recommended ordering of Maven pom files. The comments: the project element is always on one line. The blocks are voluntarily separated by a new line to improve readingness. 3. The dependencies on in the dependencies in dependencies and dependency management tags have no specific ordering. Developers are free to choose the ordering, but grouping dependencies by topic like grouped ID, that is org opposite of Maven, is a good practice. This should be in one line, obviously. Error example, we can consider this one occurred in the environment with pipeline of a Java project and Git repository. Not found Maven pom file. Error unhandled. Not found. Maven pom file /home /vsds /work/1/s pom.xml. Finishing Maven pom.xml. Now we are focusing on Maven. Here you can see Apache Maven internal design architecture. This is Maven 4.x. Apache Maven is a project development, management and comprehension tool based on the concept of a project object model. Builds, dependency management, documentation creation, site publication and distribution publication are all controlled from the pom.xml declarative file. Apache Maven can be extended by plugins to utilize number of other development tools for reporting and build process. Here is a diagram that shows the internal design architecture of Apache Maven. Apache Maven modules are labeled in this colored boxes, and third-party modules are labeled in uncolored boxes here, and this one also. Here you can see a distribution. Distribution is connected to SLF4J-provider, SLA, and it is connected to SLF4J-wrapper, and also distribution is connected to embedder, and you can see here BOM, and embedder is connected to SL4J-wrapper and also connected to Compact, and Compact is connected to core, and core is connected to plugin -mp API, and core is connected to toolchain builder and settings builder and resolver provider. Toolchain builder is connected to toolchain model, and settings provider is connected to settings builder support, and and model builder is connected to builder support, and also connected to model transform and model and artifact. And here resolver provider is connected to repository metadata, and you can see here embedder is connected to commons CLI, and SL4J-wrapper is connected to SL4J API, and core is connected to shared utils, and shared utils is connected to Jansi, and plugin API is connected to Sisu, and inside it you can see a plugin API is connected to Perplex, and in Sisu you can see Plexus and Inject. Plexus is connected to Inject is connected to Juice, and Plexus is connected to class words, and inside the Plexus you can see class words, interpolation, sec dispatcher, Cyper and utils, toolchain builder, settings builder and model builder are connected to interpolation. Settings builder is connected to sec dispatcher, and resolver provider is connected to IMPL. Inside the resolver you can see IMPL, SPI, API and util. IMPL is connected to SPI and util. SPI is connected to API and util is connected to API. Here you can see a standard Maven directory layout. Having a common directory layout allows users familiar with one Maven project to immediately feel at home in another Maven project. The advantages are analogous to adopting a site-wide look and feel. Try to conform to this structure as much as possible. However, if you can't, these settings can be overridden via the project descriptor. Here you can see source main Java application and library sources. Here you can see source main resources. This is application library resources. Here you can see source main filters, resource filter files, and you can see source main web application sources. And here you can see source test Java test resource or test sources, source test resources, test resources, and source test filters, test resource filter files. Here you can see source IT integration test, primarily for plugins, source assembly descriptors, source site, and you can see and top level you can see you can find license.txt project license, notice.txt notices and attributions required by library and that the project depends on, readme.txt projects readme. At the top level, files descriptive of the project, a pom.xml file. Basically at the top level, the file descriptive of the project, a pom.xml file. In addition, there are textual documents meant for the user to be able to read immediately on receiving the source. Readme.txt, license.txt, etc. There are two subdirectories of the structure, src and target. The only other directories would be expected here are metadata like cvs.git or .svn and any subprojects in multi-project build, each of which would be laid out as here. As previous directories for metadata. The target directory is used to house all output of the build. The src directory contains all of the source material for building the project. Its site, project, its site, and so on. It contains a subdirectory for each type. Main for the main build artifact, test for the unit test code and resources, site, and so on. within artifact producing source directories, main, that is main and test. For the main, there is one directory for the language Java, under which normal package hierarchy exists, and one for resources. The structure which is copied to the target class path given the default resource definition. If there are other contributing sources to the artifact build, they would be under other subdirectories. For example, source main ANTLR would contain ANTLR grammar definition files. Here you can see a directory layout, project folder, then source and target. Then it's under source there are main, test, IT, and assembly and site. Under main there are Java resources, a web app, config, script, and filters here in this diagram. Under test, Java resources and filters here. Here you can see Maven life cycles and paces. Dark ones are the frequently used. Here you can see the all build paces of the default, clean, and site life cycles, which are executed in the order given up to the point of the one is specified. Here you can see clean life cycle, pre-clean, execute processes needed prior to the actual process cleaning. Clean pace, remove all files generated by the previous build. Post clean, execute processes needed to finalize the project cleaning. Here you can see default life cycle. Here you can see validate the project is correct and all necessary information is available. Here you can see the pace initialize build state. For example, set properties or create directories. Here you can see generate sources, generate any source code for inclusion in compilation. Paste process sources, process the source code, for example, to filter any values. Generate resources for inclusion in the package. Process resources, copy and process the resources into the destination directory ready for packaging. Compile the source code of the project. Paste here the process classes. Post process the generated files from compilation, for example, to do bytecode enhancement on Java classes. Generate test sources, generate any test source code for inclusion in compilation. Process test sources, process the test source code, for example, to filter any values. generate test resources, create resources for testing, process test resources, copy and process the resources into the test destination directory. Here you can see process test classes. So in this diagram, one process is missing, is called test compile after test process test resources. In test compile the test source code into the test destination directory. Then process test classes. Post process the generated text generated file from the test compilation. For example, to do bytecode enhancement on Java classes, the paste test, run test using a suitable unit testing framework. These tests should not require the code be packaged or deployed. Prepare package. Perform any operations necessary to prepare a package before the actual packaging. This is often result in an unpacked processed version of the package. Take the compile code and package it in its distributable format, such as a jar. Pre-integration test. Perform actions required before integration tests are executed. This may involve things such as setting up the required environment. Integration test. Process and deploy the package if necessary into an environment where integration tests can be run. And there's another page called post integration test. It's not shown here. Perform actions required after integration tests have been executed. This may include cleaning up the environment. And then verify. Run any checks to verify the package is valid and meets quality criteria. Then install the package into the local repository for use as a dependency in other projects locally. Deploy done in an integration or release environment copies the final package to the remote repository for sharing with other developers and projects. Here site lifecycle. The pages are here, and pre-site execute processes needed prior to the actual project site generation. Generate the project site documentation here, site, and post site execute processes needed to finalize the site generation and to prepare for site deployment. Site deploy the generated site documentation to the specified web server, and here you can see the pages. So here you can see in clean lifecycle, pre-clean is connected to clean, and clean is connected to post-clean. In default lifecycle, validate is connected to initialize is connected to generate resources, and it is connected to process resources, and it is connected to generate source. Initialize is connected to generate sources. Generate sources is connected to process sources. generates and process sources is connected to generate resources. Generate resources is connected to process resources. Process resources is connected to compile. Compile is connected to process classes. Process classes is connected to generate test resources. Generate test resources is connected to process test resources. Process test resources is connected to generate test. Process classes is connected to generate test sources. Generate test sources is connected to process test sources. Process test sources is connected to generate test resources. Generate test resources is connected to process test resources. Process test resources is connected to test compile. It's not shown here. Test compile is connected to process test classes. Process test classes is connected to test. Test is connected to prepare package. Prepare package is connected to package. Package is connected to pre-integration test. Pre-integration test is connected to integration test. Integration test is connected to post-integration test, not shown here. And post-integration test is connected to verify. Verify is connected to install, and install is connected to deploy. In site lifecycle, pre-site is connected to site, and site is connected to post-site, and post-site is connected to site deploy. As an example, we can consider this one, Maven clean deploy. In a build environment, use the following this command to cleanly build and deploy artifact into the shared repository. Here, the clean paste clean remove all files generated by the previous build, and in the paste deploy done in an integration or release environment, copies final package to the remote repository for sharing with other developers and projects. As an example 2, we can consider this one, Maven compile test compile. This is compile is plugin, and this is the goal, and this is called the paste test compile. This compile the test source code into the test destination directory. Here this is regarding packaging. The first and most common way is to set the packaging for your project via equally named POM element packaging. Some of the valid packaging values are Java, EAR, and POM. If no packaging value has been specified, it will default to jar. Each packaging contains a list of goals to bind up to a particular paste. Here we are considering the default to jar. As an example 3, we can consider this one, configure plugins. The second way to add goals to paces is to configure plugins with your project. Plugins are artifacts that provide goals to Maven. Furthermore, a plugin may have one or more goals wherein each goal represents a capability of that plugin. For example, compiler plugin has two goals, compile and test compile. The former compiles the source code of your main code, while the latter compiles the source code of your test code. Goals that are configured will be added to the goals already bound to the lifecycle from the packaging selected. If more than one goal is bound to a particular pace, the order is used is those from the packaging are executed first, followed by those configured in the POM. Note that you can use executions element to gain more control over the order of particular goals. For example, here the Modello plugin binds by default its goal uh, um, Modello Java uh, uh, to the generate sources pace. Note that the Modello Java goals generate Java source codes. So to use Modello plugin and have it generate sources from the model and incorporate that um, that into build, you would add the following this to your POM in the plugin section of build. You might be wondering why executions element is there. That is so that you can run the same goal multiple times with different configurations if needed. Separate executions can also be given an ID so that during inheritance or application phases during inheritance or the application of profiles, you can control whether goal configuration is merged or turned into an additional execution. When multiple executions are given that match a particular phase, they are executed in the order specified in the POM with inherited execution running first. As an example, we can consider this code segment related to profile activation. This is in file settings.xml. Profiles can be explicitly specified using dash p command line flag. This flag is followed by a comma delimited list of profile IDs to use. Profiles specified in the option are activated in addition to any profiles which are activated by their activation configuration or the activation profiles section in settings.xml. From Maven 4 onward, Maven will refuse to activate or deactivate a profile that cannot be resolved. To prevent this, prefix the profile identifier with an question mark, making it as optional. Here you can see the command here. Profiles can be activated in the Maven settings via the activate profiles section. This section takes a list of active profile elements, each containing a profile ID inside. Profiles listed in active profiles tag would be activated by default every time a project uses it. Here there are two examples of POMs share a common dependency and each has non-trivial dependency. This information can be put in a parent POM like this. This is the parent POM, The dependency management section is a mechanism for centralizing dependency information. When you have a set of projects that inherits from a common parent, it is possible to put all information about the dependency in a common POM and have simpler references to the artifacts in the child POMs. So you can see here group ID A, and here excluding C, exclusion C, and here group ID C, and here group ID A. So this is the parent form. As an exception example, we can consider this one occurred in environment with Sonar scanner for Maven. Here you can see scanning per project and etc. And here you can see Apache org.apache.maven.exception, default exception handler, get message here, and etc. As an error example, you can see here build failure and fail to execute goal org.apache.maven.plugins Maven archetype plugin 2.1 generate default CLI on project standalone POM directory. My app already exists. Please run from clean directory, etc. Here as an additional example, we can consider Maven OPTS, Maven underscore OPTS environment variable. This variable contains parameters used to start up JVM running Maven and can be used to supply additional options to it. For example, JVM memory settings could be defined with the value -xms 256m and -xms 512m. Now we are considering package org.apache.maven.api. Yeah. Now we are considering the class default Maven in package org.apache.maven. With here you can see the we are considering CLI Maven CLI options reference. You can see the option -am or dash also -make. If a project list is specified, also build project required by the list. Now we are considering running the core ITs in Maven core ITs. By default, the project just packages the test in an artifact. To actually run them, activate the run -its. This will subject the Maven version running the build to the integration tests. If you would like to test the different Maven distribution, you can also use the Maven home system property to specify the path of the Maven distribution to test, like here. Alternatively, you can just specify the version of the previously installed or deployed Maven distribution, which will be downloaded, unpacked and tested, unpacked and tested. To run it, IT is using embedded Maven 3.x. Additionally, activate the embedded profile. ITs that don't require to fork Maven can also run from the IDs using Maven project from the workspace if the Maven dependency is added to the test class path. If you are behind a proxy, use the system property proxy.host or proxy.port, proxy.user, proxy.pass, and proxy.non-proxy host to specify the required proxy setup for the ITs. Alternatively, set the system property maven.it.central to a URL of a local repository manager, anonymous authentication only, that proxies the required artifacts. Now we are considering artifact types. Here the archetype artifact ID is Maven archetype. The archetype to generate a sample archetype. Here you can see the maintained by the Maven project in available extensions. Here you can see the extension build cache. It's a Maven incremental build and cache, local and remote. Here the version we are considering version 1.0.0. The open source in outside Maven land, the extension notifier, a status notification will be sent at the end of the Maven build. Now we are considering available plugins. There are built and reporting plugins. Maven is at its heart the plugin execution framework. All work is done by plugins looking at for a specific goal to execute. Build plugins will be executed during the build and they should be configured in the build element from the POM. The reporting plugins will be executed during the site generation and they should be configured in the reporting element from the POM, because the result of reporting plugin as is part of generator site. Reporting plugin should be both internationalized and localized. You can read more about localization of the Maven plugins and how you can help. Now we are considering core plugins in supported by Maven project in available plugins. Here you can see plugin clean up after the build. With regarding the API, the field public static final lifecycle phase clean in enum lifecycle phase in package apache.maven.api.plugin.annotations. Now we are considering retired. Here the plugin ant generate and build file for the project. This is type in the type build and the version 2.10. Outside the Maven land, here the at Mojo host, formerly known as codehost.org, the plugin here the animal sniffer build signatures of APIs, JDK for example, and check your classes against them. Now we are considering creating and submitting a patch in developing Maven in the Maven Developer Center. We have a couple of guidelines when submitting contributions. The most convenient way to create a GitHub fork from the Git repository you are working with. When you have either completed or issued or just want to some feedback on the work you have done, create a pull request. We have a couple of guidelines when submitting contributions. Verify the status of the master branch on Maven CI. If it is not success, then first try to figure out the problem. Don't start with your own issue yet. You can use the Git bisect to figure out the problematic commit and help with committer to solve the problem. Create your branch from master, not from the tag. Otherwise, your patch is outdated the moment you create it and might not be applicable to the development head. If this was a new piece of work without a Jira issue, create a Jira issue for it now. Name the branch after the issue number. Branch name would start with Jira project ID ticket ID. Push your branch with the commits to your fork. Create a pull request to submit to a contribution. Shortly after, someone will review the pull request and give you a feedback on it. A short note: make sure that you follow our code style. Now we are considering why would I want to build Maven in building Maven. Building Maven or a plugin or any component yourself is for one of two reasons. To try out a bleeding edge feature or bug fix, issues can be found in Jira. To fix a problem you are having and submit a patch to the developers team. Now we are considering checking out the sources. All of the source code for Maven and its related libraries are managed in the ASF source code repositories. For details, see HTTPS this address. Now we are considering building Maven. The building a Maven plugin, no component in building Maven. Building a Maven plugin, no component is like any Maven build, like here. Running integration test before submitting a patch. It is advised to run the integration test, which are available in the run-its, then install. Now we are considering building Maven core. Until Maven 3.3, the Maven core build could be bootstrapped with the Ant build. This bootstrap has been removed in Maven 3.5. You need pre-built Maven to build the Maven from source. To do this, run the source directory here. The assembles will be created in Apache Maven and can be manually unzipped to the location where you would like to the resulting Maven installed. If you want to have resulting Maven directly copied to a directory, you can use the distribution target dir property here. Running the full Maven core integration test before checking in a change or submitting a patch to Maven core. It is required to run the core integration test using your local build of Maven. Run this one here, this command. Now we are considering enable Apache servers in introduction in committers and resources. You need to tell the Maven what your Apache username is. The Maven uses several servers configuration to deploy snapshots and releases on the Apache servers. You need to tell the Maven what your Apache username is. It is highly recommended to use Maven's password encryption capabilities for your passwords. To publish a snapshot of some part of Maven, your Apache LDAP username, your Apache LDAP password. To stage a release of some parts of Maven, your Apache LDAP username, your Apache LDAP password. Now we are considering developers conventions. XML code style in XML in developers conventions. The Maven style for XML file is mainly mainly indentation. Always use 2 spaces indents unless you are wrapping a new XML tags line, in which your case you should indent 4 spaces. Line breaks, always use new line with indentation for complex XML types and no line breaks for simple types. Always use a new line to separate XML sections, so blocks, for instance. In some cases, adding comments could improve the readability of blocks, for instance, or here. Here you can see a workflow, the workflow in Maven JIT convention. Workflow for SVN fork is something like here, and more quiet workflow is like here. Fails because someone else has already pushed to master. So fails because someone else has already pushed to master, and this creates some mergers. Fails, someone else has already pushed to master. This moves origin /master, and this reapplies your local changes on top of the origin /master. Here you can see introduction in making releases. Here the gpg -- key here. gpg -- key. Now we are considering other resources, for example, ASF development infrastructure information. Now we are considering downloading Apache Maven 3.9.4 in Maven User Center. Here you can see the system requirements. The Java Development Kit Maven 3.9 plus requires JDK 8 or above to execute. It still allows you to build against 1.3 and other JDK versions by using toolchains. Memory, no minimum requirements. Disk, approximately 10 MB is required for the Maven installation itself. In addition to that, disk space will be used for local Maven repository. Size of your local repository will vary depending on usage, but expect at least 500 MB. Operating system, no minimum requirement. Startup scripts are included as shell script, tested on many earlier Unix flavors and Windows batch files. Now we are considering installation in Maven in 5 minutes. After that, type the following in a terminal or in a command prompt. The Maven is a Java tool, so you must have Java installed in order to proceed. First download the Maven and follow the installation instructions. After that, type follow this command in a terminal or in a command prompt. It should print out your installed version of Maven, for example here. Depending upon your network setup, you may require extra configuration. If you are using Windows, you should look the Windows prerequest to ensure that you are prepared to use Maven on Windows. Now we are considering how do I make my first Maven project in Maven Getting Started Guide. On to creating your first project, in order to create the simplest of Maven project, execute this command from the command line. We are going to jump headlong into creating first Maven project. To create our first Maven project, we are going to use a Maven's archetype mechanism. An archetype is defined as an original pattern or model from which all other things of the same kind are made. In Maven, the archetype is a template of a project which is combined with some user input to produce a working Maven project. That has been tailored to users' requirements. We are going to show you how the archetype mechanism work now, but if you would like to know more about archetype, please refer to our introduction to archetype. On to creating your first project. In order to create the simplest of Maven project, execute the following from the command line. Once you have executed this command, you will notice a few things have happened. First, you will notice a directory named my app has been created for a has been created for a new project, and this directory contains the file name pom.xml that should look like this. Pom.xml contains the project object model for this project, and the POM is the basic unit of work in Maven. This is important to remember because the Maven is inherently project centric in that everything revolves around the notion of a project. In short, the POM contains every important piece of information about a project and is essentially one-stop shopping for finding anything related to a project. Understanding POM is important, and new users are encouraged to refer introduction to POM in the user manual in documentation. This is very simple POM, but it still displays a key element every POM contains. So let's work through each of them to familiarize you with the POM essentials. The project, this is a top level element in all Maven pom.xml files. Model version, this element indicates that version of the object model this POM is using. POM version of model itself changes very frequently, but it is mandatory in order to ensure stability of use if and when the Maven developers seem it necessary to change the model. Group ID, this element indicates the unique identifier of the organization or group that created the project. The group ID is one of the key identifiers of a project and is typically based on the fully qualified domain name of your organization. For example, log.apache.maven plugins is the designed group ID for Maven plugins. Artifact ID, this element indicates the unique base name of the primary artifact being generated by this project. The primary artifact for a project is typically a jar file. Secondary artifact is like bundles also use the artifact as part of their final name. Typical artifact produced by Maven would have the form, artifact, version, and the extension. For example, myapp dash 1.0 .jar. Version, this element indicates the version of the artifact generated by the project. Maven goes a long way to help you with the version management, and you will often see the snapshot designer designator in the version, which indicate that the project is in a state of development. Name, this element indicates the display name used for the project. This is often used to Maven's generated documentation. URL, this element indicates where the project site can be found. This is often used Maven's generated documentation. Properties, this element contains value placeholders accessible anywhere within the POM. Here the name. Name, this element indicates the display name used for the project. Here. This is often used in Maven generated documentation. And URL, this element indicates where the project site can be found. This is often used in Maven generated documentation. Properties, this element contains value placeholders accessible anywhere within the POM. And the dependencies, this element's children list dependencies. The cornerstone of POM. Build, this element handles things like declaring your project's directory structure and managing plugins. For complete reference of what elements are available for use, POM page refer to our POM reference in documentation. Let's go back to the project at hand. After archetype generation of your first project, you will also notice that following directory structure has been created. As you can see, the project created from the archetype has a POM, a source tree for your application sources, and source tree for your test sources. This is the standard layout for Maven project. Application sources reside in base directory /source /main /java, and test sources are in base directory /source /test /java, where base directory base open curly brace dir close curly brace represent the directory containing pom.xml. If you are creating Maven project by hand, this is the directory structure that we recommend using. This is the Maven convention. To learn more about it, you can read the documentation. And now that we have POM, some application sources and some test sources, you are probably asking. Now we are considering request a new Jira account and submit an issue in getting help. This is so what we can communicate with you while we work together on the issue. Requesting a Jira account is preferred if you are planning to contribute the project by coding or testing by longer time. This is so that we can communicate with you while we work together on the issue. Please use your real name and surname if possible in public name field. Links to your public projects, social and professional profile can be appreciated. You can also tell us a little about yourself and what you intend to use this account for. Such information is useful to verify that account is requested for real user, not a bot. Now we are considering what is a plugin in Introduction to Maven Plugin Development in Plugin Developer Center. The Maven Clean plugin is responsible for removing the target directory of a Maven project. Maven is really just a core framework for collection of Maven plugins. In other words, Maven's plugins are much of the real action is performed. Plugins are used to create jar files, create var files, compile code, test unit code, create product documentation, and on and on. Almost any action that you think of performing on a project is implemented as a Maven plugin. Plugins are central feature of Maven that allow for reuse of common build logic across multiple projects. They do this by executing an action, that is creating a var file or compiling unit test. In the context of a plugin description, the project object model POM plugin behavior can be customized to a set of unique parameters which are exposed by a description of each plugin goal or mojo. One of the simplest plugins in Maven is a clean plugin. Maven Clean plugin is responsible for removing the target directory of a Maven project. When you run Maven Clean, Maven execute the clean goal as defined in the clean plugin, and the target directory is removed. The clean plugin defines a parameter which can be used to customize plugin behavior. This parameter is called output directory, and it defaults to $project open curly brace project.build.directory closing curly brace. Here you can, we are considering your first mojo in your first plugin in your guide to developing Java plugins. A simple mojo, it is a simple mojo, and this is about as simple as mojo can be. And after the listing is a description of various parts of the source. I'm going to provide some description of the various parts of the source. This class abstract mojo in Apache Apache.Maven plugin. Abstract class to provide most of the infrastructure required to implement a mojo except for execute method. The listed here is a simple mojo class which has no parameters. This is about as simple as mojo can be, and after listing the class Apache, here the class org.apache.maven.plugin.abstract mojo provides the most of the infrastructure required to implement a mojo except for the execute method. The annotation at mojo is required and control how and when the mojo is executed. The execute method can throw org.apache.maven.plugin.mojo execution exception if a problem occurs. Throwing in this exception causes build failure message to be displayed. The getLog method defined in abstract mojo returns a logger object which allows plugin to create messages at levels of debug, info, worm, and error. This logger is the accepted means to display information to the user. Please have a look at the section, look at the documentation for more information. All mojo annotations are described in mojo API specification. Here says hi to the user. Now we are considering how it works in introduction. A regular Maven project usually invokes the reporting goals of a plugin by declaring such plugin in the reporting section of the pom.xml, as in this example here. When Maven site plugin is invoked, for example, Maven site command, the specified plugins are loaded and generate the method of each Mojo class that implements Maven report is executed. The generate method generates a document through the Maven Doxia sync API. This document is comprised of basic elements like title, heading, text, links, label, etc. This is where you will put the logic of your report assembling element based on the content of the Maven project. This document elements are passed to Doxia to generate HTML document, which itself gets wrapped into a Maven skin as specified in the projects .source/site/site.xml. The result produces an HTML file in the ./target/site directory of your project. Here you can see unit tests. Here you can see Maven plugin testing harness in unit testing your plugin. The abstract, you can see the class abstract Mojo test case in package Maven.plugin.testing. The Maven plugin testing harness is explicitly intended to test the Maven.reporting.abstract Maven report execute implementation. In general, you need to include Maven plugin testing harness as a dependency and create a Mojo test. By convention, the class extend the abstract Mojo test case. Required for Mojo lookups to work. Sorry, here. Here you can see verify plugin documentation in documenting your plugin. The Maven docck plugin can be run here. The Maven docck plugin checks that the project compiles with the plugin documentation standard. You should verify that all plugin documentation respects this standard. The Maven docck plugin can be run here. Now we are considering introduction in the Mojo API. Although the requirements on Mojos are minimal by design, there are still very few requirements that Mojo developers must keep in mind. Maven plugins can be written in Java. These are the things, and the Maven plugin can be written in Java or any other number of scripting languages. Plugin consists of one or more Mojos, each one being the implementation for one of the plugin goals. Note this document plugin goals. Although the requirement on Mojos are minimal by design, there are still very few requirements that Mojo developers must keep in mind. A Mojo can have a method named execute which declares no parameters and has a void return type. If this method throws an exception, that exception must either be a derivative of java.lang.runtime exception or a derivative of apache.maven.plugin.mojo execution exception. It goes without saying that in the letter case, the execute method must declare that it throws this exception. exception. Additionally, modules must declare a field for each goal parameter by they specify, and these parameter fields will be populated before execute method is called. 3. Finally, all modules must be accompanied by metadata in meta info maven plugin.xml describing parameters, lifecycle bindings, etc. This descriptor will be covered in more. You can get more information on these descriptors in documentation. Now we are considering configuring logging in Maven 3.1.x logging. Every entry in this file can be overridden via Maven's JVM system properties by using the -d flag in Maven _ OPTS, for example. To configure the logging with SLF4J simple, you can edit the properties in the $maven.home /config /logging simple logger.properties file. Please see the link reference of documentation for details. Every entry in the file can be overwritten via Maven's JVM system properties by using the -d flag in -d flag in Maven options here. For example, here you can see this Maven this one thread name equal true, and Maven goals will add the thread name to every logging line. This will add the thread name to every login line, and this will add the logger name to every login line. The default SL4J configuration for Maven is listed in the documentation, where you can see other useful property names to customize logging. Now we are considering build your extension in Maven 3 lifecycle extensions. Here, the create your extension class. Your extension must be a Sisu component. Therefore, mark it with the JSR 330 for all legacy plexus contain annotation. Here, the class abstract Maven lifecycle participant in Maven allows core extension to participate in the Maven build session lifecycle, and allow all build will pass before XXX and after XXX naming pattern to indicate what at what lifecycle point it is being called. Here the and after here. To create a Maven project with dependency on org.apache.maven :maven-core colon 3.9.4 and other dependencies. Here the Maven core here. Create your own extension class. Your extension must be a Sisu component. Therefore, mark it with JSR 330 or legacy plexus container annotation. Generate Sisu index files during the build of your extension jar. Always provided by the Maven core class loader. Dependency for the JSR 330 annotation, always provided by the Maven core class loader. Start be a machine. Ask beer to the machine. Here you can see the receipt for in how to upgrade the Plexus Java doc text to Plexus Java annotations. In your pom.xml, add the Plexus component annotations dependency. In your pom.xml, add the Plexus component annotations dependency. In your Java sources, replace Java doc tags with corresponding here the corresponding Java 5 annotations. Now we are considering how to use JSR 330 in plugins in using JSR 330 instead of Plexus Java annotations. Constructor injection. With the Plexus Lex, greatly simplified the testing. Let's take a look at an example plugin. If you want to look at this example project, you can find it in the Maven core ITs. The POM is a setup for JSR 300 300 with the java.inject dependency and java.index dependency and the Sisu Maven plugin. Configured to create JSR 330 component index. In addition, we added classical Maven plugin dependencies, Maven plugin API, and Maven plugin annotations to extend abstract mojo and use Java plugin test tools annotations associated with Java plugin plugin. Now let's look at the plugin code. You will notice that that were using constructor injection, which makes testing a lot easier. If you want to test your JSR 330 component, you do not need the container to instantiate the mojo. In this simple case, you can actually test the plugin without using plugin testing harness, because you can instantiate JSR 330 component and JSR 330 mojo directly and wire everything up manually using constructor. Construct ingestion with Plexus lacks greatly simplified testing. Say hello to the world, my little constructor injected component. Here you can see a basic sample in Maven repository, the package with the API, with the API we can consider the method at not null public model.builder repositories collection type parameter repositories in class model.builder in package apache.maven.api.model. Not recommended, this part. Now we are considering digging into central index with look in central index. Download and extract look binary table and launch it on the central index with Lucene format. For the download central index nexus Maven repository index.gx, download Maven index CLI, and unpack the index to row Lucene index directory. Download and extract the binary table and launch it on the central index with Lucene format. You need an old Luke version using old Lucene version, since Maven index 5.5.1 uses Lucene 3.6.2 for this. But with more recent Maven index releases, more recent Lucene version have been used. Now we are considering where do I set artifact extension in Maven Artifact with type handlers here above here. Maybe surprisingly the dependency to this very same artifact can be described in two ways. Maven pom, where you can declare your project parent project dependencies plugin and other, maps those elements into artifact coordinates with some extra logic. Also, this has consider for example the artifact org.project reusable test support 1.0 tests jar with this type with type handlers. Maybe surpassing the dependency to this very same artifact can be described in two ways. And the equivalent would be equivalent dependency would be here. Obviously different is presence of classifier in the first case, while in the second lack of it, but presence of type test dash jar in the other hand implies classifier of test. In both cases extension is jar. In first it uses the default value of this property, while the second type is type defined it. Not in this very case. Using the first way is somewhat explicit and is recommended way. Not so far for the cases when type handle carries some important extra information like some custom packing. packaging, where using type is more appropriate. Simply put in this case, the type test-jar is like an alias for ordinary jars with test classifier. Now we are considering the A-level metadata in metadata. The XML bits considered for this kind of metadata are only the artifact level metadata found in directory of artifact serves purpose of version discovery. This metadata contains a list of versions of given GA coordinates and XML bit considered for this kind of metadata only. Now we are considering Maven repository layout. The layout is responsible for translating the artifact coordinates into generic path, but is later used to construct the some URL, file path URL. It depends on context. Obviously, since Maven inception in 2002, the layout evolved as well. For simplicity, we will cover current layout, also known as Maven 2 or default, as since Maven 3.x release. The deprecated Maven 1 layout, also known as legacy, is not supported anymore. This above implies following: the repository contains a file that is not on layout, does not obey layout transformation rules discussed rules. The file is not addressable by the Maven coordinates. You cannot address that file in Maven, nor make it to download it using gav coordinates. Using some properties transformed, we can construct the following path if classifier is not present, like here. Or if classifier is present, you can use this path. So the example artifact can be noted as gav GAV and is translated to path as like here. And this is that is it. This applies to this algorithm, and above any artifact can be built up path segment that artifact is expected to be. Important note in this case, in case of locally installed artifact, those you built locally and invoked Maven install will use artifact based version property instead of version. The full-blown timestamp version are used by in remote repositories when the artifact is deployed. So this is the full tar file. Now we are focusing on local repository. The local repository is a directory on the computer where Maven runs. It catches remote downloads and contains temporary built artifacts that you have not yet released. Here you can see the diagram. This is a diagram which shows the defined flow in which Maven to resolve the dependency. Here you can see the step 1 is read. Maven core read project dot here pom.xml. This is related to Maven 1.x, but in the new version from 2.x this will be pom.xml. and then it will build then Maven core will check if artifact is in local repository, and then get artifact from remote repository again, and back again get artifact from remote repository. Then put downloaded artifact in local repository, and thereafter generate files. For example, create jar file here. Here in step 1, Maven core is connected to pom.xml, and Maven core in step 2 Maven core is connected to local repository, and step 3 Maven core is connected to remote repository, and HTTP is passed from during the interactions, and step 4 Maven core is connected to local repository. Here this is JVM1 and this is JVM2 is a web server here. Now we are considering how Maven locates artifact at build time. When building project, Maven implements a simple caching scheme. Artifacts are downloaded from the remote repositories on the internet, and then cached to the local repository. This figure shows an overall overview of procedure that Maven follows when allocating artifact at build time. When building a project, Maven locates required artifact, OSGI, bundles, color features, for example, required plugins, and so on, and as follows. The first place that Maven looks for an artifact is the local repository. That's title mark /.m2 repository, which is effectively cached where Maven stores the artifact it has already downloaded or found elsewhere. Then an artifact is not available in the local repository. Maven attempt to download its artifact from one of the repositories listed in its configuration. This repository list can include both internal and remote repositories. If the artifact is not available from the internal repository, the next repository try remote repositories accessible through HTTP or HTTPS. For here, when the Maven project is built locally using men install command, the project's Maven artifacts are installed into local repository. Here you can see local repository. Here $ user.home and mem.m2 repository. Step 1, here the local repository interact with repositories. Here the step 2 file. Here the file :/. Here the step 3 HTTP :// here. And in the step 4 Maven project is connected to local repository via build, and here you can see in the step 2 and 3 repositories are connected to local repository via Maven, and download. Here the Maven project is connected to local repository I have built install. Now we are considering how the container locates artifact at runtime. In this is a particular configuration at runtime. With Linux here, the runtime, the process of locating Maven artifact is implemented by Eclipse Ether library, which is bundled in Karaf container, so that it is not necessary for Apache Maven to be installed on the container host. It is possible to customize Karaf containers Maven configuration by editing etc org.ops4j.pax.url.mun.cfg. Now we are considering locating artifacts at runtime. This figure shows the mechanism for handling a Maven URL and resolving Maven artifact at runtime. The step followed to locate Maven required Maven artifacts are the resolution of Maven artifact is triggered when user invokes osgi:install command on the Maven URL, or if a user invokes the features install command on the feature that references some Maven URLs. To resolve the Maven URL, JVM callbacks on the protocol handler registered against the MUN scheme, which happens to be a pax URL ether component. Step 3, the pax URL ether component reads its configuration from the install dir /etc/ops4j.pax.url.mun.cfg file, and possibly also from a Maven settings.xml file if so configured. Pax URL ether layer passes the requested Maven URL and combines this information with the specified configuration in order to invoke the Eclipse Ether library. When the Ether library is invoked, the first step is to look up any local Maven repositories to try it and find Maven artifact. The following local repositories are configured by default. Step 4. Install directory /system, the JBoss Fuse system directory, which contains all the Maven artifacts that are bundled with JBoss Fuse distribution. The user home m.m2 /repository, the user's own local repository, and in the user's home directory, user home. If you like, you can customize list of local repositories to add your own custom Maven repository. If Maven artifact is found locally, skip locally. You can skip straight to step 7 here. In 5, if Maven artifact can't be found in the local repositories, Ether tries to look up specified remote repositories using list of remote repositories spied in the pax URL Ether configuration. Because the remote repositories are typically located in the internet, accessed through the HTTP protocol, it is necessary to have internet access for this step to succeed. Note, if your local network requires you to use HTTP proxy to access internet, it is possible to configure pax URL Ether to use HTTP proxy. 6. If the Maven artifact is found in the remote repository, Ether automatically install the artifact into the local, the user's local Maven repository, so the that the another remote lookup will not be required. 7. Finally, assuming that the Maven artifact has successfully resolved, Karaf install the artifact in Karaf bundle cache. Install introductory /data /cache and loads the artifact, usually the OSGI bundle, into the container runtime. At this point, the artifact is effectively installed in the container. Here you can see the Karaf console here. This is specific configuration in basically Red Hat. I'm showing this to show how the container locates artifacts at runtime with Maven. Here the Karaf console is here, the step 1 here. Here the OSGI install Maven, and step 2 here Maven etc. And Karaf console is connected to PAX URL ether, and step 3 the PAX URL ether is it interacts with etc ops4j.pax.url.men.config here. You can see local repository equals and default repositories and repositories settings, etc. And this CFG interacts with title.m2 settings.xml Maven settings file. For the Eclipse ether stateless, it interacts with system directory, custom repository, and Maven local Maven repository. Here the system directory is here karaf.home /system. Here custom directory path to custom repository here, and local Maven repository here user home, and then m.m2 / repository. Step 5 here the Eclipse ether stateless is connected to HTTP proxy remote Maven repositories here. Step 6 here the is connected to Maven local Maven repository, and here step 7 the install the Karaf bundle cache is connected to Karaf bundle cache via install. Here you can see how Maven dependencies work. The image here show how Maven dependencies workflow during entire build process. Each step represented by arrow moved the dependency from one point to next. The step is run by the phase execution. Maven dependency management come from the pom.xml file inside project's root folder. Dependencies list is written in the pom.xml. Here you can see with regarding dependencies, here the other repositories are connected to local repository via compile paste, and here the Maven center repository is connected to local repository via compile paste, and here the /.m2 the local repository, and local repository is connected to project's target /target project's folder via package phase, and project folder is connected to local repository via install paste. As an example, we can consider Maven install in the paste install. Install the package into the local repository for use as a dependency in other projects locally. Here you can see local repository. This value is the path of this build system's local repository. The default value is $user.home then .m2 then repository. This element is especially useful for a main build server, allowing all logged in users to build from a common local repository. This is in settings.xml file. So in interactive mode, true if Maven should attempt to interact with user for import. False if not, default to true. Offline, if this build system should operate offline mode, default to false. This element is useful for build servers which cannot connect to a remote repository, either because of network setup or security reasons. As an example 3, we can consider this one, include custom library into Maven local repository. Here download the captcha extract, download the captcha, extract it and copy the captcha dash $version jar to somewhere else, for example C drive, and run this command. Then captcha, the captcha jar is installed, copied into your local into our Maven local repository. Now we are considering interface local repository in package.maven.api. The local repository is used to cache artifact downloaded from the remote repository and hold artifacts that have been built locally. Now we are considering base version artifact property in Maven local repositories. As noted in the layout page in the documentation, locally built and installed implies the local repository artifact use base version while calculating layout. Hence, in this case, both base version and version of them will both contain same value. One editing with snapshot contains constant string, no transformation is applied to the file name. Snapshot pulled from remote and cached in local repository have the timestamped version property instead. Hence, they will have the full blown timestamp version applied to the name. Now we are considering settings in settings. Settings, the root here the root element local repository, the root element of user in the settings, the root settings the element local repository, the local repository in settings, the root element of the user configuration files. The default value is the this one user home /m2 /repository. The type is string. With regarding API, we can consider method at not null public settings.builder local repository string local repository in class settings.builder in package org.apache.maven.api maven.api.settings. Here we can consider some CLI Maven CLI options reference. Here the option -LLR or -legacy -local -repository. This is unsupported and use of this option will make Maven invocation fail. And here we are considering plugin, considering supported by Maven project in available plugin. Is the plugin install the build artifact into the local repository. This is type build and source repository is git/github. With regarding API, we can consider the field public static final lifecycle phase install in enum lifecycle phase in package org.apache.maven.api.plugin.annotations. Now we are considering how do I create jar and install it in my local repository. Making a jar file is straightforward enough, and that can be accomplished by executing the following command here. You can now take a look in the base directory /target directory and you will see the generated jar file. Now you will want to install the artifact you have generated the jar file in your local repository. user.home/m.m2/repository is the default location. And do so, execute following command here. Upon executing this command, you will see the following output. Note that the Surefire plugin, which executes the test, contained in files with a particular naming convention. By default, the test include **test.java and **test.java and **test.case.java, and the default excludes **abstract-test.java and **abstract-test.case.java. You have walked through the process for setting up, building and testing packaging and installing a typical Maven project. This is likely vast majority of what projects will be doing with the Maven, and if you notice, everything you have been able to do up to this point has been driven by the 18-line file, namely the project model of POM. If you look at the typical and build file that provide the same functionality that we have achieved thus far, you will notice it is already twice the size of the POM, and we're just getting started. There is far more functionality available to you from Maven without requiring any additions to our POM as it currently stands. To get any more functionality out of this example and build file, you must keep making error-prone additions. So what else you can get for free? There are a great number of Maven plugins that work out the box with even a simple POM like we have. Using this example, we will without any work on your part, this POM has enough information to generate a website for your project. We are not showing the POM here. It's a simple POM, and you will most likely want to customize your Maven site, but if you are pressed for time, you will need to provide basic information about your project is execute the following command. There are plenty of other standalone goals that can be executed as well. For example, here, this will remove the target directory with all built data before starting so that it is fresh. So scanning project here. Nothing to compile, all classes are up to date here. Here the tests running com.mycampaign.app test here. Here the results with the building jar, and here build success. Here we are considering guide to installing third-party jars. To install a jar in the local repository, use following command. Occasionally, you will have third-party jars that you need to put in your local repository for use in your build, since they don't exist in any public repository like Maven Central. Jars must be placed in the local repository in the correct place in order to be correctly picked up by Apache Maven. To make this easier or less error-prone, we have provided an install file goal in the Maven install plugin, which should make this relatively painless. To install a jar in the local repository, use the following command. If there is a POM file as well, you can install it with the following command. With version 2.5 of Maven install plugin, it can get even simpler. If a jar was built by Apache Maven, it will contain a pom.xml in subdirectory of metadata meta-inf directory, which will be read by default. In this case, all you need to do is this. Here the path to file, and here the group ID and artifact ID here, the version and packaging here. Here the path to file, and here the path to pom file. Here the path to file. Here we are considering configuring your local repository. In configuring Maven, the default value is $sign user.home user.home /.m2 /repository. Note the local repository must be an absolute path. With regarding API, we can consider the method at not null public settings.builder local repository string local repository in class settings.builder in package apache.maven.api.settings. Now we are considering I have a jar that I want to put into my local repository. How can I copy it in with regard to sequencer's technical question? If you are not confident about the layout of the Maven repository, then you can adapt the following command to load in your jar file in all on one line. If you understand the layout of the Maven repository, you can copy the jar directly into where it is meant to go. Maven will find this file next time it is run. If you are not confident about the layout of the Maven repository, then you can adapt this command, following command to load in your jar files all in one line. Path to file, group ID, artifact ID, version, packaging, and here the packaging. Example we can example we can consider this one. Here the local class local repository not accessible exception signals a failure to store files within a local repository, and this is in package org.apache.maven.repository. And here you can see could not create local repository at /test artifacts from /m2 repository. And as an error example, we can consider this failure to execute goal on project X could not resolve dependencies for project X, failure to find Y in archive repository was cached in the local repository. Resolution will not be reattempted until the update interval of internal has elapsed or update are forced. Now we are focusing on remote repository. Remote repositories refer to any other type of repository accessed by a variety of protocols such as file : / and https : / These repositories might be a truly remote repository set up by a third party to provide their artifact for downloading. For example, repo.maven.apache.org. Other remote repositories may be internal repositories set up on a file or HTTP server within your company, used to share private artifacts between development terms and for releases. Here you can see this is a diagram which shows the defined flow in which Maven to resolve the dependency. Here you can see Maven read there should be a pom.xml and then build it. Then check, then Maven core check if artifact is in local repository. Then here the get artifact from remote repository, and put download artifact in local repository, and then generate in the core generate files or create jar. So here Maven core is connected to pom.xml here. This is the older version. So in 1.x this is project XML. Here 1.2 and onward it will be pom.xml. Then in step 2 here Maven core is connected to local repository, and step 3 Maven core interact with remote repository to HTTP, and step 4 Maven core is connected to local repository, and this is in JVM1 and this is in JVM2 the web server. Here you can see Maven repository architecture. Maven follows a two repository model, wherein it maintains a local repository which is created when you execute the first Maven command. It downloads the dependencies from the remote repository into this local repository, and then builds projects. Architecture looks like here, and Maven project is compiled. It check the local repository for dependencies. If dependencies do not exist, Maven download them from the remote repository. Once dependencies are downloaded, they are installed once the dependencies are downloaded, they are installed in the local repository. Once all dependencies are met, Maven compile the code and the project. Here Maven project is connected to local repository. Default location $user.home/.m2/repository, and local repository connected to remote repository here, and Maven is connected to remote repository and local repository. Downloads is connected to, passed from Maven to remote repository, and install is passed from Maven to local repository. Here you can see Maven central repository. This is for to use and contribute to Maven central repository. This include that need dependencies for their own build core project that wish to have their releases added to the Maven central repository. Even if they don't use Maven as their build tool. Discontinue support for TLS version 1.1 and below as of June 15th of 2018, and discontinue support for HTTP as of June 15th 2020. Here you can see users. Maven is connected to local repository, plugin repository, and here Maven is connected to a local repository, and here Maven is connected to dependent public repositories. POM file is passed from Maven to independent public repositories, and this is repository and plugin repositories, and in independent public repositories include JBoss and others. And Maven is connected to central CDN, and central default is passed from Maven to central CDN, and Maven is connected to here mirrors and repository manager. Settings.xml is connected to passed through Maven to mirrors and repository manager, and mirror of command is here. Sorry, a mirror of tag is there here, and repository manager is connected to private data and central repository and independent public repositories. Cache is passed from the central repository manager to central repository and independent public repositories. In central repository is here, and aggregation is passed passed to central data, and central data is connected to central CDN and mirrors. Publication is passed from central data to central CDN and mirrors, and here you can see central archetype catalog and central index. Inside mirrors you can see here iBiblio, Google and Google, and rsync deprecated is passed from central repository to public project dedicated staging repositories. Here you can see XY and etc. And push is passed from public Forges multi-project staging repositories to central repository. You can see Apache, OSSRH, and etc. and public Forges multi-project staging repositories. Here this is the diagram which shows the defined flow in which Maven to resolve dependency. Here you can see the local repository. If dependency found, it will then retrieve dependency. It move to switch connected to retrieve dependency, and local repositories, if dependency not found, is connected to central repository, and if dependency is found in central repository, it is connected to retrieve dependency, and if dependency not found, central repository is connected went through remote repository defined whether or not, and if it is defined, then it is connected to remote repository. If it is not, it's connected to unable to find dependency. And here also if dependency is not found in remote repository, is connected to unable to find repository, and remote repository, if dependency found, is connected to retrieve dependency. Here you can see Maven 2 repository layout. Maven 2 repository layout format is the default layout since Maven 2, superseding old Maven 1 layout, where here the group ID as directory is group ID with dot replaced by /. For example, org /maven apache.maven, here $sign after artifact ID is the artifact ID. The version is the version with some additional possibilities on a snapshot. Extension is the file extension, for example zip or tar.gs. Classifier is the artifact classifier when available, and checksums is a list of checksums algorithm MD5 and SHA-1 by default. Maven metadata.xml file format is defined in Maven repository metadata module. .asc file is optional, may be requested in some repository like center repository, and is PGB detach signature file. Obviously a group ID, artifact ID, and version are defined in pom.xml, but what about classifier and extension? How they defined? Classifier and extension definition is completely different at artifact publication and usage times. At artifact publication time, extension and classifier are defined by plugins that create the artifact and attach them for publication. Some plugins provide configuration parameters to be able to override default values. For example, Maven jar plugins jar::jar goal produces by default an artifact with jar extension and empty classifier. The classifier goal parameter can be used to define classifier. There is no parameter to override the extension. At artifact usage time, extension and classifier are defined by dependency type and classifier definition in pom.xml. Here type jar by default define an extension and classifier, and classifier is optional to override default classifier defined by dependency type. Here you can see the central repository. It is one place centralized management of the Java library that was distributed and published on many sites. It is open to the internet and is available to everyone, and many Java build tools are standard reference destinations. By the way, it seems that the library developed by itself can be published in Maven Center repository. However, you will need to apply register library in the repository. Here you can see in the step 1 project A and project B and application and his module library, and here it's just the two here the local library, inside it Maven libraries are there, and here the step here the 3 the host 1 is connected to repository, interacts with remote repository, inside it Maven libraries are there. Here the host 1 is interacts with host 2, and host 2 is interacts with remote repository here. Via here the example.com. For the host 1 interacts with host 3 via example.com, and host 3 interacts with remote repository here. Here the host 1 interacts with the host 4. Here the repo.maven /org/maven2/ here. Host 4 this 4 Maven 2 interacts with center repository, and it has Maven libraries here. Here you can see the Maven in remote repository, local repository, and remote center repository are connected via Maven here. These repositories interacts via Maven here. Here you can see there are 3 types of repositories in Maven. Maven does a lot of things behind the scenes. Before going to the concept of repositories, one should know about the relationship between Maven development environment and Maven repository. Maven repository explains about the Maven archetypes and types of repositories. Maven gets the knowledge from the repository, which has 2 types of information: archetype information and dependency information. Archetype is a model that defines a structure of a project. Archetype information has a different types of project being created for the structure and the information about project. Maven initially generate archetype and get all the required information about the project being done. When mvn archetype generate command is in run in the command prompt for the first time, all the plugins are downloaded and gives the list of archetypes and information about the application. The input given to the archetypes are classified into 5 types: archetypes, group ID, artifact ID, version, and package. Archetype is the information given to Maven about the type of the project needed. Archetypes will differ based on the application to be developed. There are archetypes for J2E applications, Spring applications, Hibernate application, etc. In Maven repository, archetype is a good starting point for each application. Artifact ID is used to identify the output like files like Java and ER. Group ID is the exploratory ID used to group all the artifact IDs and give the identification to it. Version has a default snapshots, which is a piece of code to be released. Package is the location of source code. Based on the inputs provided, the Java class in the archetype will be assigned to Java class. There are 3 types of repositories in Maven: local repository, center repository, and remote repository. Central repository and remote repository. The searching sequence of dependencies in this repository will be the same. Initially, the local repository in the local repository, then the central repository, and then the remote repositories if given in POM file. The local repository contains the downloads of dependencies. Downloading one is enough even if there are multiple projects. Own projects can be developed in a local repository using install command. Local repository is placed in user's home directory by default. The location can also be changed using settings.xml. Here the XML settings, the local repository. Then, for example, give the path. And by default, the Maven searches for central repository for dependencies. There is no special setup required to use the central repository. The remote repository downloads the dependencies from a web server. It can be anywhere in the internet and even inside the local network. This repository helps in sharing the projects among organizations. To configure the remote repository in POM files, please follow the code. For example, it's called the XML repositories, then repository, then ID and the ID, then URL, then URL. Key points: Maven repository is a combination of archetypes and dependencies. Archetype gives the structure of the project. Local, central, and remote are 3 types of repositories. Maven always check the dependencies in the local repository. Here you can see the Maven local repositories and Maven remote repositories are inside organization internal network. Here the local repositories local repositories interacts with Maven remote repository. Here the organization local network interacts with internet, and internet interacts with the Maven central repository. Here you can see the repository order. Remote repository URLs are queried in the following order for artifacts until one returns a valid result. The effective settings, then a global settings.xml, then user settings.xml, the local effective build pom, the local pom.xml, parent poms recursively, and super pom, then the effective poms dependency path to the artifact. For each of these locations, the repositories within the profiles are queried first in the order outline in the order in the build profile. Before downloading from a repository, mirrors configurations is applied. If the effective settings and local build pom with profile taken into account can easily be reviewed to see their properties or order with mun help effective settings and mun help effective setting effective pom and -d verbose. Using an internal repository, using the internal repository is quite simple. Simply make a change to add the repository's element. If your internal repository requires authentication, the ID element can be used in your settings file to specify logging information. Here deploying third-party jars to remote repository as an example 2. To deploy third-party jar, use the deploy file goal under Maven deploy plugin. First, the Vagrant, for example, Vagrant provider, Vagrant FTP, Vagrant file, etc., must be placed to your $Maven $open brace maven.home close brace /lib. Then execute this command here. As an example 3, we can consider this one: http://report.1 maven.org./maven2/. This is the default repository for central repository. If the site is not available, finally it can be redirected to http://search.maven.org. Now we are considering interface remote repository in package org.apache.maven.api, a remote repository that can be used to download or upload artifacts. Now we are considering deploying snapshot artifact in base version artifact property in Maven remote repositories. So in case of snapshot deploy, version version transformation happen in form of this. Your pom locally usually contains a snapshot version in the form of a string and ends with snapshot. constant string, for example 1.0 snapshot, but in case of deploy, this version is being transformed to a timestamped snapshot on the fly by Maven, and when you check the deployed result, you will see the artifact files does not end up with snapshot anytime, but timestamp and builder number. Also during the deploy, Maven will deploy required Maven v5 level metadata as well, that will describe for consumers the snapshot how to reverse this process. In case of snapshot deploy, a version transformation happens in form of this, where the date in etc UTC time zone used in YYYMMDD.HHMMSS format is constant across deploy from the same session each time when Maven session is created, and the counter is increased from the previously deployed metadata, or if no remote metadata exists, is initialized with 1. Consuming snapshot artifact, if your project depends on snapshot dependency, the pom of your project usually contains version and value that ends with snapshot. For example 1.0 snapshot. Still we as we see above, remote repositories do not contain such versions, but only timestamps ones. Maven snapshots are moving targets, hence during resolution Maven will use the deployed metadata first to figure out Maven base version to version timestamp mapping, and only then will fetch the required files. In case of consuming snapshot, following transformation happens. Due to this interaction, the real file name of artifact, the version part, is figured from deployed Maven repository metadata. The snapshot artifacts are moving target. Each snapshot deployment has will deploy new metadata. Hence, we'll alter this transformation here. Maven will download different snapshot artifact. Note, it is possible to lock down snapshot artifact by using timestamp version in version field of the dependency, and will ensure Maven downloads always the same artifact. Is not moving target anymore, but Maven will still consider that dependency as snapshot, and all the fine print tuples, for example release plugin, will refuse to release such snapshot such a project. Now we are considering the attribute distribution management in the project in Maven. This element is the root of the descriptor. The attribute distribution management attributes distribution information for a project that enables a deployment of the site and the artifact to remote web servers and repositories effectively. Type distribution management. Regarding API, the class distribution management in package API.model. This element describes all the pertains to distribution for a project. Is primarily used for deployment artifact and site produced by build. Deployment repository contains the information needed for deploying to the remote repository, which contains which adds a unique version property to usual repositories for download. With regarding API, we can consider class repository, the in package org.apache.maven.api.model. The repository contains the information needed for establishing connections with remote repository. Snapshot repository deployment repository contains the information needed for deploying to the remote repository, which adds a unique version property to usual repositories for download. With API, we can consider at non-null public distribution management.builder snapshot repository, deployment repository, snapshot repository. in-class distribution management.builder in package Apache.maven.api.model. Repository. The repository contains the information needed for establish connection with remote repository. Plugging repository. A repository contains the information needed for establishing connection with remote repository. Element repositories / repository asterisk the many in settings. Settings the root element of the user configuration file. This element many lists the remote repositories. This is a type list with type parameter repository. With regarding API, we can consider a class repository in package Apache.maven.api.settings. Repository contains the information needed for establishing connections with remote repository. Now we are considering Maven CLI options reference. Here the option -u and -update -snapshots forces a check for missing releases and updated snapshots on remote repositories. Now we are considering supported by Maven project in available plugins. The plugin deploy the built artifact to the remote repository. This is type is built. With regarding API, we can consider public static final life phase deploy in enum lifecycle phase in package Apache.maven.api.plugin.annotations. Now we are considering how do I deploy my jar in my remote repository in Maven getting started guide. Here is an example of SCP and username password authentication. For deploying jars to an external repository, you have to configure the repository URL in the pom.xml and the authentication information for connecting repository to the repository in the settings.xml. Here is example of using SCP and username and password authentication. Note that if you are connecting to an open SSH server which has the parameter password authentication set to no in the sshd_config, you will have to type your password each time for username and password authentication, although you can log in using another SSH client by typing the username and password. You might want to switch to public key authentication in this case. Care should be taken if using password in settings.xml. Default value is title /.ssh/id DSA. Default is here title /.ssh./id _DSA. Now we are considering guide to deploying third-party jars to remote repository. Then execute this command. Some concept of the install file goal of the Maven install plugin, where third-party jars are installed in the local repository, but this time instead of local repository, they will be installed both in the local repository and remote repository. To deploy the third-party jar, use use deploy colon deploy file goal under Maven deploy plugin. First, the vegan provider, vegan -ftp, vegan dash file etc. must be placed in your Maven home /lib. Then execute the command here. Here the group ID and here artifact ID, here the version, type of packaging, path to file, ID to map on the server section of settings, URL of the repository to deploy. Deploy a third-party jar with the generic pom. To disable this feature, you should set the generic pom argument to false. By default, deployed deploy file generate generic pom to be deployed together with third-party jar. To disable this feature, we should set the generate pom argument to false. Now we are considering deploying third-party jar with the customized pom. Deploying third-party if the pom is already existing in third-party jar, you want to deploy it together with the jar, we should use the pom file argument to deploy file goal, deploy dash file goal. See the sample here. Note that group ID and artifact ID and version and packaging argument are not included here because the deploy file goal will get this information from the given pom. Here the path to pom, path to file, ID to map on server section of the settings.xml, URL of the repository to deploy. Now we are considering deploying source jars. To deploy third-party source jars, packaging should be set to java-source and generate pom should be set to false. Now we are considering guide to remote repository access through authenticated HTTPS. Now we are considering how to configure Maven access to remote repository. That site sits behind the HTTP server, which requires a client authentication and with certificates. The problem is there is a Maven repository of HTTP colon my.server.com /Maven. This server only serves client authenticated through SSL protocol by valid certificate signed by the approved certificate authority certificate, which can be called CA cert. In the simplest case, where the server is used to internally by the identified community of users, for example corporate intranet, the server certificate is a certificate authority as the server is used only internally. So we assume that we access the trusted certification of x.509 format stored in a file named here. Client certificate has been issued by some means not described in here in PKCS #12 format, which is the format that is accepted by browser, at least Firefox and Internet Explorer for import into their key store. This file is named here, and we assume that it is accessible when launching Maven. This file contains client's private key which may be sensitive information, so it is secured by a password. The remote repository reference either through pom.xml file here. Solution for Maven to use this repository, we take the 2 steps: create a store to hold server certificate using Oracle's key tool, and define properties to be used by HTTP client for finding certificates. the storing certificates, for this command, the following command line imports the certificates authority certificate into JKS formatted key. A keystone named trust.jks, the trust store. Note that it should possible to import the full chain of certificates with only one root certificate being trusted, but author did not test it. Setting properties, the following properties must be set at the start of Maven to be accessible with HTTP client startup. javax.net.ssl.truststore, the path to the key store where trusted certificate are stored. javax.ssl. This is trust store, and other one is javax.ssl.truststore type. The type of the storage for this store may be either JKS default or PKCS12. javax.ssl.ssl, the javax.net.ssl.truststore password, the password protecting the store. javax.net.ssl.key store type, a key store, the path to the key store where users private key is stored. javax.net.xsl.key store type, the type of storage of this store may be either JKS default or PKCS. javax.net.xsl.key store password, the password protecting the store. Not all the properties must be set depending on the precise settings. Type of the store may left to default, password may empty. They may be set either on Maven's command line in .maven nrc file or in maven_opts environment variable. For setting the define in this document, here is an example .maven rc file. As an error example, we can consider this one occurred with the environment grail 2.5.x .x. An error occurred while processing Maven artifact task diagnosis. Error downloading Wagon provider from remote repository missing org.apache.maven.wagon.colon Wagon http://jar:1.0 beta 2 etc. Now we are focusing on site. The site plugin is used to generate a site for the project. The generated site also includes the project's reports that were configured in the POM. Here you can see a main website mechanisms overview. Here you can see the source SCM, https://gitbox.apache.org/repos./asf/maven*.git https://github.com/apache/maven*.git, and here you can see source edit, git box or git hub, main site source, git, maven site.git, and you can see this is local edit and it's connected to Maven main site, target forward slash site. It's a Maven site is MEN site is passed from local edit to Maven local main site, and here source edit is connected to site production. Jenkins https // build.apache.org /job /maven box /job /maven site / and Maven MEN site is passed from source edit to or main site source edit source git to site production svn. And here site production svn is connected to complete Maven site. svn nv pub sub is passed from site production svn to complete Maven site, and this is https //maven.apache.org, and it's equal Maven site content. Composition by symbolic links created with and from components link plus components documentation archive / latest plus versions plus current. The main site content component documentation is staging / xxx archives /yy latest. Component documentation / xxx archives /yy $version / xxx /yy and HTML svn for svn pub sub https //svn.apache.org repos /asf /maven /website /content https svn.apache.org repos asf maven /website components. Since December 2012, the overall website uses svn pub sub mechanism, and main website uses Apache CMS. Here you can see Maven site plugin developer overview. Doxia to pass many markup languages, then render HTML. Doxia site tools. Here site renderer. Site renderer to integrate documents. To integrate document content into template packaged as skin. Maven reporting executor to manage reports execution, since Maven 3 execution was managed by Maven itself in Maven 2. And here you can see Maven here. Here, and shared components are here, and Doxia are this 1 2 3 4 6 and this was this one, and Doxia site tools are these are Doxia 5 site tools. velocity is not a part of Doxia here. Here the Maven is connected to Maven plugin API. Maven is connected to Maven site plugin and report plugins, and it's go through Maven API, Maven plugin API, and when invoked directly as goal, when Maven is connected to report plugins here, and Maven site plugin is connected to markup parsers, integration tool, and reporting API. Handwritten contents are passed from Maven site plugin to markup parsers. Reporting exe is passed from Maven site plugin to reporting API, and report plugins contains reporting API and reporting IMPL. And report plugin is connected to Doxia sync API. Report content is passed from report plugins to Doxia sync API. Integration tool is connected to decoration model here. Doxia sync API is connected to Doxia module, and Doxia module has markup parser, and also basically Doxia sync API is connected to Doxia module markdown, Doxia module XHML, markup renderer, XML markup renderer module is there, and inside that markup parser is in Doxia module, and markdown markup parser equal flexmark equal HTML render is in Doxia module markdown. XML markup parser is in Doxia module XHTML. Here XHTML markup renderer is connected to site renderer. Site renderer is connected to velocity. Site renderer is interact with velocity, and velocity interact with skins, reusable templates, and it is connected to site output is equal contents per template. Skins are connecting with skin module, and here velocity is not part of Doxia, so other white boxes are part of Doxia. And also this is markup pass is not part of Doxia. Here you can see a component reference documentation overview in documentation mechanisms overview in deploy Maven website. Since December 2012, the overall website uses SV and pub sub mechanism. Here how component reference documentation publication works. Component don't use CMS. Component reference documentation are versioned and generated from full sources with both handwritten like Maven main source and content generated from sources Javadoc, unit test results, integration test results. Referenced documentation is the staging component reference documentation. The reference documentation of a component is staged in https://maven.apache.org/xxx-archives/yyyy-latest where YYY is the component name and XSS can be a component type like shared plugin skins, or a component name for standalone component like archetype, plugin tools, Surefire, Vegan. To publish component reference documentation, one prerequest eventually build the component if it has not been done previously, or some reports may misbuilt or integration information. Notice in cases where you haven't prepared the release, you can simple change into target /checkout directory and continue with to mun -p run -its install to build reference documentation. Here the mun -p reporting site colon stage. Notice the site colon stage is really necessary only for multi-modules components, but added unconditionally in this instruction to keep them as straightforward as possible. 3. Stage the reference documentation to website production SVN area using Maven -svn -publish -plugin. Here you can see the SVM mun scm-publish publish -scm. SVM publish sub mechanism transfer the SVN production content to live production live production site. Notice the content is in fact published to /components directory, and symbols like declared in resources /component and dot links in the mains resource are used by AND to create reference from /xxx to /component /xxx. Publishing, now we are considering publishing version component reference documentation. When doing releases, YYY latest YY-latest content stage in previous section needs one to be archived to version directory before a newer version is published into latest. To replace the actual component reference documentation. This is done with operations on website production SVN area. You can use component reference documentation helper to easily prepare SVN MUCC command line. If you prefer to do everything by hand from command templates, you can do either with the SVN command, Unix SVN pub sub equal HTTPS etc. and in Windows also set SVN pub sub equal SVN HTTPS etc. With SVN MUCC command, you can use SVN MUCC -m then other required parameters. Updating index page in Maven site. Some component types have an index page referring to each component of the same type. This is the case. This is the case for plugins in index plugins. Shared POMs and skins. Update the version number and release the date for component in content apt. Content /apt/xxx/index.apt page. Notice if you forget about updating index page, dist dash tool has report run daily that will gently send a failure notification or notification at Maven when checked errors. Report is not empty. Here you can see component source SCM and here digit for the YY. Then it is connected to local component doc via MVN -p reporting site, multimodule MVN site colon stage, and local component doc target /site in multimodule target /staging, and local component doc is connected to component documentation staging SVN via MVN SCM-publish publish -SCM. Component documentation staging SVN /component /xxx -archives /YYY -latest is connected to a complete Maven site via SVN pub/sub. And here component documentation staging SVN is connected to component documentation documentation SVN via SVN CP -latest the version here SVN RM /YYY CMCP $version /YYY etc. And here the component /xxx -archive $YYY $version /component /xxx The component documentation SVN is connected to complete Maven website via SVN pub/sub. Here you can see SVN source SCM https /gitbox.apache.org /repos /asf /maven *git here for https /github.com /apache /maven *maven.git. Here you can see HTML SVN for SVN pub/sub. Here the https /svn apache.org /repos /asf /maven /website /content. https /svn.apache.org /reports /asf /maven /website /components. Here the source SVM and here the HTML SVN. Here the you can see in complete Maven website component documentation staging and component documentation and main site content are there. Here the component document staging here and /xxx -archives /YYY -latest. Here the component documentation /xxx -archives /YYY $version /xxx /YYY, and here main site / and here the complete Maven site https /maven.apache.org. Here the equal main site content. Here composition by symbolic link created with add from components links plus component documentation archives /latest plus versions plus current. Here you can see site lifecycle. The phases are here. Here you can see the pre-site execution execute processes needed prior to actual project site generation. Here site generate the project's site documentation. Here post-site execute processes needed to finalize the site generation and to prepare for site deployment. Here site deployed, deploy the generated site documentation to the specified web server. Here so you can see site lifecycle bindings, paces, and plugin goals. Here you can see site, and here site dash deploy, here site colon deploy. Here you can see a graphical representation of lifecycle execution. Here the pre-site, this phase execute the processes before the actual site. The site, this phase execute the actual site documentation process. Post-site, this phase execute the processes required to finalize the site generation and preparation for site deployment. Site deploy deploys the specific site generated documentation into the web server. Note the executing one phase in the life cycle, which result to execute all previous phases prior to that phase. If we invoke site command maven site dash it or maven site, it will execute pre-site and site phases. Sequential execution of site commands maven pre-site, it will execute the pre-site command maven site. It will invoke the pre-site and site both. Maven post dash site, it will invoke the pre-site, site, and post-site all together. Maven site dash deploy, this command will execute pre-site, site, post-site, and deploy site. Maven site Maven site colon site goal is usually referred to as the site phase. Maven's site colon deploy goal is referred to as site colon deploy goal. Typically maven clean site is used to clean and generate new documents. Maven clean site dash deploy is usually maven clean site dash deploy is usually used to clean the project site and deploy it. Here you can see pre-site is execution sequence. Pre-site is connected to site is connected to post-site, post-site is connected to site deploy. Here you can see site lifecycle. You can see the process pre-site, site, post-site, and site deploy. And here you can see the bindings, Maven site plugin here, site, and Maven site plugin here, the colon deploy. As an example, we can consider Maven site. This is to generate project site and reports. By default, the resulting site will be in the target /site / directory. Here you can consider deploying a site. To be able to deploy a site, you must first specify where the site will be deployed. This is set in the distribution management element of the POM shown here. The ID element defines the repository so that you can attach credential to it in your settings.html file using servers element as you would for any other repository. The URL gives the location to deploy to. In this example, we copy the host www.yourcompany.com using the path www/docs/project over SCP protocol. You can read more about which protocols with the documentation. If subprojects inherit the site URL from the parent POM, they will automatically append their artifact ID to form their effective deployment location. Now you can execute the site site colon deploy goal from your project directory. Note, site must be generated first before executing site colon deploy. If you want to generate the site and deploy in it one go, you can utilize site dash deploy phase of the lifecycle. To do this, just execute Maven site dash deploy. Here we can, as an example 3, we can consider this example. This example shows how to configure the standard project info reports that display information from POM in a friendly format. Maven has several reports that you can add to your website to display the current state of the project. These reports take the form of plugin goals, just like those used to build the project. The Maven project info reports plugin provides many standard reports by extracting information from the POM. For example, continuous integration, dependencies, issue tracking, license, mailing list, project team, source repository. To add these reports to your site, you must add the plugin to the reporting element in the POM. If you have included appropriate menu ref equal reports tag in your site descriptor, then you can generate the site. Those items will appear in the menu called project reports. Not many reports plugins provide a parameter called output directory to or similar to specify destination for the report outputs. This parameter is only relevant if the report plugin is run standalone, that is by invoking directly from the command line. In contrast, when reports are generated as part of the site, the configuration of the Maven site plugin will determine the effective output directory to ensure that all reports end up in a common location. Now we are considering class site in package org.apache.maven.api.model contains the information needed for deploying websites. Now we are considering goals overview in Apache Maven site plugin. The site plugin has 7 goals. Site is used to generate site is used to generate the site for single project. Note that the links between module sites in the multi-module build will not work, since local build directory structure doesn't match deployed site. Site deploy is used to deploy generated site using Wagon supported protocol to the site URL is specified in the distributed management section of the POM. Site run start the site up rendering document as requested for fast editing. It uses Jetty as the web server. Site stage generates the site in a local staging or mock directory based on the site URL specified in the distribution management section of the POM. It can be used to test that tested link between module sites in a multi-module build work. This goal requires the site to already have been generated using the site goal, such as by calling Maven site. Site stage dash deploy deploys the generated site to a staging or mock directory to a site URL specified in distributed management section of the POM. Site attach dash descriptor adds the site descriptor site.xml to the list of files to be installed or deployed. For more references of the site descriptor, look for the documentation. Site jar bundles the site output to a jar so that it can be deployed to a repository. Site effective dash site calculates the effective site descriptor after inheritance and interpolation. Now we are considering generating a site in usage. To generate the project site and reports, execute Maven site here. With API, we can consider public static final lifecycle site in enum lifecycle phase in package or maven.api.plugin.annotations. By default, the resulting site will be the target/site/directory. Note, if you have multi-module project, then the link between the parent and child modules will not work. When you use mun site or mun site:site, if you want to use those links, you should use mun site:stage instead. You can read more about goal further later. More about goals in the documentation. Note, for performance reasons, Maven compares the timestamps of generated files and corresponding source document and only generates the document that have changed since the last build. However, this only applies to documentation source documents, apt, xdoc, etc. If you change anything in your site.xml, any relevant section in your pom or any relevant properties or source files, you should generate the site from scratch to make sure all references and links are correct. Now we are considering deploying a site. This is set in the distribution management element of the pom as shown here. To be able to deploy a site, you must first specify where the site will be deployed. This is set in the distribution management element of the pom as shown here. The ID element identifies the repository so that you can attach credentials to it in your settings.xml file using servers element as you would for any other repository. The URL gives the location to deploy to. In this example, we copy the host www.mycompany.com using path www.docs/project over SCP protocol. You can read more about which protocol. This is your company. More about for which protocol are supported in the documentation. If subprojects inherit the site URL from the parent pom, they automatically append the artifact ID from their effective deployment location. Now you can execute the site:/deploy goal in your project directory. Note, site must be generated first before executing site:/deploy. Here the mun site:/deploy. If you want to generate a site and deploy it in one go, you can realize site-deploy phase of the site life cycle. To do this, just execute mun site-deploy. Now we are considering staging a site. Just execute the site:/stage goal from your project. To review or test the generated website and before an official deploy, you can stage the site in a specific directory. It will use distributed management element or the project hierarchy to list the projects in its modules. Just execute site:/stage goal from your project. Here the mun site:/stage. Note, the site must be generated first before executing site:/stage. By default, the site will be staged in a directory target /staging /. A different staging location can be chosen with the staging directory. Parameter as shown here. Note, the staging directory cannot be dynamic. That is, staging directory equal $base directory /full site. To stage the site and deploy it, execute site:/stage-deploy goal from your project with the required parameters. The site colon stage dash deploy goal will use the value of distributed management dot site dot id as the default id to look up the server section in settings.html, sorry, settings.xml. Unless this is not defined, then the string staging site will be used as id. So if you need to add your username or password separately for staging stage dash deploy in settings.xml, you should use id staging site for the server section. By default, the site will be staged dash deploy to assign distributed management dot site dot url / staging / different location can be chosen with the staging site url parameter as shown here. Note, a site must be generated first before executing stage colon site dash deploy. Now we are considering running a site. To do this, execute this. Site plugin can also be used to start up the site in Jetty. To do this, execute this. The server will by default be started on http colon / localhost colon 8080 / running a site only work for single module sites. To preview a multi-module site, one should use site colon stage. Now we are considering rebuilding a published released site. To solve that problem, you first need to configure your project for reproducibility by setting the project.build.output timestamp model property. In general, site documentation is published as part of a release. This means that changes to the documentation depend on a new release before being visible, or you must accept that documentation refers to a snapshot version instead of the latest release version. To solve that problem, you first need to configure your project for reproducibility by setting the project.build.output timestamp model property. Then branch off from the CM tag you want to modify. Perform the changes, commit them, and rebuild. Finally publish updated site. Underline Maven Doxia site tools will automatically inject the property as publish date, velocity, context property in the site, and skin won't render a newer current date but use this one. Check out publish date IT for configuration details. Now we are considering internationalization in creating content in examples. To enable multiple locations, multiple locals or languages, add the configuration similar to the following to your POM. Internationalization in Maven is very simple as long as the reports you are using have that particular local defined. For an overview of supported languages and instruction on how to add further languages, please see the documentation. To enable multiple locals, add the configuration similar to the following in your POM. This will generate both the English and French version of the site. If EN is your current local, then it will be generated at the root of the site with a copy of the French translation of the site in the fr / directory subdirectory. To add your own content for that translation, instead of using the default, place a subdirectory with that local name in your site directory and create a new site descriptor with the local in the file name, for example here. default version, French version, and default site descriptor, the French site descriptor. Now we are considering creating content in creating site. Let's take a look at the examples of various document type here. For the first step to creating your site is to create some content. In Maven, site content is separated by format, as there are several available. You will notice there is now base directory /src /site directly, within which contains the site.xml site descriptor along with the various directories corresponding to the supported document types. Let's look at the examples of the various document types. APT, the APT format, the almost plain text, is the wiki like format that allows you to write some simple structured document like this one very quickly. A full reference of the APT format is available. Markdown, the well-known markdown format. FML, the FML format is the FAQ format. Xdoc, an XML document conforming to a small and simple set of tags. Other formats are available, but at this point these four are the best tested. There are also several possible output formats, but as of Maven site plugin, only XHTML is available. Note that all of the above is optional. Just one index file is required in one of the input trees. Each of the path will be merged together to form the root directory of the site. Now we are considering customizing look and feel. If you want to tune the way your website looks, you can use the custom skin to provide your own CSS styles. If that is still not enough, you can even tweak the output templates that Maven uses to generate the site documentation. You can visit skins index to have in the documentation to have the look at some skins that you can use to change the look of your site. Now we are considering generating the site. Generating the site is a very simple and fast. Here by default the resulting site will be in target /site etc. Now we are considering deploying the site. To be able to deploy the site with the classical network protocol FTP, SAP or WebDAV, you must first declare the location to distribute it to it in your pom.xml, similar to the repository for the deployment. The ID element identify the repository so that you can attach the credential to it in your settings.xml file using servers element as you would for any other repository. The URL gives the location to deploy to. Currently the only SSH is supported by default, as above copied the host www.mycompany.in in the path and /www/docs/project, but you can add more protocols as required. The subprojects inherit the site URL from the parent POM. They will automatically get the artifact ID append to form their effective POM effective deployment location. One distribution location, once the distribution location is configured, deploying the site is done by using the site-deploy pace in the site lifecycle, MEN site-deploy. Here now we are considering creating site descriptor. The site.xml file is used to describe the structure of the site. The sample is given below. Note that menu ref equal reports element here when building the site, Um, uh, when building the site, this is replaced by a menu with link to all the reports that you have configured. Um, uh, Now we are considering adding extra resources. Additional CSS files will be picked up when they are placed in the CSS directory with the resources directory. You can add any arbitrary resources to your site by including them in resources directory as shown here. Additional CSS files will be picked up when they are placed in the CSS directory within the resource directory. The file site.css will be added to the XML, to the default XML output, so it can be used to adjust the default Maven style sheet if desired. File the pic1.jpg will be available via a relative reference to the images directory from any page in your site. Now we are considering configuring reports. The following example shows how to configure standard project information reports that display the information from the POM in a friendly format. Maven has several reports that you can add to your website to display the current state of the project. These reports take the form of plugins, just like those used to build the project. There are many standard reports that are available by gleaning information from the POM. Currently, what is provided by the default are dependencies report, mailing list, configure continuous integration, resource repository, issue tracking, project team, license. To add these reports to a site, you must add the project info reports plugin to the special reporting section in the POM. The following example shows how to configure the standard project information reports that display information from the POM in the friendly format. If you have included appropriate menu ref equal reports tag in site XML script, then you can regenerate the site. Those items will appear in your menu. Many other plugins provide reporting goals. Look for R reporting value in the typed column in the list of plugins in the documentation. When plugins are both built and reporting plugins, defining explicitly for version of the reporting section is usually not necessary, since the reporting will use the version from build/plugin or build/plugin management. Since the Maven site plugin 3.4 reporting plugin also get configuration from build/plugin management. Not many report plugins provide a parameter called output directory or similar to specify the destination for their report outputs. This parameter is only relevant if the report plugin is run standalone, that is by invoking directly from the command line. In contrast, when reports are generated as part of the site, the configuration of the Maven site plugin will determine effective output directory to ensure that all reports end up in a central location. Define version here if not already defined in build/plugin or build/plugin management. Now we are considering internationalization. Enable to multiple locals to add the configuration symbol to the following here. Internationalization in Maven is very simple as long as the reports you are using have that particular local defined, and To enable the multiple locals, to add the configuration symbol to the following in your POM. This will generate both English and French version of the site. If EN is your current local, then it will be generated at the root site of the root of the site with the copy of the French translation at the site in the site fr directory. To add your own content from that translation, instead of using default, place a subdirectory with that local name in your site directory and create a new site descriptor with the local in the file name, for example here. Default version, French version, default site descriptor, French site descriptor. Now we are considering maintained by Maven project available skins. The skin here, the Maven default skin. You get this skin if you don't specify any skin or template. Now we are considering outside the Maven land, the skin reflow Maven skin, responsive Apache Maven skin to reflow the standard Maven site with a random with a modern field. Here the instructions, for example, to use Maven Fluido skin, you would include this in your site.xml. Classed in the API class skin model in octa.apache.doxia.site skin. The skin element is the this is the one the skin here, the skin element. The skin element is the root of the skin descriptor with the API. Now we are considering site in Maven, the attribute child.site.url.inherit.append.path. When children inherit from the distribution management site URL, append path to not while the type of this field is for technical reasons the string. For technical reasons, semantic type is actually Boolean. Default value is true, and this is from the Maven 3.6.1, and this is type string. Now we are considering Maven archetypes. This is the archetypes artifact ID Maven dash archetype dash site, and archetype to generate a sample Maven site which demonstrates some kind of support document types like APT, Markdown, XDoc, and FML, and demonstrate how to I18N your site. Now we are considering supported by Maven project available plugins. The Precis plugin site generate the site for the current project. This is the type build. Now we are considering supported by Maven project available plugins. The plugin scm-publish your Maven website to a scm location. This is type build. Now we are considering running Maven tools in Maven in 5 minutes. This is generating site. This page generates the site based upon the information on the project's POM. You can look at the documentation generated on the target /site. Now we are considering the APT format, the document structure in APT, the APT format. A short term, the short APT document is contained in the single text file. The longer document may be contained in ordered list of text files. For instance, first text line contains section 1, second file contains section 2, so on. Not splitting the APT document in several text files on section boundary is not mandatory. Split may be occur anywhere. However, doing so is recommended because the text file containing a section is by itself a valid APT document. File contains a sequence of paragraphs and displays non-paragraphs such as tables separated by open lines. A paragraph is simply sequence of consecutive text lines. the indentation of the first line of the paragraph is the main method used by the APT processor to recognize the type of the paragraph. For example, section title must not be indented at all. The plain paragraph must be indented by certain amount of space. For example, a plain paragraph which is not contained in the list may be indented by 2 spaces here. Indentation is not rigid. Indentation is not rigid. Any amount of space will do. You don't need you don't even need to use consistent indentation all over the document. What really matters is for the APT processor is whether the paragraph is not indented at all, or when inside the list whether the paragraph is more or less indented than the first item of the list. Note that the tabs are expanded with the tab width set to 8. The first line of the first paragraph, second line of the first paragraph, third line of the first paragraph, the line 1 of the paragraph 2 separated from the first paragraph by an open line. The line 2 of the paragraph, this my section title not indented, is the paragraph first line indented by 2 spaces. This first paragraph has its first line indented by the 4 spaces, then the author did not even bother to indent the other lines of the paragraph. The second paragraph contains several lines which are all indented by 2 spaces. This style is much nicer than the one used for previous paragraph. Now we are considering block level elements in the title in block level elements in document elements. If the title is optional, if used, it must appear as the first block of the document. The title block is indented centering. It is nicer. It begins with the line containing at least 3 dashes. After first 3 dashes line, one or several consecutive lines of text implicit line break after each line specify the title of the document. This text may immediately followed by another 3 dashes line, and one or more several consecutive lines of the text specify the authors of the document. Each line represents an individual author. The author subblock may optionally be followed by a date subblock using the same syntax. The following example is used for document with this example is used for document with a title and a date, but no declared author. The last line is ignored. It is just 3 there to make a block nicer. Note that the date has no specific format, and it will be passed as a string. But we recommend to use the ISO-8601 standard since formatting a date varies around the world. That is y-mm-dd. There is where YY is the year of the Gregorian calendar, mm is the month of the year between 01 January and 12 December, and DD is the day of the month between 01 and 31. Now we are considering APT in snippets documentation. The snippets in documentation. As of the Doxia-core version 1.0 alpha 9, a file parameter also available. if the full path is not specified, the location is assumed to be the relative to $sign due to the base directory. Macros in apt must not be indented. Exactly one of the URL and or file must be specified. Since docshare-co 1.0-alpha-9, now we are considering how do I create a documentation in Maven getting started guide to get you to jump start with the Maven documentation. Maven's documentation system, you can use the archetype mechanism to generate the site for your existing project using the following command. Now we are considering site distribution in distribution management in environmental settings in POM reference. More than distribution to the repositories, distribution management is responsible for defining how to deploy the project sites and documentation. The name, ID name and URL, these elements are similar to their counterparts in the distribution management repository element. Now we are considering handle special characters in a site in frequently asked questions. Configure the reporting output encoding in POM here, like here. Configure your ID to use the correct encoding with Eclipse. Add -d file.encoding equal ISO -8859-1 in Eclipse ini file. Configure the reporting output encoding in POM. Or default encoding is overridden in the parent POM that you can't change. Configure the site plugin explicitly. Configure the file encoding used by MEN. Add to Maven underscore PT or PTS the encoding same as the ID. This can be made with adding Maven underscore options equal double quotation -d file.encoding equal ISO -8859-1 double quotation in $home /profile. Now we are considering determining the output directory for the site report. Multi-language site generation is another scenario to exploit this bug, which is illustrated below here. Here the class abstract Maven report in org.apache.maven.reporting. The basis for Maven report, which can be generated both as part of the site generation or as a direct standalone goal invocation. Both the invocations are delegated to abstract execution report local from Mojo's execute method, C Maven plugin API or Maven multi-page reports. Reports generate skin factory local. You can see the Maven report API. Maven reporting plugins from abstract Maven report. In doing so, you need to implement the inherited but abstract method get output directory. To implement this method, plugins usually declare the field name output directory, which may return in the method. Nothing wrong so far, but now some plugins need to create additional files in the report output directory that accompany the report generated via the sync interface, while it is tempting to use the either method get output directory or the field output directory directly in order to set up a path for the output files. This leads most likely to a bug. More precisely, those plugins will not properly output files when run by the Maven site plugin as part of the site lifecycle. This is best noticed when the output directory for a site is configured directly in the Maven site plugin such that it deviates from the expression $, here the project reporting.output directory. That plugin is used by default. Multi-language site plugins, site generation is another scenario to exploit this bug, which is illustrated below here. There are in principle two situations in which the report mojo could be invoked. The mojo might be run directly from the command line or the default build lifecycle, or might be run directly as part of the site generation along with other report mojos. This glaring difference between these two invocation is the way to output directory is controlled. In first case, parameter output directory from the mojo itself is used. In the second case, however, the Maven site plugin takes over control and will set the output directory to its own configuration by calling Maven report set report output directory on the reports being generated. Therefore, developers should always use Maven report.get output directory method if they need to query the effective output directory for the report. The implementation of abstract Maven report.get output directory is only intended to intended as the feedback in case the mojo is not run as part of the site generation. Parameter default value is here. This assumes the mojo parameter reflects the effective output directory as used by the Maven site plugin. As an exception example, we can consider this. Here fails to execute goal, etc. And this is artifact resolution exception, unable to locate site descriptor, could not transfer artifact parent project XML site _en : 1.0.141.1 from to Eclipse and etc. As an error example, we can consider this error occurred in the environment with Maven site 3.2 and Java 3.3 and Java 1.8. Warning error injecting. This is a warning also. ogda.apache.maven.report.projectinfo.ci management report. Java lang.no class found error. org/apache/maven/doxia/ site renderer/ document content. This is end of my presentation. Thank you very much for watching.